Intro. Right. Correct. Andaka image ihan gaya. Okay, we'll start. Good evening. Online, how about the audio and video? We'll start. Right, it's fine. So I know, right. We'll start. Okay. Right. So we are in the fourth seminar day we are conducting for your batch, right? Fourth practical seminar, I mean. Fourth practical seminar, right? So far we have done mechanics, right? Then we had another one for waves, optics, and today we are doing thermal, and we'll be doing another one for electricity as well, right? Hurry. Then other plan in thermal, we have 6 experiments now after all revisions, right? After all the recent revisions, right? Then all the experiments which involved with mercury was removed, right? And now we only have 6 experiments remaining, right? So we'll be discussing all 6 starting from here, right? Online ones, you can go to the pinned message here, and there's a link mentioned. That's a Telegram link. Go there, and you can download the soft copy, right? If needed. So otherwise, if you already have the guide, right? So this is actually same as the guide, right? හැබැයි ඒක නෙමෙයි ඉතින් discuss කරන්නේ. ඒක දන්නවනේ. guide එකේ තියෙන එක තමයි ඕක දාලා තියෙන්නේ. Right? But we'll be discussing everything that is relevant for answering questions and understanding the practical, right? අර නිකම්ම guideline එක විතරක් නෙමෙයි. අනිත් ඔක්කොම ටික අපි කතා කරන්නේ නැද්ද කතා කරමු. Right. ඔයගොල්ලෝ ගත්තේ දැන්ද ටික? සඳිල් නැද්ද? හරි. Right, listen. So now we are in a period where we are just 9 weeks from the exam, right? Now today is Sunday, no? After this, that is exactly 9 weeks after today, right? Again, seminar given 9 weeks, right? එතකොට දැන් මේවා ආයි බලන්න ටයිම් එකක් එන්නේ නැහැ, right? Now when you learn these things today, right, you won't get any time to like go through these things again in detail, right? Just 9 weeks no. එහෙම ටයිම් එකක් එන්නේ නැහැ. එතකොට කෙලින්ම අද සෙමිනාර් එකේදීම ඕක කරලා ඉවර කරගන්න. නැත්නම් එහෙම ආයෙ අර පස්සේ කරනවා කියලා තියාගන්න එපා. especially online ones recordings එකෙන් බලන්න ඉඳාගෙන ඉන්නවා නම් think about it again, because the effectiveness is not there when you are watching the recording later on. again මෙච්චර ටයිම් එකක් එක නෙමෙයි ඕක බලන්නේ. ඒතර quickly බලයි සමහරට miss වෙයි. ඒතකොට වෙන්නේ කොහොමද? අපි දන්නවනේ thermal කියලා කියන්නේ that's a definite experiment you are getting in the exam, right? Question number 2. Question number 2, right? So I think make hiring එකක් එනවා කියලා දන්නවනම්, if you know that one out of these 6 is going to come in the exam, right? So that is not something to miss out, right? කෙලිම plan කරලා ගිහිල්ලා ගන්න පුළුවන්, right? plan කරලා ගිහිල්ලා ගන්න පුළුවන් ලකුණු තියෙන්නේ. ඒ නිසා මේ අර ආයි මේක පස්සට කල් දාන්න එපා. Don't postpone this, right? Understand everything here, then and there, and by the time you leave the seminar, right, then you will be able to write any question from these 6 experiments, right? That's the purpose, right? That's the purpose, right? Okay, we'll start. Go to practical 1. Go to practical 1, right? Go to practical 1. Write down practical 1. Determination of relationship between pressure and absolute temperature. This is called pressure law, verification of pressure law. Pressure and absolute temperature, right? අපි මේක ලේසියට කියන්නේ verification of pressure law, right? අපි ලේසියට කියන්නේ verification of pressure law. Verification of pressure law. Verification of pressure law, right? First, let's take out the theory part. Right. What is pressure law? Verification of pressure law කියලා කියන theory part එක pressure law. What is pressure law? Pressure of an ideal gas, constant volume of constant moles of an ideal gas is proportional to absolute temperature, right? Open pressure law කියලා කියන්නේ. ඔය එන්නේ මෙතනින්. Right? We know for any ideal gas, PV over T is a constant, right? PV over T is a constant. Pressure law is valid in constant volume, right? මතකයිනේ, pressure law is valid in constant volume. When volume is constant, right? When volume is constant, this is also constant now. P over T becomes K over V. This whole thing is a constant if volume is also constant, right? This whole thing is constant, right? Which means P over T is a constant. Then P equals KT, right? Which means P is proportional to T. මෙන්න pressure law එක. P is proportional to T, right? කොහොමද pressure law ගන්නේ? කියනකෝ නේද? කියනකෝ. Right. මේක තමයි pressure law එක. මේක verify කරගන්න යන්නේ. Right? Okay. Now, as a theory, write this down, right? Theory එක ලියාගන්න. සෙට් එක ගන්න. හොඳයි. සඳිල්ලද? හරි. මේ එක්ස්ට්‍රා සඳිල්ල දෙන්න. Right. Oh, maybe. Yeah. Right. So what here? मैं වැඩක් කරන්නේ. Right. ලිය ගන්න තාම ඉවර නැද්ද? Okay, listen. As an experiment, what we are doing here is a simple thing, right? As an experiment, what we are doing here is a simple thing, right? Listen. පොඩි apparatus එකක් තියෙන්නේ. මෙහෙමයි වෙන්නේ. Listen, this is a beaker, right? Filled with water. This is kept on a tripod or a stand, right? And this is called a round bottom flask, right? There's a reason to be round bottom. Why it is must be round bottom, right? And this is a capillary tube. For this capillary tube, a pressure gauge is connected. For this capillary tube, a pressure gauge is connected. For this capillary tube, a pressure gauge is connected. Right? This is filled with water like this. And to change the temperature, we have a burner here, Bunsen burner. Right. Now, simply what we are going to do here is this. Listen. Right. Listen. Now, inside this flask, round bottom flask, right? Inside the flask, if we are not opening from this point or this point, there's a constant amount of gas inside, no? Right? Because in order to prove this, we have to have a constant volume. Right? And volume එක වෙනස් කරන්න බෑනේ. Volume එක වෙනස් කරන්න බෑ. ඉතින් volume එක තියෙන්නේ මේක ඇතුළේ. Now the gas is inside this. Listen. Gas එක තියෙන්නේ මෙතන. Right? And from here that is not closed. මේක දිගෙත් gas එක යනවා. Gas එක මෙතනට ගිහිලා එහෙමනේ pressure gauge එක වැඩ කරන්නේ. Right? ඔහොම තමයි gas එක තියෙන්නේ. But with respect to the volume of the container, right? This is a very small tube, capillary tube, right? To minimize the percentage error. Right? එහෙම නැත්නම් දැන් මම මෙතන volume එක මේකනේ heat කරන්නේ. Because we are going to heat this gas. When Bunsen burner is heated, liquid can water around the burner will be heating. When water gets heated, because of the thermal conductivity of this glass here, gas inside is going to get the heat because of the thermal conductivity. නිකන් ඒකට heat එක එන්නේ නැහැ. ඒ කියන්නේ thermal conductivity එක. ඒතර මේ gas එකනේ දැන් heat වෙන්නේ. Right? And this gas is not going to get that direct heat from this flask. මේ flask එක වටේට මේක heat වෙනවා. But මෙයාට ඒක එන්නේ නැහැ. එතන පොඩි error එකක් එනවනේ. To minimize that error, we are using a capillary tube. Right? ඊට පස්සේ මේ ටික measure කරගන්න we need a thermometer, right? We need a thermometer and to make sure there's a uniform distribution of temperature, we need a stirrer to stir this, right? Simply ඕක තමයි කරන්න යන්නේ. කරන්න යන්නේ එතකොට constant volume is assured because of this setup, right? මේක leak වෙන්නේ නැහැ නේ. මේකට මම gas add කරන්නෙත් නැහැ නේ. So constant volume is assured. Constant volume එකක් තියෙනවා. Then to change temperature, right? To change temperature we have the burner, right? මේකෙන් අපි temperature එක change කරනවා. By changing temperature, then we are going to get the respective reading for pressure using the pressure gauge, right? Simple වැඩක් කරන්නේ. මෙතනින් temperature එක change කරනවා, right? Say we are changing 10 by 10. සාමාන්‍යයෙන් අපි මේක 10 by 10 වගේ change කරනවා, right? Starting from 25 again start කරනවා. 25, then pressure is measured. At 35 again pressure is measured. 45 again pressure is measured, right? Temperature එක control කරන්න එහෙම දේවල් තියෙනවා. ඒවා කතා කරමු. But basically what we are doing is, when this is heated from this, water around is getting the heat, right? Then that is taken by the gas inside because of the thermal conductivity of glass here. That's a thin glass, right? ඒකත් conductivity එක වැඩි කරන්න හින්දා thin glass එකක් කරන් තියෙනවා. Otherwise thermal conductivity decreases, no? Right? If the distance or the thickness increases, right? එහෙම කරලා මේ reading එක ගන්නවා. ඔය reading එක අරගෙන we are going to record this temperature against pressure, and then we can plot a graph, right? Temperature against pressure දන්නවනම් graph එකක් අඳින්න පුළුවන්, right? If this graph goes through origin, pressure law is verified, right? Simple experiment එකක් කරන්න, right? හැබැයි මේක එක precautions එහෙම තියෙනවා. ඔය ටික තමයි ටිකක් වැඩිපුර කතා කරන්න තියෙන්නේ, right? There are many precautions to take into consideration when we do this, right? Because we are doing this, even though that's a simple thing, we are doing this inside some kind of restrictions, right? Get පොඩි restrictions තියෙනවා, right? ඒ ටික මොනවද කියලා බලමු, right? Then මේක ලියා ගන්න. Write down materials and apparatus. 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 Right, mention one by one. Mention a beaker filled with water, a beaker filled with water, right? Malayalam. Materials and apparatus, a beaker filled with water. A beaker filled with water, right? Then pressure gauge, then round bottom flask, right? Then thermometer, stirrer, burner, right? Burner කියලා කියන අතරම Bunsen burner, right? Tripod or stand, right? And other than that, a square net, or that is called a square gauze, right? To put here, right? A square gauze or net to put here, because now Bunsen burner has a single flame, no? When it has a single flame, that is going to point to a single point. When it is point to a single point, this bottom is going to heat by a single point, right? To have a good distribution, we are going to use a net here to distribute heat. Net එකක් දානවා. ඒ කියන්නේ මේකට මෙහෙම net එකක් දානවා. මෙහෙම net එකක් දානවා. net එක දැම්මම පස්සේ now along the net heat is distributed, no? Then bottom is going to heat uniformly, right? ඒ වැඩේ කරේ නැත්තම් මෙයාගේ අර center එක විතරක් heat වෙන්න ගන්නවා, right? ඒතකොට uniform distribution එකක් ගන්න අමාරුයි. බැරි නෑ, ඒක අමාරුයි, right? So therefore මේක heat තව experiments වලත් අපි මේ වැඩේ කරනවා, right? When we need to get a uniform distribution along this base, right? We are laying a net there. That's called a net or a gauze, right? A square net or gauze. Next one, square net O goes. Right. Right. Then as the next heading, write down method. 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 Right. Now, let's label this as well. Label pressure gauge. Pressure gauge. මේක තමයි එන්නේ නැහැ අදින්න. Right? මෙතන අදින්න. And thermometer. Label this while you are drawing. Thermometer, beaker, Bunsen burner, stand or tripod, square net, stirrer, round bottom flask. Right. Take down the apparatus. Then go work on it. Right. Right. Check this again. Square net. Right. නැත්නම් wire gauge කියලා කියනවනේ. Square gauge කියලා කියන මොකක් හරි. Square net. Bunsen burner, tripod, beaker, thermometer, thumb bottom flask, stirrer, pressure gauge. Right? And these are capillary tube. These are capillary tube. These are capillary tube. Capillary tube. Right. Then we are starting from a temperature, and when we decide the initial temperature, right, usually we don't start with the room temperature, because if we start with the room temperature now, how many readings we need minimum to plot a graph? Minimum, what's our minimum standard? 6, right? 6 ne? Minimum standard is 6. So minimum 6 readings on. Say we are starting from 30 when we start 6 readings arang ඉවර වෙද්දි 80 90 වගේ temperature එකකට ඔක යනවනේ, right? So ඔක පොඩ්ඩක් විතර control කරගන්න, what we do is, right, we'll first going to reduce the temperature by adding ice. I'm going to reduce this up to 24 25 somewhere around, right? එතකොට distribution එක ගන්න ලේසි. නැත්නම් distribution එක ගන්න බැරි වෙලා if we are going to exceed 100, right, 100 වලදී මට මේක කරන්න බෑනේ, because at 100 water is going to vaporize, right? So 100 වලට කලින් we have to stop the experiment before 100. 30 වලින් start කරත් still we have the limit of 6, right? හැබැයි මොනවා හරිලා අපිට 7 ගන්න ඕන, ඒක 100 වුණොත් කරගන්න බෑනේ. Then to be safe, right, as a precaution, what we do is we are starting with somewhere above dew point, somewhere below room temperature, right? Dew point එක idea එකක් ගන්නවා මුලින්ම. Dew point එක, let's say now today's dew point is 22, right? 22 and 23 වලින් start කරන්න. If the dew point is 22, we are not going to start at 23, right? දෙකක්වත් අඩුම උඩින් තියෙන්න ඕනේ. Then if there is 22, minimum 24 25 වගේ value එකකින් start කරනවා, right? පොඩ්ඩක් හරි අර පහළ value එකට එද්දි distribution එක ගන්න ලේසි, right? Write down in point form. First point, right, write down 6 readings. Yes, good. Write down first point. Set up the apparatus properly as shown in the figure. Set up the apparatus properly as shown in the figure. Set up the apparatus properly as shown in the figure. Set up the apparatus properly as shown in the figure. Second point. Add some ice. Adding ice කියන එක compulsory නෑ, but that is a precaution we take, right? Add some ice to reduce temperature, to reduce initial temperature. Add some ice to reduce initial temperature. Add some ice to reduce initial temperature. To have a good distribution, to have a good distribution of readings. To have a good distribution of readings. Right? Next point. Heat water beaker using burner. While stirring well. Oh, nanti kan apa? Ini yang karan kan? Stir yang karan ini kan? Right? Next point. Record pressure from pressure gauge. Record pressure from pressure gauge. When increasing temperature, for each 10 degrees Celsius. For each 10 degrees Celsius. 10 degrees Celsius. And record them in following table. And record them in following table. Right. Table එකක් කියලා ලොකු එකක් නැහැ. Right. We have temperatures. Right. We have temperatures. Right. මෙතන තියෙන thermometer එකනේ. Thermometer is measured. Right. Thermometer measures the temperature in degrees Celsius. Right. එතකොට මෙතන අපේ direct reading එක Celsius temperature එකක්. Direct reading is going to be Celsius. But we are going to plot the graph with a Kelvin temperature. Kelvin වල convert කරලා ගන්න ඕනේ. Right. Then this is the thermometer reading. Right. Temperature in degrees Celsius. Right. Temperature in degrees Celsius. Right. මෙහෙම readings එක ගන්නවා. Like this. Then convert this to kelvins. Temperature again in kelvins. Right. And the respective pressure. මේ readings එක විතරයි අපිට ඕනේ. Pressure P. Right. Say we started from 25, then 35, 45, 55, 65, 75. මේ වගේ ගන්න. Right. මට දැන් සවර් රීඩින් එකක් ගන්න ඕනොත් it is going to 85 නෝ. Right. අර ඒතකොට 15 තියෙනවනේ 100 දින. we are within the limit. නැත්නම් නිකන් අර 90 95 වගේ රීඩින් එකකට යන්න ගියොත් ඒක අර එච්චරම සක්සස් නැහැ. Right. ඒකයි අර අයිස් දාලා මුලින්ම මේක අඩු කරේ. ඒක precaution එකක්. හොඳේ. Not compulsory but a precaution. Right. මේ දන්නවා නම් we know Kelvin values, pressure gauge එකෙන් ගන්නවා මේ reading එක. Right. Then we have Kelvin temperature with pressure. Right. Can plot a graph. ඊට පස්සේ කරන්නේ we are going to plot the graph. Table එක ලියා ගන්න. Take down the table. Adding IC is optional. Yes, that is optional. That is optional. That is optional. 30 වලින් start කරලා ගන්න පුළුවන්. That is doable. But to have a good spread, මට නිකන් readings 8ක් විතර ගන්න පුළුවන් නම් තව හොඳයිනේ. That is better if you can have more readings, right? අන්න ඒ වගේ scenario එකක් ආවොත් that's better to decrease temperature නෝ. right? ඒතකොට නිකන් 24 25 වගේ level එකකට high set කරලා මේවා කරගන්න පුළුවන්. That is optional. Right. Next point. Plot the graph. Plot the graph between pressure and volume, between pressure and temperature, pressure and absolute temperature. Plot the graph between pressure and absolute temperature. Right. When the graph is pressure and absolute temperature, right? By marking these points for this graph, මෙහෙම එකක් එයි. Right? Right. Then conclusion. Conclusion. If the graph between pressure and absolute temperature is, if the graph between pressure and absolute temperature is, if the graph between pressure and absolute temperature is, if the graph between pressure and absolute temperature is a straight line goes to origin, 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 pressure law is verified. Pressure law is verified. Pressure law is verified. Right? මේ තියෙන pressure law එකනේ. Right? අපි Leesa එක කියන්නේ මේ pressure law එක. This is the pressure law. Pressure law is verified. Right? Okay. Basically කරන්නේ මේ වැඩේ. Right? But there are some other facts to put some attention on and put some extra care, because there are some, as I told you, there are some like restrictions and some other points to be careful, right? ඒ ටික අපි ඔක්කොම මෙතන discuss කරමු. Right? Write down as remarks. Remarks. Right, first thing, listen. Listen. When we heat from a Bunsen burner, right? When we heat from a Bunsen burner, right? This heat is not immediately going to acquire by the gas. No? It takes some time. මෙතන ඉන්න අපි heat කරන්නේ. Gas එක නෙමෙයි heat කරන්නේ. Then initially this heat should be acquired by the square net here, and then by conduction this beaker here, right? Then after that beaker, that heat is acquired by water inside, right? When water is heated, now when we stir this properly, it is uniformly distributed. When water is heated only, this round bottom flask is getting the heat, right? Then again, through a heat conduction through these walls of the flask, only gas is getting the heat, right? So methane heat කරලා ටික වෙලාවක් කරනවා මෙතනට heat එක එන්නේ. That is not instant, right? methane heat කරපුවා මෙතනට ඒක වෙන්නේ නැහැ, right? මේ temperature එක වෙන්නේ නැහැ නේ methane heat කරපුවා. Then what we do is this. Say I need to get the temperature at 25, right? What we do is, right? You can't stop this exactly at 25 when we heat this from a Bunsen burner. ඒකම control කරන්න බෑනේ මේ Bunsen burner එක කියන්නේ. නිකන් පත් වෙනවනේ හටින්. This flame is here, right? And even though you remove this, now when this is at 25, it is going to increase the temperature more than 25. Hey, making up heat එක තමයි මෙතෙන්ට ආවිලා නැහැ. Got the point? When the temperature shows, when the thermometer shows a temperature 25, right? If you remove this until you take the measurement, right? That temperature is not going to stop at 25. That is going to rise above 25, because even though you remove this at 25, there is another additional amount of heat that is not acquired by the gas. ඒක instantly වෙන්නේ නැහැ. ඒතර ඕක තවඩයක් උඩට යනවා. Right? To minimize that error. ඉතින් error එකක් එනවනේ. Right? As a precaution, what we do is we heat this to a point where around 2 degrees above to the expected value, right? 25 නම් මම ගන්න යන්නේ මේක heat කරනවා 27 වලට. Then we are removing the burner, flask නෙමෙයි, removing the burner එක අයින් කරනවා. burner එක අයින් කරාට පස්සේ ටික ලාගෙන temperature drop වෙනවනේ. When it drops, we can easily catch where it is going to reach 25 නෝ. increase වෙද්දි හොයන්න බෑ. ඇයි යටින් heat එක දාලානේ තියෙන්නේ. ඒතර මට control කරන්න බෑ. But when it slowly drops, then it is going to stay at 25 for a little bit longer than this. අන්න ඒක තමයි reading එක ගන්න time එක. ඒක තමයි precaution එක. ඒක 25 ගන්න අපි මේක 27 වලට heat කරලා මේක අයින් කරනවා. That is one thing. Right? නැත්නම් අර නිකන් temperature එක අපි set කරලා වගේ නිකන් program කරලා වගේ එහෙම ගන්න බෑනේ. You are going to do this manually. Right? We are doing this manually. 25 වල මට control කරගන්න විදියක් නැහැ. ඒකට තියෙන precaution එක අරක increasing the temperature up to 27, 2 degrees above the expected temperature. Or 30 නම් ගන්න 32, right? එහෙම. 2 degrees above the temperature and removing the burner and let it cool down up to that point, right? So when it cools down to that point, then only you are going to read the reading from the pressure gauge, right? අර නැත්නම් අපිට කැමති තැන ගිහිල්ලා මේක stop කරන්න බෑ. point එක තේරුණාද? Right? Because when thermometer shows a temperature 25 when you heat, right? Temperature inside the system is not actually 25. that's a delay it has, right? මේ හරිය එතකොට 25 නෙමෙයි, මේ 26 විතර වෙලා. හැබැයි මෙයා පෙන්වන තාම 25 කියලා. මේ හරිය හිට් එක වැඩි. ටික වෙලාවක් යනවා මේක වැඩි වෙන්න, right? ඒතර බර්න් එක ගාව ගත්තොත් මීට වඩා වැඩි, right? that's the thing. ඒතර immediately මේක 25 වෙද්දි gas එක 25 වෙනවද? එහෙම වෙන්නේ නැහැ. it takes a time, right? ඕක තමයි case එක. ඒතර මේක පොඩක් slow කරගන්න ඕනේ. Increasing it to 27 and let it cool up to 25 and then only you are taking the reading, right? First point, write down. මේ remarks වල කියන points එක තමයි especially questions වලට එද්දී ඕන වෙන්නේ හොද? Because in questions always you will be asked about these special things, important things about the experiment, no? Right? Precautions, other important things, right? Those things extra care we take, right? ඒ ඔක්කොම තියෙන්නේ මෙතන. මේ ටික very special ලා. නැත්නම් method එකේ තියෙන ටික that's more or less the normal. ඒක normal නේ. ඔයා වෙන කොහෙන් හරි මේක බැලුවත් ඒක normal. හැබැයි මෙතන තියෙන ටික අනිවාර්යෙන් දැනගෙන ඉන්න ඕනේ. Plus that will be question when comes to a question, right? First one, write down. First point. When a reading is taken at a temperature, at a certain temperature, it should be heated around 2 degrees Celsius above around 2 degrees Celsius. It should be heated around 2 degrees Celsius above the expected reading. Above the expected temperature, Gillian. Above the expected temperature. 2 degrees Celsius above the expected temperature. And then burner is removed. To control heat. For the same point, when the system cools down again, to required temperature, take the reading of pressure gauge. Right? Next point. Right. Next point is about stirring this. Listen. Now, if you didn't stir well, right, what happens is uniform distribution of temperature is not going to get by the whole liquid or the whole amount of water, all the molecules of water, right? මේ ළඟ ඉන්න කට්ටිය වැඩිපුර heat වෙනවනේ. Then when you stir this well only, uniform heat is distributed in all volume of water. Then only these walls are getting a uniform heat, right? නැත්නම් තැන් තැන් වල එක එක temperatures, right? To control this throughout the experiment, stirring this is mandatory, right? දැන් අපි ඔක් කරද්දී තනියෙන් කරන්න ගොඩක් වෙලාවට අමාරු වෙන. ඒතකොට එක්කෙනෙක් ඕක වෙනම ස්ටර් කරන්න තියෙනවා. කර කර ඉන්න. මොකද ඒක කන්ටිනියස්ලිම කරන්න ඕන. ඒක ස්ටොප් කරොත් ප්‍රශ්න වැඩි කියන්නේ මේ වැරදි. It's erroneous, right? Second point, stirring well throughout the experiment is mandatory. To ensure a uniform distribution a uniform distribution of heat throughout water beaker. To ensure a uniform distribution of heat throughout water beaker. Right? Next. Listen. Now, this is going to get heat through heat conduction through this glass. No? Then having a thin flask is very important. Right? If the flask is not thin, glass is not a good heat conductor. Glass කියන්නේ කොහොමද heat insulator එක. Glass කියලා කියන්නේ හොඳ heat conductor එකක් නෙමෙයි. That is a heat insulator. Right? Then to minimize that impact, we have to have a minimum possible thickness for the flask. Right? ගොඩක් කීනි glass එකක් use කරන්නේ නැත්නම් මොකද glass කියලා කියන්නේ glass එකක් use කරන්න නැතුවත් බෑ. Right? මොනවාද copper වගේක් use කරන්න බෑ. copper වගේක් use කරන්න බෑ. glass එකක් විතරයි use කරන්නේ. හැබැයි glass කියලා කියන්නේ that is not a good heat conductor. ඒතර ඒක minimize කරන්න විතරයි පුළුවන්. We can't make it zero. Minimize කරන්න ඕන නම් කරන්න දෙන්නේ. We know heat conduction is QOD equals Ka delta theta OD, no? Right? So higher the thickness, lesser the conduction, right? Then what we can do is choosing a flask with a minimum thickness to increase this, right? Ek minimize karna vidara puluwan. Next point, write down. Having thin walls for round bottom flask is important to increase heat conduction from water to gas inside flask. Right. Next thing. Listen. So I told you this is a capillary tube. Right. Now the thing is this capillary tube and the gas inside capillary tube is never going to get the temperature of the gas here. මේ temperature එකට මේක කවදාවත් equal වෙන්නේ නැහැ. කොච්චර මේක heat කරා. එහෙම කරන්න බෑ. Right? Then only thing we can do is minimizing this to minimize percentage errors. Right? So therefore we are using a larger flask with a capillary tube. Then with respect to the volume of gas here, right? If this is a negligible volume inside the capillary, it can be neglected, no? If that percentage error is less than 1, එතකොට තියෙන volume එකේ percentage error තේරෙනව නේද? Right? To have a percentage error less than 1%, right? නැත්තම් එහෙම මේක consider කරන්න වෙනවනේ. If the percentage error is less than 1, we can neglect it. Right? ඒක අපේ allowed limit එක. That is 1%. 1 එකක් නම් allowed අපිට අයින් කරන්න පුළුවන්. Then what we do is we are choosing a capillary tube here as to minimize the percentage error. Right? Then we will neglect the percentage error, but we are neglecting by being inside our limit. That's the thing. Right? Then ලොකු tube එකක් දාගෙන ඒක neglect කරන්න බෑ. Right? With respect to the volume inside the flask, this should be negligible. Right? To serve that purpose, the capillary tube is used. Right? Next point. Volume of gas inside capillary tube. Volume of gas inside capillary tube should be negligible with respect to the volume of should be negligible with respect to the volume of gas inside flask. Should be negligible with respect to the volume of gas inside flask. Right? Within brackets, to minimize percentage errors. Within brackets, to minimize percentage errors. Right? Okay, then the reason to use a round bottom flask is this. Right? We know minimum possible area is taken for same dimensions, right? When something is spherical, right? Our example is water bubbles or water droplets in surface tension. Higher the stability means lesser area, because surface energy is given by delta AT, no? Delta AT. Lesser area means higher stability, right? Then to lessen the area, naturally those things are spherical, right? So මේක නිකන් ඔන්න මෙහෙම ප්‍රූව් කරන්නත් පුළුවන් දන්නේ නැත්තම්, right? නිකන් radius එක r තියෙන 2r කියමු, 2r තියෙන sphere එකක් ගන්න. What is going to be the area here? Area of this one 45r, 45 නෙමෙයි 85r 8 නෙමෙයි 2r, no? This area is A1 45r squared, then 2r squared, right? මෙතනින් එනවානේ 16 5r squared කියලා, right? මේ dimensions में තියෙන, say you are getting a cube, right? නිකන් මේක check කරලා බලන්න 2r 2r 2r, right? මොකක්ද දෙන්නේ 24 නේද? 4 into මෙහෙම නෙන්නේ මෙතනින් එන්නේ 8r squared, right? Sorry 2r නෙමෙයි මේක r නේද? Same dimensions means width එක same වෙනවා කියලා කියන්නේ diameter should be 2r, නැත්නම් මට compare කරන්න බැරි වෙනවා. Diameter is 2r, මේක r. එතකොට 4 5r squared මන්. නිකන් බලන්න මේක comparison එකක් කරලා 4 5r squared ඊට පස්සේ ආයෙ මේක සිලින්ඩර් එකක් එක්ක ඕන සිලින්ඩර් එකක් එක්ක compare කරන්න. right? මේක 2r මේක 2r වෙන සිලින්ඩර් එක, right? එළියවත් මේකට වඩා වැඩි එකක් එනවා, right? This is going to be 5r squared into 2r, right? 5r squared into 2r, 2 5r squared plus 2 5 2rh කියලා කියන්නේ again 2r, right? मैं सिंपल कर बात मैं हमें का को मेरे वाला ready, right? Then minimum possible area is going to get area simple कर इन्हों ने minimum possible area is for spherical shapes, right? When the area is minimum, right? We can easily heat this. मैं area गोड़ा कड़ी ना तो heat करा नवारू इन, right? So therefore spherical means round bottom flask is used. Spherical flask are used, right? Diagrams on the node na point take kiya na, write down next point to minimize the area to minimum possible value for same dimensions, to minimum possible values for same dimensions, to minimum possible value for same dimensions, to minimum possible value for same dimensions, a spherical shape slash round bottom flask is used, right? Next thing about this, about using the square net, right? When the square net is used only, we can uniformly distribute the heat coming from Bunsen burner, right, throughout the bottom of the beaker. Right? Otherwise, the flame is going to point to one point at the bottom of the beaker. Right? Next point. Next point. A square net is used. A square net is used. A square net is used. A square net is used to uniformly distribute. To uniformly distribute. To uniformly distribute heat throughout the bottom of beaker. To uniformly distribute heat throughout the bottom of beaker without being pointed to a single point. Without being pointed to a single point. Right? Next thing. Right? I gave you this point when we are discussing about thermometers. Right? Thermometers will give up. Thermometers will give up. Verification of pressure law and the setup means මේ setup එක හරියටම මේක නිකන් මොන thermometer එකක් වගේද? මේක අපි දන්න thermometer එකක්. What is it? This is a demonstration of a popular thermometer we have. How many gas thermometers we have? 2. මොනවද මේ දෙක? Constant volume gas, constant pressure gas. Right? මේ දෙන්නේ මොකද? Constant volume gas thermometer එක. Constant volume gas thermometer එක. Right? Then what are the gases we are going to use here in this? ඒක මම එතෙන්දි කිව්වා in thermometry. What are the possible gases to be used in a constant volume gas thermometer? Helium neon, right? Helium neon වගේ තමයි use කරන්නේ. Then most popular one is helium. Helium වගේ තමයි use කරන්නේ. Helium or neon, right? Because they are less reactive, right? Next point. Next point. ඒකන idea එකක් තියෙන්න ඕනේ. Next point. Next point. Next point. Gases such as hydrogen, helium or neon. Gases such as hydrogen, helium or neon. Hydrogen, helium or neon are used since their behavior is much closer to that of an ideal gas. Is much closer to that of an ideal gas. It is supposed to be ideal because these equations are valid only for ideal gases, right? Within brackets write down. But helium is used more popularly. Under standard conditions. Right? Next point. Ice can be added to water initially to reduce initial temperature below room temperature to have a better spread of values in the graph. Right. Next thing. Now, there's another one we have neglected, right? In terms of thermal, what is it? Attention now. Now we are heating something. We are heating something. Then, when any substance is heated, it is going to expand. That is going to expand, right? Which means now over time, this flask is also going to expand, right? That expansion should be negligible. Expansion එක මෙෂර් කරන්න විදියකුත් නැහැ. Right? එතකොට දැන් මම මෙතන constant volume කියලා කිව්වට is it a constant volume? No, that is going to expand by a bit, by a little bit. But that expansion should be small enough as to neglect, right? So therefore, in glasses also, right? In glasses also, there are different glass materials with different expansivities. No? Then when this round bottom flask is made, a glass with minimum expansion, minimum coefficient of expansivity is used, right? එතකොට නිකන් අපි ගෙදර තියෙන glass එකක් වගේ මේකට හරියන්නේ නැහැ. මේක lab එකේ තියෙන instrument එකන්නේ, right? Then for that material, a type of a glass with a minimum expansivity is used, right? It must be used. Otherwise, if this expansion is considerable, right, we are never going to get a graph which goes to origin, right? So volume එක change වෙලා තියෙන volume එක change වෙනවා කියන අර graph එක මේව straight line එකක් එන්නේ නැහැ. ඒතකොට ඉතින් කොහොමද experiment එක කරදීනේ? There are errors we make. ඒකයි මම කිව්වා we have constraints. Constraints තියෙනවා. මේක නැති කරන්නත් බෑ. Then only thing we can do is using a flask with a minimum coefficient of expansivity. Right? වෙන options නැහැ. වෙන කිසිම option එකක් නැහැ ඒක නැති කරන්න. ඒක 0 කරන්න බෑ කොහොමද? Right? Minimizing විතරයි කරන්න පුළුවන්. ඒකත් 0 කරන්න බෑ. Right? Next point. Next point. Flask should be made. Flask should be made. Flask should be made. Flask should be made with a glass of with a glass of with a glass of minimum thermal expansivity, with a glass of minimum thermal expansivity. Right? Next about hygrometry. මෙහෙම case එකක්. When we inside the gas into this, right? If we are to include water vapor with that including gas, right? Water vapor is not going to behave as an unsaturated vapor, right? Gas laws are only for which gases? ඕකනේ දැන් ඔගේ point එක. Gas laws valid only for unsaturated gases, right? Then if a water vapor is going to be inside, water vapor is going to be saturated, right? ඒක saturated වෙන්න ගත්තොත් මේ variation එක කොහොමවත් වෙන්නේ නැහැ. Pressure of a saturated gas is different from the variation of a unsaturated gas, right? Then we have to make sure that this 100% volume is filled with a dry gas, right? 100% is filled with a dry gas, right? ඒක ඉතින් fill කරද්දී වෙන්නේ මේක අපි නෙමෙයි fill කරන්නේ. This setup is there. ඒ කියන්නේ මේක අපිට fill කරන්න බෑ. අපි නෙමෙයි helium fill කරන්නේ. setup එක තියෙනවා. ඒතර මේක seal කරලා තියෙන්නේ. seal කරලා තියෙන්නේ මේ setup එක මෙන්න මේ ඔක්කොම ටික seal කරලා තියෙන්නේ. right? ඒතර ඒක එතෙන්දි වෙන්න ඕන එකක් at the point of filling this, right? We have to make sure that 100% dry gas is inside. Otherwise, it is going to saturate at some point, and the ultimate impact is that is going to be erroneous, and pressure law cannot be verified if there is a saturated part inside it. If there is a saturated part inside it, right? Next point. Next point. Next point. Gases laws are valid only for. 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 Gases laws are valid only for unsaturated gases. Unsaturated gases. Unsaturated gases. Unsaturated gases. For the same point. Therefore, total volume inside flask, total volume inside flask should be filled with a dry gas should be filled with a dry gas should be filled with a dry gas. Right. Then look at here. Without using this pressure gauge, right? Pressure gauge එක තමයි අපි use කරන්නේ, but there is another alternative if we are not using a pressure gauge. Right? Alternative එකක් තියෙනවා. Our experiment is supposed to be done using the pressure gauge. හැබැයි මේකට මොකක් හරි තව alternative එකක් තියෙන නිසා මම මේ කියලා දෙන්නේ. හදිස්සියට ඇහුවොත් මේක ගැන. Right? If it is going to be questioned about the alternative is this. Alternative is this. Right? මේ alternative එක ගැන මම thermometry වල කිව්වා. කිව්වා නෙමෙයි අපි මේක තමයි යන්නේ ඇත්තට. Without using the pressure gauge, right? We can use the same setup here that we had in the thermometer. Right? This should be filled with mercury. Right? මේක alternative එකක් විතරයි. Right? This should be filled with mercury. Right? මේ part එක අන්ද මතකයිනේ අපි thermometry වලදී. Right? මේකේ readings තියෙනවා. Right? මෙන්න මේක මම ඇදලා ඉන්නේ. Right? And this part is a rubber tube. මේක rubber tube එකක් හින්දා මේක පොඩක් move කරන්න පුළුවන්. This is actually a rubber tube. Right? මේක rubber tube එකක්. And cross check this again with the constant volume gas thermometer. Right? ඒක මේක ඇඳලා ඇති. Now here we have an indicator. මෙතන indicator එකක් තියෙනවා. එහෙමනේ අපි constant volume එක තියාගත්තේ. Same thing. මෙතන තියෙන indicator එකක්. Some mark is marked here. මෙන්න මෙතන mark එකක් ගහලා තියෙනවා. Right? Then always when you take a measurement, we have to make sure that this surface of mercury is at this mark. If there is at the mark, which means constant volume is inside, no? Right? To take the pressure reading, we have this height here. මෙතන ගාලා තියෙන මේක scale එකක්. This is h. Then this pressure difference is h rho g. Right? මෙහෙම කරලා අපිට improvise වෙන්න පුළුවන්. Right? Without using a pressure gauge. Right? Pressure gauge එක use කරලා තමයි කරන්නේ. මම ආයි කියන්නේ ඒකයි pressure gauge එක use කරලා කරන්නේ. But this is an alternative you can do. Right? හදිස්සියට මේක නිකන් modify කරලා මෙහෙම එකක් දුන්නොත් confuse වෙන්න එපා. pressure එක ලියන්න වෙන්නේ P0 plus h rho g. That's it. P0 plus h rho g එක ලියන්න. හරිනේ? Next point. Following setup can be used instead of using the pressure gauge. Following setup can be used instead of using a pressure gauge. Right? setup එක මදින්න ඕනේ නැහැ. Just draw the modified part. Right? මෙන්න මෙතනින් පස්සේ flask එකත් එක්ක modified part එක විතරක් අඳින්න ඕනේ. setup එක ඕනේ නැහැ. Right? setup එක අඳින්න පුළුවන් නම් අඳින්නත් ගන්න නැහැ, but setup එක ඕනේ නැහැ. mercury. Right? මේක open. This part is a glass tube, this is a rubber tube. Right? ඊට පස්සේ මෙතන තියෙන්නේ it's a meter scale, meter ruler or the scale. Right? Finished. Done. මේ මෙතන තියෙන ඉන්ඩිකේටර් එකක්. right? ඉන්ඩිකේටර් එකක් කියලා කියන්නේ මෙතන පොඩි මාක් එකක් තියෙන. This is a mark mentioned here, right? To make the volume constant. ඒතර මේ මාක් එකට අපි ගෙනලා තමයි readings ගන්නෙ, right? This is an indicator. Indicator. Right, write down below again. Write down below this setup again. Vertical height of mercury column. Vertical height of mercury column should be obtained. Vertical height of mercury column should be obtained vertical height of mercury column should be obtained in order to find pressure at a given temperature. In order to find pressure at a given temperature. In order to find pressure at a given temperature. Right? Okay. Right. So basically, that's it for this experiment. Right? Even though we are doing something very simple, right? අර methods ඔක්කොම වඩා remarks වල මම කියපු facts වැඩිනේ. ඒක මම කිව්වේ දැන් මේකේ method එක lazy. But we have some quite a few restrictions. ඒ restrictions ගැන questions ආනවා. ඒතර ඔයයක් ඒකේ දැනන් ඉන්න ඕනේ. Right? So even though the method is very simple, method is very straightforward and simple. මෙතනින් heat කළා pressure එක ගත්තා. gauge එක තිබ්බනම් වෙන මොකුත් කරන්න දෙයක් නැහැ. heat කරනවා, heat එක තියෙනවා, gauge එකෙන් pressure එක ගන්නවා. and plotting a graph. Right? But we have some restrictions, no? So we have to be careful and we have to be within those limits, right? And the restrictions properly to minimize all the errors that we discussed so far, right? And do the experiment, right? Okay, so that's it for the first one. Any questions from this one? Any questions from experiment 1? Any questions from experiment 1? Right? මේකෙත් බලන්න තියලා තියෙන ටික ඕන. Right, so only point given under note here is මේ තියෙන guide එකේ it's only about the capillary tube, right? Capillary tube එකේ මත තියාගන්න. Right, other than that there are many more facts to be considered. Be careful when you do the experiment. Right, මේකේ තියෙන the temperature of the water in the heater should be raised very slowly and the water should be continuously stirred. And since the temperature of the air in the tube connecting the bulb and the gauge and the temperature of the air in bulb do not exist at the same value. Right? These two are never going to be these two are never going to be same. Then only thing we can do from our side is minimizing it. Right? To minimize it, the only option we got is using a capillary tube. To minimize the percentage error of this volume, you are going to consider. Right? Right, මේක තියෙනවා point එක and the temperature of the bulb it's going to be same value. The resulting error can be minimized by using a bulb with a large volume and a capillary tube as a connecting tube. Right, ඒ percentage error එක 1% වල අඩු කරන්න විතරයි අපිට පුළුවන්. වෙන option එකක් නැහැ. Right, any questions before moving on to the next? All good?
Adding ice adds optional. Sir, would you mind explaining some more details around the topic?
I think you sent it before I explained, right? What happens to the graph if it's drawn in degrees Celsius? Can be drawn in degrees Celsius, right? But not as easy as to identify as it is going through origin. No? That's the thing, right? If you have intersection intercept known at minus 273, right? Well, you can get a scale. Right? But difficult. You have to have a proper scale. So a scale then say you are drawing 10 by 10, then you have to check the intercept where it is going to intersect that point at minus 273. Right? Origin intersect lazy. That's why absolute temperature is used. Right? Otherwise, we can't say we can't plot the graph with relative temperature. Possible. Right? But a little bit difficult. Will the reading decrease once we remove the thermometer, sir? We don't remove the thermometer. We remove the Bunsen burner. Thermometer remove we don't remove the thermometer. We don't remove the thermometer. Remove the Bunsen burner to control flame, to control heat, to control flame. The pressure gauge alternative equation. Pressure gauge alternative equation. P naught plus H rho G. Pressure P naught plus H rho G. All good. Right, what else? Anything else? Anything else? It's by a mistake. Yeah, thermometer remove temperature reading. Very well explained. Right, okay. Then we move on. Right. Okay, all good. Anne, let's move on. Listen, when it comes to thermal practicals compared to other practicals, right, we have comparatively more details in thermal. Thermal product details ready, right? So, we have 6 experiments only, right? But they have more details. They have more details. Mechanics, waves, compare practicals, right? Make a details ready. Then when you study these things, put some more attention and do it. And now just after today, right? Best thing is just after today, make sure you are getting this, you are grabbing this then and there and practice other questions starting from tomorrow, right? paper class again questions discuss right? Then second day method of mixture solids paper papers right? As a seminar we are doing this, we are discussing this today, right? Paper discussions discuss experiments right? But method of mixtures, law of cooling, paper discussions discuss right? So let's move on. Right? So I thought මේක කෙලින්ම අදම ඉවර කරන්න ඕනද? සර් බොමුද සීතල වතුර විදුරක් කියලා අහලා තින්නේ. සීතල වතුර විදුරක් තමයි මම බිව්වේ. Right. Second one. Write down determination of specific heat capacity of a solid. Determination of specific heat capacity of a solid. Determination of specific heat capacity of a solid by using method of mixtures. By using method of mixtures. By using method of mixtures. Right, listen. As a solid substance, right, we use lead shots, right? Lead bullets, නැත්නම් lead shots කියලා කියනවා. Lead shots තමයි use කරන්නේ. Listen. Right. Listen. First thing, materials and apparatus. Right. मुझे मम्मी explain करला इन्ना पड़ा कहा. Right. Listen. This diagram is not given in the guide, right? मतलब diagram में diagram में guide दे ना, but you are know the diagram. मैं अंतिम में आपको हम क्वेश्चन के diagram में कहा. Right, listen. Listen. Right. And here we have a calorimeter. Here we have a calorimeter. Right? We have a calorimeter. And that is kept on insulator supports. Right? Insulator supports. And around the calorimeter, right? May occur precautions. Around the calorimeter, it should be filled with or covered with an insulating substance. Usually regiform is used. Right? Air medium එකක් තියන්නත් පුළුවන් because air itself is a good heat insulator, right? But regiform is the best one we have in our labs, right? මේකට regiform දාන්නත් පුළුවන්. මේක cover කරන්න. Right? And 2/3, right? And around 2/3 of the height of this calorimeter is filled with water. මේක water වලින් fill කරනවා. Right? Now initially, before this is filling with water, right? After putting the stirrer and the thermometer, right? After putting these two, initially we have to find the mass. Right? Masses readings right? First reading is we need initial mass. Initial mass කියලා කියන්නේ initial mass කියලා කියන්නේ beaker plus stirrer, right? මෙයාගේ mass එක ඕනේ m1, right? In detail ලියමු මම මේ points එක කියන්නේ. And again we need the initial temperature, say that is theta1, right? And then we are filling this calorimeter up to a 2/3 of the total height with water, and then again we need the mass, right? Mass of these two, then mass of beaker stirrer with water, say M2. Now mass of water here is M2 minus M1, right? අපිට එහෙම හොයාගන්න තමයි මේ readings එක ගන්න. Mass of water here is M2 minus M1, right? ඒතර මේක දන්නවා. මේකත් දන්නවා. Mass of water, M of water here is M2 minus M1, right? Then as a precaution again, an insulator sheet is kept in between because if this setup is going to get direct heat from the Bunsen burner, temperature is going to be different here, right? Make heat again, because this is going to reach the equilibrium under room conditions. Room conditions is making direct heat again, right? So therefore this is used is an insulator sheet. Usually what we use in labs is either regiform sheet, regiform board, or asbestos. Asbestos කියන දන්නවනේ. That is also a good heat insulator. ඒකනේ roofing වල ගන්න. ගේ අස්සර heat එක එන්නේ නැති වෙන්නේ. ඒක minimize කරන්න. That's why asbestos is used as roofing. අර ad එක යන්නේ. Rhino asbestos මොකද්ද කියලා? අන්න ඒක තමයි asbestos කියන්නේ. right? ඒක තමයි roofing වලට ගන්න. නැත්නම් අර දැන් ඔයගොල්ලෝ දැකලත් ඇති. අමානෝ sheets වගේ දැම්මොත් එම දැන් වෙන point එකක් කියන්න දැන්. අමානෝ sheets වගේ දැම්මොත් අමානෝ sheets කියන එක දන්නවනේ? metal sheets. අමානෝ කියලා කියන්නේ අර දන්නවද? ගටර්ස් එක තියෙන sheet එකක් කියන්නේ අමානෝ කියලා. තවන exam එකෙන් පස්සේ හරි බලන්න එහෙම sheet එකක් තියෙනවා. හරිද? එහෙනම් පොඩි ගටර් එකක් එක්ක මෙන්න මෙහෙම. එහෙම ගටර් එකක් එක්ක එන metal sheet එකක් තියෙනවා. that is called අමානෝ. අමානෝ sheets කියලා එකක් තියෙනවා. right? ටකරන් නෙමෙයි, ටකරනුත් හරි. ටකරනුත් හරි. අර ඒකේ හොඳ එක අමානෝ sheets කියලා කියන්නේ. ටකරනුත් හරි. ඒකත් හරි. හරි. ඒතර අමානෝ sheets වගේ දැම්මොත් heat එක වැඩිනේ. right? ඒක තමයි අර asbestos වගේ එකක් ඇවිල්ලා තියෙන්නේ. ඊට පස්සේ අර දැන් ඉස්සර තිබ්බේ උළු කියලා එකක්. උළු දැකලා තියෙනවනේ. right? ඉතින් ඒකත් clay නේ එතකොට මේ substance එක. ඒක clay type යන්නේ. ඉතින් clay කියලා කියන්නේ නැත්තම් උළු කියලා කියන්නේ ටිකක් මේ හොඳ මේකෙක්. හොඳ heat insulator එකක්. right? ඉතින් ඒ හින්දා use කරනවා. ඔය වගේ තමයි. right? මේ එතකොට මේක ගැන this can be either regiform or asbestos. ඒක මතක තියාගන්න මේ substance එක ගැන හැබැයි අහලා තියෙනවද? ඒ නිසා මේකත් දැනගෙන ඉන්න. either regiform or asbestos. right? මේමයි කරන්නේ. now initially lead shots are here. මේ තියෙන lead shots. lead shots කියලා කියන්නේ small lead balls කියන්නේ lead shots කියලා ඒවට. lead shots. right? small lead balls. අර මේ bicycles වල නැත්නම් motor bicycles වල තියෙන මේවා දැකලා තියෙනව නේද? අන්න ඒ වගේ lead shots කියලා කියන්නේ. මේ boys නම් කොහොමද දැනගෙන තියෙන්න ඕනේ? මොකක් හරි අර joints වල තියෙන දන්නව නේද ඔයගොල්ලෝ? girls දන්නවද? කියන්නේ bicycles වල එහෙම අර joints වල තියෙන්නේ මේ bearing එකට දාලා. දන්නවනේ? in bearings small iron balls are used in bicycles, motor bicycles, vehicles. bearings වල තියෙනවා. right? නැත්නම් ඔය මේ දවස්වල කරගෙන කෝඩුවක් එහෙම දැක්කම ඒවත් ඉතින් bearing එකේ තියෙනවා. අන්න ඒ වගේ එකක් තමයි lead shots කියලා කියන්නේ. small lead balls. right? lead shots කියලා කියන්නේ. right? මේක heat කරනවා. right? මේක heat කරනවා. listen. මේක heat කරනවා. lead shots. ලකදල්නේ මේක heat කරනවා. listen. system එක heat කරනවා. once the system is heat, the steady temperature we can reach when water is heated is 100 degrees Celsius. No? Right? Because at 100 only it is going to be uniform since it is reaching the state change. Right? Vaporization එකට යනවනේ. ඒතර මෙයාව 100 වල යනකම් අපි heat කරනවා. heat කරාට පස්සේ initial temperature of lead balls is ensured as 100 no. right? නැත්නම් මේක measure කරගන්න විදියක් නැහැ. ඒ කියන්නේ lead shot එකක lead shots වල තියෙන temperature එක මේම thermometer එකක් දාලා dip කරලා measure කරන්න අමාරුයි. that is lead shots. right? ඒතකොට ඒක අර bulb එකත් එක්ක contact වෙන්නේ නැහැ. right? ඒ හින්දා අපි ඉතින් මේක improvise කරන්න ඕනේ. then what we do is we are using a water beaker here and water beaker is heated until it is boiled. when water is boiled, we know it has reached the system has reached the unchanged temperature at 100. which means initial temperature of lead balls, lead shots is going to be 100. Right? Wrong. Initial temperature of lead කියන එක දන්නවා 100 කියලා. Initial temperature of lead 100. Right? Then after heating this to 100, these lead balls are added to the calorimeter here. Right? These lead balls are added to the calorimeter here. ඒකයි මේක 2/3 වගේ වෙන්න height එකකට මේක water දාන්නේ. නැත්නම් lead balls දාපු ගමන් මේක spill out වෙනවා. Right? Spill out වුණොත් mass එකේ error එකක් එනවා. Right? Then lead balls are added. Lead balls are added. And this system is covered with the insulated lid. And we are going to make sure that we cover ganna insulated lid. Right? We are going to make sure that all heat of lead shots are absorbed only by water inside and the calorimeter. Calorimeter, styre and water. Right? මේකට එයා එකට වෙන මේ ඒ කියන්නේ heat loss එකක් ආවොත් error එකක් එනවනේ. ඒ heat loss එක නැති කරන්න ඕනේ. For that this lid is used. Right? And listen, until this system is reaching the maximum temperature. Now initially water is at somewhere close to room temperature, theta 1, somewhere close to room temperature. Right? When lead shots at 100 added, temperature is going to increase. Right? And it will reach a maximum temperature. It is going to reach a maximum temperature. Right? Maximum temperature reach කරනවා කියන එක අපිට නිකන් අර හැම වෙලේම sensible නෑ. ඒ කියන්නේ මෙහෙමයි. Now we can see an increase. Right? But at the maximum, just after the maximum, it is going to decrease, no? Right? එතකොට අපිට මතක නෑනේ මේක maximum නේ කීයද කියලා. ඒ නිසා ඔය වගේ වෙලාවට අපි කරන්නේ like in each 30 seconds, we are recording the temperature. Then you will see some point as when you take the reading in the next 30, it is a reading less than the immediate previous reading. අන්න ඒක තමයි maximum එක කියලා ගන්න. නිකන් මෙහෙම බලන් ඉඳලා maximum එක අපිට decide කරන්න අමාරුයි. Practically. Right? ඒ කියන්නේ එකපාරට මේක drop වෙන්න ගන්න point එක අමතක වෙනවනේ. ඒ කියන්නේ මතක හිටින්නේ නැහනේ. ඒතර අර safety precaution එකක් what we do is we are recording in each 30 seconds. Right? මේක නිකන් 5 minutes වගේ යද්දි මේ වැඩේ වෙලා ඉවරයි. equilibrium එකට යනවා. ඒතර නිකන් 5 minutes යන්නෙත් නැහැ සමහරවිට. Between 2.5 to 5 minutes this thing is over. Right? මේ ඉක්මනට වෙනවා because lead is a good heat conductor. ටක් ගාලා මෙයා conduct කරනවානේ heat එක water වලට. ටක් ගාලා වැඩේ වෙනවා. ඒතර අපි පොඩි වෙලාවක් යනකම් for each 30 seconds වලට our temperature එක measure කරනවා. නිකන් record කරනවා. record කරාට පස්සේ then you will see at some point, right, you will see a drop in temperature. ඒක නම් drop එක, then the immediate previous value is the maximum temperature reached by the system. ඒක measure කරනවා. Right? Then initial it was say maximum temperature කියලා කියන්නේ final temperature. Final temperature for the system say theta 2. Right? And finally final mass of the system. Final mass. So final mass කියලා කියන්නේ water beaker stirrer with lead shots. ඔක්කොම ටික measure කරනවා. Final mass. Say M3. Then what should be the mass of lead? Mass of lead shots. M3 minus M2. Right? M3 minus M2. Right. Then let's assume lead shots add කරන්න කලින් තිබ්බ mass එක M2 නේ. ඊට පස්සේ කරේ lead shots add කරන එක විතරනේ. Then M3 minus M2 is the mass of lead shots. Added lead shots. Right? හරි. දැන් කරන්න දෙන්නේ මේකයි. Now we know if no heat is lost to the environment, right? If no heat is lost to the environment, when it is reaching the equilibrium, lead shots are going to release heat to the system. And water and the system beaker is going to absorb this heat. Right? Then my logic is this. If there's no heat loss to environment, if there's no heat loss, heat released by lead shots equals heat absorbed by water plus calorimeter. Water plus calorimeter. මම මෙතන beaker කියලා දෙන්නේ. Not beaker, calorimeter. Right? මේක තමයි beaker එක. This is a beaker. Right? And this one is also a beaker. Right? Then heat released by lead shots. Right? Lead shots are released by heat එක කියලා කියන්නේ mass of lead is M3 minus M2. right? ms theta can ලියන්න යන්නේ m3 minus m2, right? And let's assume c l as c නෙමෙයි sl කියලා ගමු. නැත්නම් c කියලා ගමු. මේකේ නම් දාලා තියෙන c, but new notation is s, cl, cw and cs, right? Lead, water, styrer with calorimeter, right? එහෙනම් මෙතන එන්නේ this is cl. Temperature difference is, it was started at 100, then 100 minus maximum temperature reached by the system is 0 2. 100 minus 0 2. 100 minus 0 2 plus, sorry, equals from this side absorbed by water. Water wala mass එක මෙතන තියෙනවා. m2 minus m1. Then m2 minus m1 cw and temperature increase by water is from theta 1 to theta 2, then temperature difference is theta 2 minus theta 1, right? And plus mass of styrer and the calorimeter is m1. If specific heat capacity of calorimeter is cs, same temperature difference theta 2 minus theta 1, right? Now using this equation cl can be determined, right? Using the equation cl can be determined, right? Basically කරන්නේ ඕක මේකෙත් අර වගේ තමයි, even though the method, right, methodology is simple, methodology එක ඇත්තටම simple, right? But since we have several restrictions, precautions, right, and things to take care, right, in terms of details about the experiment, that is kind of large කලින් වගේ තමයි. හැබැයි thermal හැම එකේම වගේමයි ඔද. thermal වල methods and lazy කියන්නේ methods මතක තියාගන්න lazy. හැබැයි අර background එකේ තියෙන details ගොඩක් වැඩි. ඒ thermal වල හැටි, thermal experiments වල හැටි. කරන වැඩේ මතක තියාගන්න lazy, right? අමතක වුණොත් අමතක වෙන්නේ අර මොනවා හරි මේකේ ඔය තියෙන reason එකක් පාඩම් කරගන්න නැතුව. right? thermal වල ඒ වගේ වැඩි. Because we are limited, we are restricted in some cases, right? So basically මෙහෙම වැඩක් තමයි කරන්නේ. හරිනේ? And මෙන්න මේ තුනම කරලා listen. Keeping on insulator supporters and covering with heat insulators and covering with a insulated lid, right? Everything is done to make sure that no heat is lost out of the system, outside the system, right? මේන heat ඔක්කොම මේ system එක ඇතුලේ ඉන්න ඕනේ. මේ මුන් නැත්තම් මට අරක ලියන්න බෑ. හරිනේ? If some certain heat is lost to the environment, right? එතකොට මේ පැත්ත මම ඇත්තටම ලියන heat එක නෙමෙයිනේ lost වෙලානේ තියෙන්නේ. වැරදිනේ එතකොට. right? ඉතින් ඒකට තමයි මේ වැඩ ටික කරන්නේ. right? එතකොට heat loss එක නැති කරන්න නම් අපිට තුනක් නැති කරන්න තියෙන්නේ conduction, convection and radiation. To minimize conduction, this is used, right? මේක මම in detail කියන්නම්. To minimize conduction, because if this is in contact with a flow or a heat conductor, it is going to conduct heat, right? Therefore, it is kept on insulator supporters to minimize conduction. To minimize convection, it is covered with insulators, right? And the lid, මේ ටිකයි lid එකයි ඔක්කොම, right? Because to minimize radiation, we have to use a well polished calorimeter, right? Polished calorimeter, and this is also contributing the radiation, right? මේකත් radiation එකට contribute කරන, radiation is all around no, right? එතකොට ඒකයි මේකක් අස්සේ දාලා තියෙන්නේ. නැත්තම් නිකන් calorimeter එක තියාගෙන ඒකට lead shots දාලා කරන්න බෑ, right? Okay, then first write down materials and apparatus. Materials and apparatus. Materials and apparatus. Make it tripod එකත් ඇඳ ගන්න ලස්සනට. Right. Okay, first write down. A calorimeter. Next, boiling tube කියලා කියන්නේ මේකට, right? Boiling tube. Next one, lead shots. Mention one by one. right? Thermometer. Thermometer. Bunsen burner. Bunsen burner. Heat insulated sheet. Heat insulated sheet. Heat insulated sheet. Tripod. Tripod. Beaker right? Two beakers. Two beakers. Right? And one more thing to add to the discussion, I'm going explain right? To have a good distribution of heat, again, a square net. Square net is used here, right? Square net. Square net. Next one, next square net. Square net is also called wire gauze, right? Wire gauze can ekama thamai. Gauze කියන එක දන්නවනේ. Right? අර බැන්ඩේජ් වලත් ගන්න ඉතින් අර ග්‍රිඩ්ස් නේ තියෙන්නේ. Wire gauze කියලා කියන්නේ square nets. Right? Then relevant on sufficient amount of water, sufficient amount of water, sufficient amount of water, sufficient amount of water. A stirrer. Right. So first, let's see the theory. Right. Mention next heading, next part as theory. Theory. Right. Theory. First mention this. Right. Mention this as theory. Write down. If there's no heat loss, if there's no heat loss, if there's no heat loss, if there's no heat loss to environment, when lead shots are mixed, when lead shots are mixed with water, when lead shots are mixed with water, right? Put a comma and write down heat released by lead shots equals this one. Heat released by lead shots. Heat released by lead shots. Heat released by lead shots equals heat absorbed by water and calorimeter. Heat absorbed by water and calorimeter. Right? Under that, mention readings. Put as readings and mention them one by one. And you have to know this order of the readings you are taking. Right? මේ තියෙන order එක. මේ order එකේම ඔයාලා මතක තියෙන්න ඕනේ. Order එකම අහනවා හොඳ. කියන්නේ මේක in order you have to, in this sequence, in this correct order you should be able to memorize this. Right? Okay, readings. මේ 1 2 දාලා ලියන්නේ ඒකයි. This is the correct order of these readings. මේ order එකට මේ readings එක ගන්න ඕනේ. Right. First one. Mass of empty calorimeter with stirrer. Mass of empty calorimeter with stirrer. Mass of empty calorimeter with stirrer. Right? Second reading. Mass of water, calorimeter with stirrer. Mass of water, calorimeter with stirrer. මේ M1 M2 ඒවා දාගෙන යන්න. First one is M1, right? Second reading is M2, right? Second mass is M2. Then third one, initial temperature of water. Third, initial temperature of water. Initial temperature of water, right? Next, initial temperature of, initial temperature of lead shots. Initial temperature of lead shots. Within brackets, 100 degrees Celsius. Within brackets, 100 degrees Celsius. මේක 100 ගන්න නැතුව කරන්න බැරි නෑ කරන්න පුළුවන්. But the thing is, we can't make sure all the lead shots has obtained that same temperature of the liquid of water here, right? එහෙම කියන්න බෑ, right? Lead shots කියන ඒවා solid material and solid medium එකක්. In between lead shots there are small gaps filled with air, right? In between lead shots, right? ඉතින් මේ වගේ gaps තියෙනවා මේ. මෙයාට එතකොට මෙයාට යන heat එක මෙයාට යන්නේ නැහැ සමහර වෙලාවට, right? ඒ නිසා ඒක අර මැද temperature එකදී කියන්න අමාරුයි. That's why we are focusing on the boiling point. Boiling point එකේදී at least it is going to be stable at 100 no. 100 වල ගොඩක් වෙලා තියෙනවනේ. Unless until all the water is vaporized, right? එතකොට ලොකු වෙලාවක් තියෙනවනේ. ඒ නිසා අපිට මේක අර error එක ගොඩක් minimize කරගන්න පුළුවන්. constant තියෙන හින්දා නැත්නම් එහෙම දැන් මේක by second to second, minute to minute, temperature of the system increases from room temperature to 100. right? වෙන එක කරන්න බැරි නෑ, කරන්න පුළුවන්. හැබැයි added error එකක් එනවා. right? Next reading, mass of lead shots, water, calorimeter with stirrer. Mass of lead shots, water, calorimeter with stirrer. Maximum temperature oh sorry, I missed one. What was the last number you wrote? 4, right? Then fifth should be fifth should be maximum temperature slash final temperature, maximum temperature slash final temperature reached by the system. Maximum temperature slash final temperature reached by the system. Maximum temperature slash final temperature reached by the system. Right? Next one. Mass of lead shots, calorimeter, water, calorimeter with stirrer. Right? So take a 6. Right? Then these three. 7. Specific heat capacity of lead. Say Cl. Specific heat capacity of lead, Cl. Right? 8. Specific heat capacity of water, Cw. Right? 9. Specific heat capacity of calorimeter, Cs. right? හරනේද කොටි මේ ඕඩේ එකේ තියෙන්න ඕනේ. ඕඩේ එක ආයි චෙක් කරන්න. right? අර 5 එක හරනේද 5 එක මම මිස් කරලා කිව්වේ. Fifth one should be the maximum of the final temperature reached by the system. Right? Then write down below. Write down below. Write down below. According to theory. Write down below. According to theory. Put a comma. According to theory. According to theory. According to theory. Put a comma and mention this. Theory එක මේකනේ. Right? එහෙනම් මේකට substitute කරන්න. M3 minus M2 Cl. Right? මේ terms එක හරියට ලියාගන්න. Right? According to theory, M3 minus M2 Cl brackets 100 minus theta 2, right, equals M2 minus M1 Cw theta 2 minus theta 1 plus M1 Cs theta 2 minus theta 1, right? මේක ඕනනම් within brackets දාලා ගන්න පුළුවන්. Theta 2 minus theta 1 is a common temperature, right? Another. Now go to method. Next method. Method. Right? Take down the diagram. Take down the diagram. It should be a Polish calorimeter. Minimize radiation. Yeah, minimize radiation. Yeah. Someone has answered. Good. Wire mesh means the same. Yeah, wire mesh. So, same. Wire mesh, square net, square goes, wire goes, everything are same. Should we draw the apparatus? No. You can draw now. Right? And label it accordingly. Label it accordingly. Right? We can label karna. Insulator supports, right? Insulated cover, right? This is insulator lid, right? This one thermometer, right? I'm making thermometer kila mega liya diba? Styrer, boiling tube, square net, lead shocks, tripod, Bunsen burner, Vega, heat insulated sheet. This is either Rigiform or asbestos. Remarks on Gianna. insulated supports, beaker, insulated cover, stirrer, right? Maybe in water. Right. Sometimes you might not get the fullest if you are from 27 batch, because if you haven't done thermal yet, right? Chat එක දැකලා කිව්වේ මේ thermal equations ටික දන්නේ නැත්නම් thermal equilibrium එක එකපාරට තේරෙන්නේ නැතුව ඇති, right? Then you should know the thermal equations in order to understand this properly. But it's like good to be here and know these things a little bit earlier than you are supposed to be, right? 27 වතින් thermal experiments එක කරගන්න පුළුවන් නම් මේ experiments වල 80% විතර කොහොමද තේරෙනවා, right? අර equations ටික ඉතින් familiar නැතුව ඇති. equations දෙකම use කරලා තියෙන ඉතින් ms මේක නම් 3ම ms తీරා. ms తీරා use කරලා තියෙන්නේ. right? ms తీරා c తీරා and ml ඔය equations තුනෙන් තමයි ඔක්කොම equilibriums ටික යන්නේ. finished? හරි? right. හරි? තියෙනවද? හරි මම කියන check කරගන්න. bowling tube, square net, lead shots, tripod, Bunsen burner, beaker, heat insulated sheet, insulator lid, thermometer, water, beaker, insulator supports, insulated supports, stirrer. Right? Right. Go to method. Method. Calorimeter. 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 හරි. හරිද ඔක්කොම ලේබල් කරලා නැති? තව ඕනනම් මේකත් පුළුවන්. This is called the stand, right? මේක දන්නවනේ. This is called the stand. ඒකත් ඕනනම් ඒකත් stand. හරිනේ? තව මොකුත් නැහැ. Right, that's it. Right, method. Go to method. Okay. Write down. First point, write down in point form. First point. Measure the mass of empty calorimeter with stirrer. Measure the mass of empty calorimeter with the stirrer within brackets M1. Right? Write in point form. Second point. Fill up water up to like this. Two-third of the height of calorimeter. Up to two-third of the height of calorimeter. And measure the mass of system. Measure the mass of system, that's it. Within brackets M2. Measure the mass of system within brackets M2. Right, next point. Measure initial temperature of water. Measure initial temperature of water. Measure initial temperature of water using thermometer. Measure initial temperature of water using thermometer. Next. Heat up. Heat up. Heat up. Lead shots. Heat up lead shots. Heat up lead shots to boiling point. To boiling point. Heat up lead shots to boiling point within brackets 100 degrees Celsius. Boiling point 100 degrees Celsius of water. Of water. Using boiling tube. Using boiling tube. Using boiling tube and Bunsen burner. 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 And mix heated lead shots and mix heated lead shots with water in calorimeter and mix heated lead shots with water in calorimeter. Mix heated lead shots with water in calorimeter. Right, next point. Next point. Start recording temperature. Start recording temperature. Start recording temperature. Start recording temperature of water each 30 seconds. Each 30 seconds. And record it. And record it. And record it while the system is well stirred. While the system is well stirred. While the system is well stirred. Next point. Note down the maximum temperature. Note down the maximum temperature. Note down the maximum temperature. Note down the maximum temperature reached by the system. Note down the maximum temperature reached by the system. Right, within brackets theta 2. Within brackets theta 2. Right. Next. Measure the final mass. Measure the final mass of system. Measure the final mass of system. Measure the final mass of system within brackets M3. Within brackets M3. Measure the final mass of system within brackets M3. Right, next point. Next point. Calculate specific heat capacity of lead. Calculate specific heat capacity of lead. Calculate specific heat capacity of lead. Specific heat capacity of lead within bracket CL. Using the equation discussed under theory. 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 Right, within brackets use standard values of CW and CS. CW and CS for calculations. CW and CS for calculations. Right? Ever standard value say no again. Copper ne? Make a copper ne? Since that is copper, that is 400. Heat capacity එක නම් 400. Right? Specific heat capacity එක නම් අපි lab එකේ ගන්න එකේ mention කරලා තියෙනවා ඒක ගන්න ඕනේ. Right? 3600 ඕම value එකක් තියෙනවා. ඊට පස්සේ water නම් ඉතින් අපේ usual value එක 4200. Right? Standard values use කරලා අනිත් calculation එක කරනවා. හරිනේ? අනිත් ඕනේ values ඔක්කොම ටික අපි මෙතනින් හොයාගෙන තියෙන්නේ. මේවා standard values මේ දෙක ගන්න ඕනේ. Right? Then using the equation we can calculate, because all other things are known, you can calculate CL. Right? Right. So basically this is what we do in the mechanism, in the experiment, right? In the methodology. මේක තමයි කරන්නේ. But this is not over yet, right? තව ගොඩක් දේවල් තියෙනවා. කියන්නේ precautions එහෙම ඒවා ගොඩක් වැඩි හොද. එහෙම තමයි හැටි. අන්න මේකට alternative එකකුත් තියෙනවා. ඒකත් මොකක්ද කියලා කියන්න. ඒ alternative එකෙන් කාලෙකින් ආවේ නැහැ. ඉස්සර ඇවිල්ලා තියෙනවා. ඉස්සර කියලා කියන්නේ I think it came somewhere between 2000 to 2010 ඒකෙන් ආව question එකක්. ඊට පස්සේ ආවේ නැහැ. දැන් ඒතර ගොඩ කාලෙකින් ඇවිල්ලා නැහැ. මොකක්ද කියලා කියන්න. මේක තමයි අපිට තියෙන එක. but මේකට alternatives තියෙනවා. Right. So before that, before moving on to remarks, any questions up to here about materials and apparatus, methodology, theory, these things? All right? All good? All right? All right? Right. Then let's move on. What about online? Online, any questions? So about the equation, I have used ms theta only, right? Ms theta. And for coming up experiments, we'll need all other equations also. You can ML එහෙම තියෙනවානේ. Then ඊළඟ එක latent heat නේ වන්න තියෙන්නේ. Latent heat එකට using method of mixtures, right? එතකොට ML එකත් ඕන වෙනවා. මේක use කරලා තියෙන්නේ ms theta විතරයි. What else? Right. Okay. Then let's go to remarks. Write down remarks. Right. Listen. Theta 1 is let shots temperature, water's initial temperature. Let shots are at 100 initially. Right? කෙලින්ම අපි value එක 100 කියලාම ගන්න ඕනේ. Right? නැත්තම් කියන්නේ 100 කියලා ගන්නද මම කලින් කිව්වේ. We can do the experiment to somewhere in between. But error in that case is very high. Right? ඒ නිසා අපි අර steady temperature එකට යන්න ඕනේ. දැන් මේකෙත් ඒක mention කරලා තිබ්බා මම දැක්කා mention කරලා තියෙනවා. mention කරත් නැතත් අපි 100 වල කරන්නේ ඒකයි. මේකේ තියෙනව නේද? yeah. After heating till the water boils කියලා point එකක් තියෙනව නේද? Even though that is mentioned as theta 2, that is 100 no. මම 100 එක use කරලා තියෙනවද? මේකේ point එකක් තියෙනවනේ. After heating till water boils. Right? ඒ කියන්නේ 100. 100 කියන එක indirectly කියලා තියෙන්නේ. මම 100 කියන එක use කරා. That's why I didn't use theta 1, theta 2 and theta 3, right? 100 is used as 100, right? And theta 1 and theta 2. හරිනේ? Okay. That's all. All right. Remarks. First point. Right. Listen. One thing is One thing, and the first thing is deciding the number of lead balls to use, right? දැන් ඒක එකපාරට decide කරන්න බෑ. lead balls දැම්මට පස්සේ මේක spill out වුණොත් අතින් අල්ලලා නවත්තන්න බෑනේ, right? ඒ හින්දා මේක එකපාරක් කරන්න කලින්, I mean, if you do the experiment, right? If you do the experiment, right, you have to do a controlled experiment, a prior experiment to this, and check whether how many lead balls are going to satisfy these water levels if you put in, right? එතකොට අපි water heat කර කර ඉන්න මේවා heat කර කර ඉන්න නෑ. නිකන් lead ටික දාලා බලනවා මේක spill වෙනවද කියලා, right? නැත්නම් එහෙම දැන් එකපාරට ඔයා මේක දාද්දි මේක 100 වල තියෙන්නේ. අතින් අල්ලලා අයින් කරන්නේ 100 වල තියෙන්නේ, right? ඔයා මේක දාද්දි මේක spill වෙනවා. එතකොට experiment එක වැරදිනේ ආයෙ කරන්න වෙනවනේ, right? ඒ වගේ වෙලාවට ඉතින් අර මුලින් කරලා බලනවා lead shots කීයක් ඇයිද කියලා, right? එතකොට ඒක decide කරගන්නේ මෙතනින්, right? මෙතනින්, right? Write down first point. Number of lead shots to be added. Number of lead shots to be added. Number of lead shots to be added should be decided. Number of lead shots to be added should be decided. Number of lead shots to be added should be decided by doing a pilot experiment. By doing a pilot experiment. Pilot experiment. Pilot කියන්නේ pilot කියලා කියන්නේ අර හරියට කරන්න කලින් කරන එක pilot experiment. Pilot experiment. plane පදින එකම තමයි ඒකට කියන්නේ pilot experiment කියලා. Right? Pilot experiment. Before the actual experiment, right? Within brackets, write down. Water should not spill out. Water should not spill out. Water should not spill out. Water should not spill out when lead shots are added. When lead shots are added to calorimeter. When lead shots are added to calorimeter. Water should not spill out when lead shots are added to calorimeter. Right? Second point. Lead shots are initially heated. Lead shots are initially heated to 100 degrees Celsius. Lead shots are initially heated. Lead shots are initially heated to 100 degrees Celsius. Lead shots are initially heated to 100 degrees Celsius to maintain a constant temperature. To maintain a constant temperature. To maintain a constant temperature. Right? Within brackets, boiling point of water. Within brackets, boiling point of water. Right. Listen, next. So about the height to be filled water is a very popular question when it comes to questions, right? එතකොට අපි ඒක කෙලින්ම 2h/3 කියලාම තමයි කියන්නේ. That is 2h/3, right? ඒතර 2h/3 වලට වඩා අඩු වුණොත් මොකද වෙන්නේ? වැඩි වුණොත් මොකද වෙන්නේ වගේ ඒවා අහනවා. Right? වැඩි වුණොත් ඒක තේරෙනවනේ. Then it is going to spill out. Right? අඩු වුණොත් percentage errors are going to be higher because lead shots are heated to 100. Right? ඒතර lead shots වල තියෙනවා ලොකු heat එකක්. If this water amount is not enough to absorb all heat that is given by lead, then the experiment is again it's going wrong, right? එහෙනම් මේකට අර adequate amount එකක් ඕනේ. So as the standard adequate, we go with 2h/3, right? අර half වගේ දාන්නෙත් නැහැ. half වගේ දාන්නෙත් නැහැ. තව ඉඩ තියෙනවා නම් ඉතින් අපිට ඒ amount එක use කරන්න පුළුවන් නේ. ඒතර percentage එක අඩු වෙනවනේ, right? ඒතර දැන් මේක half දාලා ඉතුරු භාගයක්ම lead දැම්මොත් මේක මැද ටෙම්පරේචර් එකට ගන්නත් බැරි වෙනවා. right? ඒ කියන්නේ water ටිකමදි අතන තියෙන heat එක absorb කරන්න. එහෙම scenarios වෙනවා. right? So therefore Therefore, only 2H over 3 is put, and for the remaining volume here, 1 over 3 is remaining, no? For the remaining volume, let shots are used. Right? So, we balance, no? We balance, no? Right? Empty space is empty space is because we have to minimize percentage errors as much as possible. Right? If there are empty spaces, you are not going to go to the minimum possible values of percentage errors, no? Right? At there on may space utilization not thone. At the same time, you have to make sure that this amount of water is enough to absorb all heat released by lead shots. Right? Next point. Water is added only up to this one, 2H over 3. Water is added only up to 2H over 3. Water is added only up to 2H over 3 of height of calorimeter. Right? Within brackets, there should not be any spill of water. Within brackets, there should not be any spill of water when lead shots are added. There should not be any spill of water when lead shots are added. And amount of water should be enough. An amount of water should be enough to absorb all heat released from lead shots. Right. Listen. Then the other main constraint we have is heat loss to environment. No? Other main constraint we have here is heat loss to environment. Right? We can't make it 0, but we can do our best to minimize it. Right? ඒකට තමයි මේ තුන use කරේ. Right? මම දැන් කලින් කියවනේ. What are the three main ways of transfer of heat? Conduction, convection, and radiation. Right? Now we have to address each one separately. Right? මේ ටික address කරන්න තමයි මේ ටික කරලා තියෙන්නේ. Right? Write down to minimize heat loss to environment. To minimize heat loss to environment. Following precautions are taken. To minimize the heat loss to environment. Following precautions are taken. Right? Mention them one by one. First one, conduction. Right? If I minimize conduction, first one, conduction. What has done to minimize conduction? Keeping calorimeter on insulator supports. Right? Write down here, keeping calorimeter on to minimize conduction, keeping calorimeter on insulator supports. Right? Then convection. Using a heat insulated lid. Using a heat insulated lid to cover calorimeter. Using a heat insulated lid to cover calorimeter. Right? Next one, radiation. Radiation. Covering calorimeter. Covering calorimeter. Covering calorimeter. Covering calorimeter. With heat insulators. Covering calorimeter with heat insulators. Within brackets, air or rigiform. Air or rigiform. Air medium එක තියන්න පුළුවන් because air itself is a good heat insulator. Right? Rigiform තියෙනවා. Rigiform වලින් cover කරාට පස්සේ ඒක තවත් minimize කරන්න පුළුවන්. Right? And මේකට තව එකක් තියෙනවා. And use a polished calorimeter. Use a polished calorimeter. Within brackets, shining surfaces. Right? Polishing කියලා කියන්නේ surface shine වෙලා තියෙන්න ඕනේ. Right? එතකොට මොකක්ද ඒකේ minimize වෙන්නේ? දැන් මම වෙන එකක් අහන්න දැන්. To minimize radiation, how it happens when it is polished? How it works when it is polished? කොහොමද radiation එක minimize වෙන්නේ if the surface is polished? polish කළා මම address කරන්නේ මොකද්ද? ඒක තමයි තේරෙන්න ඕනේ. What is the equation of radiation? Heat radiation. Heat radiation කියලා අපි මොකද්ද කියන්නේ? කොහෙද ඒක කතා කරන්නේ? Matter and radiation. Right? Heat radiation කියලා කියන්නේ radiation and black body radiation. What is the equation? Stefan's law. Stefan's law එකෙන් මේක වැඩ කරන්නේ. Stefan's law. Stefan's law එකේ තියෙනවානේ if there is not a black body we have a E coefficient of surface emissivity. Right? Surface emissivity එක තමයි අඩු කරන්නේ. Because in white smooth surfaces emissivity is less. Right? දැන් shine වෙනවා කියලා කියන්නේ ඒක smooth වෙනවා. Smooth කියලා කියන්නේ radiation අඩු වෙනවා. Right? එහෙමයි ඒ වැඩේ වෙන්නේ. වැඩේ link වෙන්න ඕනේ. හරිනේ? Right. Radiation එකක් දෙවනේ. Then next මේකට තව වැඩක් කරනවා. හරි මේ තුන ඉවරයි. Then we are using another technique. මේක ටෙක්නික් එකක්. We are using another technique to minimize loss of heat. Right? To minimize loss of heat. In thermal physics we call it heat compensation method. මේක ටෙක්නික් එකක්. Right? පොඩක් අහගන්න. මේක ස්පෙෂලි දැනගෙන ඉන්න ඕනේ. Heat compensation. Heat compensation method. Right? අපි මේ use කරන ටෙක්නික් එකක්. Heat compensation method. Listen. Right? මේක අපි experiments තුනක වගේ use කරනවා. We are using the same heat compensation method in four experiments in thermal. Right? එතකොට මේක අනිවාර්යෙන් දැනගෙන ඉන්න මම මෙතෙන්දි මේක explain කරන්න. ඉස්සරහා experiments වලත් මේක මම දැන් කියනවා. Right? Heat compensation means this. Right? When we start the experiment, right? We are starting the experiment 5 degrees Celsius below room temperature. Right? I set කළා වැඩේ අඩු කරගන්න ඕනේ. You are starting the experiment 5 degrees below. Let's say this is room temperature. Right? We are starting the experiment 5 degrees below. Right? 5 degrees Celsius below room temperature. Right? And finally, we are finishing this. Completing the experiment around 5 degrees above room temperature. Right? එතකොට දැන් මේ 5 degrees වලට යනවා කියන එක අපිට එකපාරින් decide කරගන්න බෑ. මේක 5 degrees වල ගිහලා නතර වෙයි කියන එක. Right? ඒ වගේ වෙලාවට අපි pilot experiment එකක් කරලා බලනවා. pilot එකක් කරන්න නැතුව කියන්න බෑ. Got it? pilot එකක් කරාම මම මේක 37 වලට යනවා නම් හිතන්නකෝ දැන් මේ room temperature 30 කියලා. If the room temperature is 30, right? We are going to start at 25 and it should be finished at 35 no. Right? 35 වලට යනවාද කියලා මට එකපාරින් කියන්න බෑනේ. Right? ඒකට අර pilot experiment එකක් කලින් කළා වගේම right, you have to do this same thing as a pilot experiment again and check whether it is reaching 35 or 36 37 මොකද්ද වෙන්නේ කියලා 37 වගේ වුණා කියන්නකො එහෙම වුණොත් lead shots ගන්න තව අඩු කරලා ඒක balance කරගන්න ඕනේ right මේක කරන්නේ මේකයි now when temperature of the system is less than room temperature right when temperature of the system is less than room temperature right we know always heat flows from high temperature to low temperature right when this is less than room temperature heat flows from environment to system එහෙම heat එකක් එනවනේ ඒක නැති කරන්න බෑ right there's a heat flows from environment to system simply system absorbs heat from environment right when it is less than 5 and it absorbs heat from environment it absorbs heat from environment from -5 නෙමෙයි from 5 to 5 degrees less to room temperature right then when it is heated beyond room temperature right when it is heated beyond room temperature higher temperature is at the system then system is going to emit heat to the environment right ඒකනේ heat loss එක කියන්නේ then this is going to loss heat right emit heat absorb heat and loss of heat loss heat to the environment right approximately absorbed heat from here to here is equal to emitted heat from the system from here to here from the system right ඒක හරිම reasonable argument එකක් ඒක හරිම reasonable කියලා කියන්නේ now say room temperature is 30 today right now room temperature is 30 and you are starting the experiment at 25 now from 25 to 30 there is a amount of heat absorbed to the system right and when the system increase from 30 to 35 again the gap is same no under same conditions gap is same right so therefore it is going to lose the same amount of heat approximately the same ඒක same කියලා අපිට argue කරන්න පුළුවන් approximately the same amount of heat to the environment again during this time right ඉතින් මේ දෙක equal නම් right which means net loss of heat or net absorption of heat is zero right මේක අපි කරන precaution එකක්. ඒතර absorption එකක් විතරක් හරි emission එකක් විතරක් හරි තිබ්බොත් මෙතන issue එක වෙන්නේ. Got the point? Now if you start from 30, say you are starting from 30 right and finishing at 40 then from 30 to 40 there is only an emission ඒ කියන්නේ කොහොමද loss එක නැති කරගන්න විදියක් නැහැ right that is why this is called compensation මේක loss වෙනවා ඒක නැති කරන්න බෑ but we are going to compensate right compensate කියන එක තේරෙනවනේ compensate කියනවා කියන්නේ අර we are going to cover up something with this දැන් cover up එකක් වගේ compensate කරනවා කියන්නේ cover up එකක් වගේ right මේ වෙච්ච එක මේ වෙන්න යන එක මේකෙන් cover කරගන්න හදන්න right you are going to cover up this right cover up this emission using this emission එකක් විතරක් වුණොත් issue එක තියෙන්නේ ඒ හින්දා මේක අඩු කරනවා right that is called heat compensation method and very popularly used in heat experiments right so most importantly heat compensation is not a method to minimize loss of heat එහෙම කරන්න බෑ that is to compensate the loss of heat minimize වෙන්න heat loss එක කොහොමද තියෙනවා right හැබැයි absorption and loss is going to cancel each other and it is going to be compensated that's the thing right ඒතර ultimate impact එකක් නැහැ got it ඕක තමයි point එක නේද heat loss එක minimize කරන්න compensate කරලා බෑ හොඳේ heat loss එක minimize කරන්න තමයි මේ තුන කරේ හරිනේ වැඩේ clear නේ heat loss එක minimize කරන්න තමයි මේ තුන කරලා තියෙන්නේ මේ වැඩේ කරන්නේ අර additionally තව මේ එන heat loss එක compensate කරලා දාන්න right එතකොට මට අර worry වෙන්න දෙයක් නැහැ මේකට heat loss එකක් වුණාද කියලා even if there is a heat loss there is a heat loss non zero right even if there's a heat loss that is compensated with the heat comes into the system here right මේ ආපු ටිකනේ එතකොට මෙතන එළියට ගිහිල්ලා තියෙන්නේ අවුලක් නැහැ right ඕක තමයි point එක right next point heat compensation method is used next point heat compensation method is used 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 to compensate heat throughout the time, the experiment is conducted. Throughout the time, the experiment is conducted. Right? For the same point, write down. You better use a red pen. Write down this with a red pen. Write down this with a red pen for the same point. Start the experiment. Start the experiment. Start the experiment. Start the experiment. 5 degrees Celsius less than room temperature. Start the experiment 5 degrees Celsius less than room temperature. 5 degrees Celsius less than room temperature. And finish the experiment 5 degrees Celsius greater than room temperature. Right? Within brackets, keep using the red pen. Within brackets, absorbed amount of heat into the system. Absorbed amount of heat into the system from environment. Absorbed amount of heat into the system from environment from initial temperature to room temperature. From initial temperature to room temperature. From initial temperature to room temperature is approximately equal to emitted slash lost amount of heat from system to environment. From system to environment. From system to environment. From room temperature to final temperature. From room temperature to final temperature. Right? So we'll be using heat compensation method in coming up ones also, right? So මම ආයෙ explain කරන්න method එක. We'll be just mentioning as heat compensation, right? So method එක මෙතනින් මතක තියාගන්න. Right. Next thing. Now ඒකෙන්නේ මේකත් එක්ක. Now we are going to minimize temperature. We are going to reduce temperature 5 degrees less than room temperature, no? Right? What if we reduce this temperature less than the dew point of that particular day? What's going to happen? Dew forms, right? Dew හැදෙනවා කියලා කියන්නේ මොකද්ද වෙන්නේ? What about heat? Heat transfer එකක් වෙනවනේ. Forming dew means, right? There is a heat absorbed by dew when dew is going to vanish. When dew is going to go to the gas layer again, air layer again, right? එතකොට අපිට මේ calculation එකට ඕන නැති heat loss එකක් එනවනේ. Dew form වුණා. Right? හදිස්සියට මේක dew form වුණා. මෙහෙන මෙතන තමයි dew form වෙන්නේ හොද? කොච්චර මේකේ ඉන්සුලේටර් කවර්ස් දාලා තිබ්බත් මේක තියෙන්නේ මේ temperature එකේනේ. Right? එතකොට යා medium එකේ තියෙන water particles අතුලට එන එක අපිට එහෙම එච්චර seal කරලා නවත්තන්න බෑ. Right? It comes in and dew forms. අපිට පේන්නෙත් නෑ එතකොට. මේ inner bowl එකේ dew හැදෙනවා. Right? If dew forms, dew is going to absorb an additional heat and you are going to make an error in that equation, right? මම equation මගලා දෙන්නේ. equation එකේ ඒතර වරදිනවනේ. right? එතකොට ඒකට කරන්නේ මේකයි. First you have to find the dew point of this day, right? Rough dew point. dew point එක හොයාගන්න පුළුවන්. right? dew point එක හොයාගන්න lab එකේත් ඕනනම් instrument එකක් තියෙනවා. එහෙම නැත්නම් ඉතින් දැන් apps කියන්නේ ඕනේ weather app එක dew point එක වෙනවනේ. Just know the dew point. Say dew point today is 22, right? Then you have to make sure that you are not going to reduce this to 22, right? එතකොට 22 නම් minimum 2 degrees Celsius above අපි යෝග තියෙනවා. right? 24 වගේ වෙනකන් තමයි reduce කරන්නේ. එතනින් එහාට අපි reduce කරන්නේ නැහැ. right? ඒ හින්දා ඒකට අපි dew point එක දැනගෙන ඉන්න ඕනේ. initial dew point එක හොයාගන්න. right? next point. next point. next point. next point. ensure initial temperature of system is not reduced. ensure initial temperature of system is not reduced. ensure initial temperature of system is not reduced. ensure initial temperature of system is not reduced beyond dew point. beyond dew point. right? next point. right, listen. Next point is about taking these recordings for each 30 minutes, right? 30 minutes and a 20 minutes and a 20 minutes, 20 seconds and a 30 seconds and a right? For a constant duration of time, you have to take readings because otherwise that maximum temperature is not going to be sensible, right? If you are just looking at the thermometer, right? ඒක අමාරුයි. right? අපි නිකන් මේ mercury glass thermometer එකක් දිහා බලාගෙන ඉන්නේ, right? mercury glass thermometer එකක් දිහා බලාගෙන ඉන්නේ, right? එතකොට අපිට නිකන් decimals values වගේ ඒවා මතක තියාගන්න බෑනේ. it is not practical actually. that's the thing, right? දැන් මම මේක දිහා බලාගෙන ඉන්නවා බලාගෙන ඉන්නකම් say now it is 62.5 62.6 62.7 නොහොම යනවා. ඊට පස්සේ මොකෙක් හරි එකේ කතා කරනවා දැන් මේ එක්ස්පෙරිමන්ට් එක කරද්දී. හරිද? ඊට පස්සේ බලද්දී මේක අඩු වෙලා. ඒතකොට maximum එක 62.7ද නැත්නම් ඊට වඩා එකක් ගිහිල්ලා drop උනේ දන්නේ නැහැ. ඒකට තමයි රෙකෝඩ් කරගන්නේ. දිගටම රෙකෝඩ් කරගන්නවා for each 20 seconds or 30 seconds, right? 20 වෙන්න පුළුවන් 30 වෙන්න පුළුවන්, right? 10 වගේ නම් අඩු කරන්න ඕනේ නැහැ. අපි average එකක් විදිහට 30 වගේ තමයි ගන්න. ඒතකොට එක මිනිත් එකක් ඇතුලේ දෙපාරයිනේ මට readings ගන්න තියෙන්නේ. it's a quite enough value. right? next point. identifying the maximum temperature. Identifying the maximum temperature reached by system is not practical unless variation of temperature is recorded over time. For the same point, write down for this temperature of water should be recorded for this temperature of water should be recorded for each 30 seconds or 20 seconds, right? 30 තමයි අපේ normal value එක, right? 20 වුණත් පුළුවන් 20 වුණත් තුන් පාරක් ගන්නවා එක මිනිත් එකක් ඇතුලේ. 30 seconds to identify maximum temperature. Right? Okay, so basically that's it about this one also, right? මේ මම කලිනුත් කිව්වා වගේ thermal experiments වල ඇටි තමයි Methodology is easy. මුලින් methodology එක හොඳට පාඩම් කරගන්න. Methodology එකට අග්ගල පාඩම් කරන්න පුළුවන්. Methodology එක විනාඩි 5ක්වත් යන්නේ නැහැ. When you study this, right? It doesn't take even more than 5 minutes for the methodology, theory, methodology, right? ඊට පස්සේ ටිකක් thoroughly go through කරන්න ඕනේ මේ remarks කියන දේවල්. Because they are questioned in all questions, right? In all the questions මම කරපු discuss කරපු questions වලත් දැකලා ඇති, right? Past papers වලත් දැකලා ඇති, right? That is question to the points in all the questions, right? ඒ ටික නම් මතක තියාගන්න වෙනවා. right? එහෙම නැත්නම් ඒවා හිතලා ලියන්න බෑ. හොඳේ ඔය remarks වල ඒවා සමහර දේවල් පුළුවන් හිතන්න. සමහර දේවල් ගොඩක් ඒවා බෑ. right? එකපාරට හිතෙන්නේ නැහැනේ. right? ඒකට ඉතින් අනිවාර්යෙන් බලලා තියාගන්න. right? So let's quickly go through what is given here. right. right. notes වල තියෙන ටික බලන්නකො. Take the calorimeter with its external covering to the place where the lead shots are being heated. If not, place a heat insulated obstacle between the water. පිරයන් කරනවා. තව පොයින්ට් එකක් මට මෙන්ෂන් කරන්න තියෙනවා. මේක මෙන්ෂන් කරේ නැහැ. මේ this is not in the guide, right? මේක guide එකේ නැහැ. ඒක මෙන්ෂන් කරේ නැහැ. right. මේ අනිත් පොයින්ට් එක ලියන්න. last point. A heat insulated sheet. 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 Within brackets, rigiform කියලා යන දන්නවනේ. දන්නවද? RIGI. Rigi කියලා එන්නේ. RIGI rigiform. right? Within brackets, rigiform or asbestos. Rigiform or rigiform or asbestos. Asbestos කියලා කියන asbestos කියලා කියනවා. right? Cross brackets should be used in between boiling tube and calorimeter. Be used in between boiling tube and calorimeter. In between boiling tube and calorimeter. Boiling tube and calorimeter. To prevent direct heat from Bunsen burner. To prevent direct heat from Bunsen burner. Reaching the calorimeter. To prevent direct heat from Bunsen burner reaching the calorimeter. right? ඒ කියන්නේ වෙන්නේ දැන් මේක නැතුව මේක ළඟ තියාගෙන මේ වැඩේ කරොත්, right? මේ වැඩේ කරොත් ළඟ තියාගෙන, right? This is going to absorb some heat, right? Initially from the burner itself. burner එකෙන් මේකට heat එකක් එනවා. ඒ heat එක අපිට capture වෙන්නේ නැහැ, right? ඒ කියන්නේ capture වෙන්නේ නැහැ කියලා කියන්නේ ඔයා initial temperature එකත් measure කරගෙන, right? initial temperature එකත් measure කරගෙන දැන් මේක අරගෙන මේ පැත්තට දානවා. right? Bunsen burner එක මෙතන තියෙනවා. system එකක් මෙතන තියෙනවා. right? ඒතර මේ net එක heat වෙලා තියෙන්නේ. tripod එක පොඩ්ඩක් heat වෙලා තියෙන්නේ. burner එක තියෙනවා. ඒතර මේක direct heat එකක් එනවා. right? අන්නේ heat එක නැති කරන්න ඕනේ. හරිනේ? ඒතර දැන් එහෙම කියලා මේක sheet එකක් තියන්න නැතුව මේක ගොඩක් දුර තියාගෙනත් බෑ. because if you are when you are taking lead shots at 100, right? Instantly you have to put it to the calorimeter because lead means that is a very good heat conductor. lead නේ. හොඳ heat conductor එකක්. ඔයා නිකන් එයා medium එකේ 30 seconds යන් හිටියත් ඇති මේක ටක් ගාලා 98 විතර drop වෙනවා. 98 97 වෙන එක ටක් ගාලා drop වෙනවා. එහෙම තමයි හැදෙන්නේ. එයා හොඳ heat conductor එකක්. ටක් ගාලා එයා heat conduct කරනවා අනිත් පැත්තට එයා medium එකට. right? එහෙනම් මේක ළඟ තියෙන්නත් ඕනේ. ඒකයි මේක use කරන්නේ. ගත්ත ගමන් මේ පැත්තට දාන්න පුළුවන් වෙන්න ඕනේ. right? okay. මේකේ first point එක තියෙන එක ගන්න මේක ගැන. right? මට මේක මිස් වුණා කියලා මතක් වුණේ ඒක කියවද්දි. take the calorimeter with its external covering කියන්නේ මේකට, right? insulated cover, right? place where the lead shots are being heated. If not, place a heat insulated obstacle between the ඒක තියෙනවා නේද? heat insulated obstacle කියන්නේ මේකට. Right? Heat insulated obstacle කියන්නේ මේකට. Heat insulated sheet. Right? Second one, when the lead shots are being transferred to the calorimeter, care should be taken to prevent splashing out of water. Right? ඒක තේරෙනවනේ. ඇයි නැත්තම් මේ මෑස් එක වෙනස් වෙනවනේ. Right? ඒ කියන්නේ අර නිකන් උඩ ඉඳන් මෙහෙම දාන්න නෑ. එහෙම දැම්මොත් කොහොමත් මොකක් හරි ඉන්ජරි එකකුත් කරගන්නවා. ඒ කියන්නේ එහෙම දාන්න බෑ. මේක 100 වල තියෙන මේක කෙයාෆුලි කරන්න ඕනේ එක්ස්පෙරිමන්ට් එකක්. නිකමට ලෙඩ් ෂොට් එකක් එළියට වැටුණා කියන්නෝ. ස්කින් එක හිල්ලලා යනවා. يعني ඒක එන්නම කෙයාෆුලි කරන්න ඕනේ එක්ස්පෙරිමන්ට් එකක්. රයිට්? මේක අර මේකකින් අල්ලන්න එතකොට අතින් එහෙම අල්ලන්න බෑ. මේක රත් වෙලා තියෙන්නේ. අර මේ ග්‍රැබ් එකෙන් අල්ලලා මේ කෙලින්ම මේ පැත්තට දානවා. ඒ කියන්නේ ඒක අපි මෙතන ග්‍රැබ් කරගෙනම ඉන්නේ මේ වැඩේ යද්දි. රයිට්? ග්‍රැබ් කරගෙනම ඉඳලා කෙලින්ම මේ පැත්තට දානවා. රයිට්? prevent splashing of water and observe the thermometer reading very carefully. Right? ඒකට තමයි අපි රෙකෝඩ් කරගන්නේ. Since lead is a good conductor, මේ අර point එක. The mixture reaches the maximum temperature very soon. Right? ඒකයි මම කිව්වේ. This whole experiment is done in less than 5 minutes of time. ඒ කියන්නේ 2.5 5 minutes වගේ time එකක් වෙද්දී මේ වැඩේ ඉවරයි. මේක යා medium එකේ තිබ්බත් මෙයා ඩක් ගාලා heat එක loss කරනවා. Right? ඒකයි ඩක් ගාලා මේ පැත්තට දාන්නත් ඕනේ. හරිනේ? This method can be used to determine the specific heat capacity of a liquid by using right ඒක කියන්න. pilot experiment මේ දින මේ pilot experiment කියන වචනේ අර කට්ටිය අහලා තිබුණේ නේද? ඒකට කියන්නේ pilot experiment නේද? ඒක දැනගෙන ඉන්න ඕනේ. right? pilot කියලා කියන්නේ මම කියවනේ if you are doing a prior experiment to the actual one, right? That is called a pilot experiment. right? අපි hikes යද්දිත් ඔක් කියන. ඒ කියන්නේ ඒක සාමාන්‍යයෙන් use කරන term එක pilot hikes කියනවා. right? දැන් pilot කොහේද ඒක මතක් කරගන්න. pilot hikes කියනවා. pilot hikes කියලා කියන්නේ now if none of us මම කියන්නේ campus එකේද if none of us from the club in the university is not been to a particular peak, right? Then whole bunch is not going to go there at once, right? එතකොට දැන් හිතන්න 30ක් 40ක් ගිහිල්ලා ඔක්කොම ටික මරනොත් මොකක් කරුණොත්, right? Then what we do is, right, like 3 or 4 people from us are going on a pilot hike and finding the routes, water sources, camping places, right? Camping sites, right? Trail කියන්නේ route එක, routes, bus availability, right? Food ඕනේ හොයාගන්න දේවල් තියෙනවනේ. ඉතින් ඒව කරන්නේ pilot එකක් ගිහිල්ලා. ඒක කියනවා pilot කියලා. Pilot hike. Right? So likewise, if you are doing something prior to that actual occurrence, right? That is always called a pilot. Right? ඒකට තමයි pilot එකක් කියලා කියන්නේ. ඒක තව එක එක තැන්වල use කරනවා. ඔයගොල්ලෝ සමහර තැන්වල අහලත් ඇති. pilot කියන වචනේ use කරනවා කියන්නේ අර මෙයා නැතුව කවුද aviation pilot නැතුව pilot කියන වචනේ use කරන තැන තව අහලා ඇති. එහෙම තැන් තියෙනවා. right? okay. pilot interviews තියෙනවා. pilot interviews තියෙනවා. right? mock interviews කියලා සමහර mock නෙමෙයි pilot කියලා වෙනම එකක් තියෙනවා. mock කියන්නේ pilot වගේ එකක්. pilot interviews තියෙනවා. right? ඔය කේකේව තියෙන එක තැන්වල ඔක use කරනවා. right? mock කියලා සමහර companies වල ඒක use කරනවා. ඒ කියන්නේ before the actual one, right? To break ice and break your like nervousness and all these things, pilot එකක් තියෙනවා. ඒක පොඩ්ඩක් comfortable නේ. ඒ වගේ තියෙනවා ඉතින්. හරි. That's it. The pilot experiment should be done to decide the amount of lead shots to be used to mix in order to the temperature of rice will about 10. හරි. අර මේ point එක. දැන් මේක 35 හරි after rising to 10 degrees Celsius should stop no, right? ඒතර ඒකට pilot එකක් කොහොමද කරන්න එක මම කියවනේ. Method of compensation can be used as remedy for the loss of heat. right? මේ ඒකනේ ඒක. හරිනේ. In the above process, care should be taken to have the initial temperature of water a few degrees above the dew point. ඒකත් කියවනේ. right? එහෙම නැත්නම් dew form වුණොත් හරි. dew form වුණොත් කොහොමද තර එකක් එනවා. ඒක නැති ගන්න බෑ. right? and දැන් තව කිව්වේ නෑනේ. මොකද්ද? මං කිව්වා මේක තව එකක් තියෙනවා ඒකත් කියන්න කියලා. මොකද මේක ඉවරයි. that's it. මේකට alternative එකක් තියෙනවනේ. right? alternative එක කරන්නේ මෙහෙමයි. listen. There is another alternative here. right? This is over. right? alternative එකක් කියලා මේ ඉතින් වැඩේ ඉවර කරමු එතකොට. ඒක ආවත් ඉතින් අවුලක් නෑනේ. right? මේක labs වල තියෙනවද? මේක සමහර ලාවට හැම lab එකේම නෑ. but මේක සමහර lab වල තියෙනවා. right? මේක සමහර lab වල තියෙනවා. listen. මෙන්න මේක. මේක රිප්ලේස් කරන්න පුළුවන් මම මේක ආයෙ අදින්න. දැන් ලේබලින් එක නැත්තම් වැඩේ කරලා යනවනේ. right. මෙන්න මෙහෙම එකක් තියෙනවා. this is called Nicholson heater. Nicholson heater. හරිද? Nicholson heater එක lab එකේ තියෙනවා. ඒක lab එකේ නැත්තම් මෙහෙම කොහොමද කරන්න වෙනවා. right. හැබැයි ගොඩක් labs වල Nicholson heater එක තියෙනවා. right. Nicholson heater කියලා කියන්නේ මෙහෙම එකක්. Nicholson heater කියලා කියන්නේ බලන්න. In Nicholson heater there's a outlet like this, right? මේක මේ වැඩේටම හදලා තියෙන එකක් හොඳ. මේක නිකන් අර displacement container එක වගේ. This is made for this. Made for this. right? මේකට water දාන්න පුළුවන්. ඊට පස්සේ මෙතන පොඩි door එකක් තියෙනවා. මෙතන මෙහෙම door එකක් තියෙනවා. right? ඊට පස්සේ දැන් calorimeter එක මෙහෙම තියෙනවා කියන්නකො. this is the calorimeter. මම දැන් අනිත් ඒවා ටික ගන්නෙ නෑ. හරි? listen. ඊට පස්සේ මේකේ thermometer එක දාන්න පොඩි mechanism එකක් මෙහෙම තියෙනවා. right? මෙතන පොඩි මේකක් තියෙනවා. this is made. right? මේක ගානට අර මේකක් තියලා තියෙනවද? thermometer එක දාන්න පුළුවන් වෙන. right? ඊට පස්සේ මේකට water දාන්න පුළුවන්. මේක උඩින් open කරන්න පුළුවන්ද? මෙහෙම තියෙන්නේ මේක tripod එකක තියෙන්නේ. Nicholson heater එක heat කරනවා. right? මේකටත් external Bunsen burners දාන්න නැතුව කරන්න පුළුවන් Nicholson heaters උත් තියෙනවා. external එක දාන්න ඕන ඒවාත් තියෙනවා. දෙකම තියෙනවද? ඒ කියන්නේ a mechanism to heat Nicholson heater is inside it in some Nicholson heaters. right? මේව තියෙනවා. ඊට පස්සේ මෙතනට දානවා LED shots එක. මෙතනට දානවා කියන්නේ මෙතන තමයි ඒ ටික තියන්නේ. right? මේක පොඩ්ඩක් safe. මේක safe කියලා කියන්නේ this is safe compared to this method, right? Because there are some mechanism here to pull this off. right? once this reach the boiling point, right? මේක මෙහෙම තියාගන්නවා දැන්. ආයෙ අර එහෙට මෙහෙට ගෙනියන්න දෙයක් නෑ දැන්. මේක මේ පැත්තට ගන්න ඕනේ. right? මේකේ තියෙන්නේ මෙතන පොඩි තියෙනවා මේ මොකක්ද ඒකට කියන්නේ? ලොක් එකක් වගේ එකක්. to pull it off, right? ඒක අයින් කරපුවා මේ lid එක open වෙනවා. ඒක lid එක අයින් වෙනවා. lid එක හොඳේ මේ තියෙන lid එක. මේ lid එක අයින් වෙනවා. අයින් වෙච්ච මේ ටික ඉතින් මෙතන දාලා වැටෙනවා. that's it. right? so ඒක ටිකක් safe. එතකොට අර මේ එළියට වැටෙයිද? ඒ කියන්නේ දැන් මේක මම අර බොයිලින් මේ ටියුබ් එකෙන් අරගෙන දාන්න ඕනේනේ. එහෙම යද්දී දැන් මේක මේ පැත්තට තියෙන එක මේ පැත්තට වෙනස් කරන්න ඕනේ. ඒක හිතන තරම් ලේසි නෑනේ. හරිද? මේක ඕපන් ටියුබ් එකක්නේ. ඉතින් ඕපන් ටියුබ්. මේකේ තියෙන ලෙඩ් shots මෙහෙම කරලා මේ පැත්තට දාන්න යන්නේ. එතකොට slowly දාන්නත් ඕනේ. splash උත් වෙනවා. right? ඊට පස්සේ මේ ටික ඔක්කොම ටික දාන්නත් ඕනේ. ඒ නිසා ඒකට මේ solution එක තියෙනවා. but this is not the experiment we have in our guide. right? මේක guide එකේ නෑ. හැබැයි මේක අහලා alternative එකක් කියලා මේක අහන්න පුළුවන්. එතකොට දෙකම හරිනේ. එහෙම cases තියෙනවනේ. right? මේක guide එකේ දාලා නෑ. අපිට තියෙන්නේ මේක හොඳ. හරිනේ වැඩේ කියන්නේ. තියෙන්නේ මේක alternative එක මේක. right? සමහරවිට මේක කරලා දෙනවා නම් මම මේ කියන එක දන්නවා ඇති. right? if you have done this experiment already in your schools, right? sometimes you might have seen Nicholson heater. anyone? nah? seen? where's no? royal online? anyone has seen Nicholson heater? මේ තාම තියෙනවද? අපේ ඉස්කෝලේ තිබ්බා. අපේ මෙහෙ තිබ්බා. දැන් ගන්නත් දන්න එළියට තිබ්බා. ඉස්සෙල්ලා නම් තිබ්බා. anyone has seen Nicholson heater? no? නෑ වගේ. හරි මේකත් ලියා ගන්නකො. වැඩේ තේරෙනවනේ. මේකෙනුත් වැඩේ කරන්න පුළුවන්. right? using Nicholson heater. Nicholson. right? take it down first. take it down. Right, take it down. මෙයා තමයි අපේ alternative එක. Nicholson heater. Right. නිකමට දැනගෙන තියාගෙන ඉන්න හදිස්සියාරි આવොත් ඉතින් දන්නේ නැහැ කියන්න බෑ. That is the Nicholson heater. Right, ඒක ඉතින් පොඩ්ඩක් safe. ඒක තමයි තියෙන advantage එක. Finished. Right, write down below. Nicholson heater can be used as 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 an alternative can be used as an alternative to boiling tube, alternative to boiling tube, to add lead shots safely into calorimeter, to add lead shots safely into calorimeter. Right, that's it. Right, මේ වගේ ඩයග්‍රෑම් එකක් නිකමට ආව කියලා හිතන්නකෝ. ආවොත් ඉතින් බය වෙන්න එපා. නිකල්සන් හීටර් එක කියලා එකක් තියෙනවා. මේක ගොඩක් වෙලාවට ස්කූල් එක්ස්පෙරිමන්ට් එක කරද්දි මේක තියෙනවා නම් මේකෙන් තමයි මම දැකලා තියෙන්නේ කරනවා. because that is convenient. right, අර වෙලා තියෙන අපිට තියෙන්නේ මේක නෙමෙයි මේක. හරි, හැබැයි ස්කූල්ස් වල මේ දෙකම තියෙනවද? දෙකම තියෙනවා කියන්නේ මේක තියෙනවා. අරක ඉතින් කොහොමත් බෝයිලින් ටියුබ් එකක් කියන එක ඕන ස්කූල් එකේ තියෙනවනේ. right, ලැබ් එකේ බෝයිලින් ටියුබ් එකක් නැත්නම් ඉතින් right වැඩක් නැහැ. මේක තියෙන ගොඩක් ඒවා. Right, any questions? So we have come to the end of this experiment also. Any questions? Hungry? Sleepy වෙන්න කෑවට පස්සේ. ඔව්, ඊට පස්සේ. Any questions? එනුක? Right, online. It is simply adding heat to system to compensate the array. So there's a balance all times, right? Can I explain again why we should ensure initial temperature is not reduced beyond dew point? Listen. If initial temperature is reduced beyond dew point, dew forms, right? When dew forms, right? To form dew and vanish dew, some additional amount of heat is transferred from the system. So I didn't write about the net in the experiment. I mentioned about the net, right? Go, Magala. Skynet ke live na mame. All right. YouTube live එක ගන්න තියෙන. Rewind කළා. Is that a thermometer? Nicholson heater. Thermometer එක තියෙන මෙතන. This is the thermometer. All good. Right. Okay. Right. Ask if there's anything else before we break for the dinner. Anything else to know? නෑ කන්න තමයි ඕනේ. හරිනේ? Alright, all good. Right. Okay. Then we'll break. We'll break up for 30 minutes. Now it's 10:10. 30 minutes I think. Next එක තවම break එකක් දෙන්නම්. ඒක නම් දෙන්නේ නැහැ මෙච්චරලා. ඒක 15 වගේ. 15. හරි. මේක 30 minutes දෙන්න. Right. It's 10:10 now. Right? We'll regroup by 10:40. Right? We'll regroup by 10:40. Right. Okay. We'll start. There are some more students to come. We'll wait for like 2 minutes and start. We'll wait for a small time because some physical students are still having their meals, right? You can go through what we have done so far again, right? Go through what we have covered so far. Okay. Right. Right, experiment 3, practical 3, experiment 3. Oh, tahu ini mana? Kalau iru nado, iru. Betul, benar. Pulang pulih, check tadi. Oh iya. Ya betul, open deh, open deh, open. Right, okay, go to practical 3. Practical 3. Right, write down. Determination of specific heat capacity of a liquid by method of cooling. This is the only experiment we have from method of cooling, right? Law of cooling, method of cooling, law of cooling. Using law of cooling, this is the only experiment we have, right? Using law of cooling, method of mixtures അവിടെ ഇവിടുത്തെ no, right? Cooling DNA guy. Determination of specific heat capacity of a liquid. Specific heat capacity of a liquid. Then difference ഒക്കെ തരുന്നതാണ്. Previous method was used to find the specific heat capacity of a solid, right? Now to find the specific heat capacity of a liquid using law of cooling. Right? Okay. Putaama ఎంత కట్టినా. Oh. What 30 minutes മതിയോ അതിനെ? 30. बात පැටේ ගනවද කොහෙද? හරි හරි go. හරි මුලින්ම මේකේ theory එක බලමු. මේගොල්ලෝ අනිත් පැත්ත නේද? Right. Theory is this. Listen. Law of cooling no. Theory කියන්නේ law of cooling. Theory is law of cooling. Law of cooling කියන්නේ මොකද්ද? Law of cooling. What is law of cooling as a law? What is law of cooling? T/T is proportional to theta minus theta. ඕකන් law එක. Right? Law is Q over T is proportional to theta minus theta r, right? Rate of heat loss from a heated object, right? Rate of heat loss from a heated object is proportional to law rate of heat loss from a heated object is proportional to theta minus theta r. Theta minus theta r is excess temperature between environment and the body, right? Body and the environment. හරිනේ මේක තමයි law එක. law එකෙන් එන equation එක මේක. right දැන් හරිනේ. No, online scenario is different. ඕන time මදිනවද නෑ? time හරිද 30 minutes මදිද? ඇතිනේ? right. Law of cooling, QOD and rate of heat loss from a heated object is directly proportional to excess temperature between environment and body, right? Body and environment, right? Okay, making equation එක අපි ගන්නවා. Equation is QOD is EA theta minus theta r. QOD is EA theta minus theta r. මේක කෙනෙක් දාලා 30 minutes is more than enough කියලා. It's different කියලා. Yeah, it's true 30 minutes is more than enough තමයි. But it's different between online and physical, right? online වුණා නම් 30 minutes කියලා කියන්නේ කාලා නිදාගෙන ඉඳලා ඉන්න උලා නේ විනාඩි 10ක් විතර නැප් එකකුත් දාලා ඉන්න උලා. physical එකේ අමාරුයි. right, listen. ආයරෝ. listen. What are these terms? දැන් මේ theory එක මතක් කරගන්න ඕනේ. QOD. What is QOD? ඒක තමයි මම කිව්වා. What is QOD? QOD. Rate of heat loss, right? Rate of heat loss. हम मेथड इंट्रोड्यूस करना. Rate of heat loss, right? E. You will know Q. What is E? What is E? 9 weeks. I'm then again. What is E? Coefficient of emissivity. Coefficient of emissivity. Coefficient of emissivity. Right? Very much comparative to surface emissivity. What is A? Area open to atmosphere or area open to environment. Right? Nikang area ke liye wala nahi. Area open to atmosphere. Right? Theta minus theta r is introduced as a single term. Excess temperature between body and atmosphere or body and environment. Right? Excess temperature. Right? Make a law of cooling. Right? Now, when something cools in the environment, right? Heat is lost from the body. According to this equation, law of cooling, and we had conditions of validity for law of cooling. Right? Then experiment then everything is coming here. What are the conditions of validity of law of cooling? What are the conditions of validity? What are the two convection types we have? What are the two convection types? With respect to convection types, we have conditions. What are the convection types online? Convection types: natural convection and forced convection. Right? Under natural convection, what is the condition? Under natural convection, what is the condition? Only for small temperature differences. Right? Under forced convection, up until higher or larger differences. 80 degrees Celsius under forced convection. Right? Under natural convection, it should be less than 20. Less than 20 values there. Right? Okay. What is a forced convection and a natural convection? දැන් ඔක්කොම ටික ඕනේ. දැන් ටික මතක් කරගන්න ඕනේ. What is a natural convection? Natural convection. By the way, what is convection? දැන් කලින් convection එකේ heat loss එක ගැන කිව්වත් what is convection? Transfer of heat by decreasing density of a medium, right? Convection by decreasing density of a medium, right? Okay, that's convection. For convection, we have two types now: natural and forced. What is natural convection? If a body, right, cooled under natural conditions. Natural conditions means, right, there cannot be any artificial wind blows, right? Even if we can't blow to the system, right? Fans දාන්න බෑ. Natural wind flows අරන්න අනිත් වෙන කිසිම flow එකක් තියෙන්න බෑ. Right? Natural කියන flow එකත් uniform තියෙන්න ඕනේ. ඒක naturally වෙන්නේ නැහැනේ. Then to achieve natural conditions, it should be a controlled room if we are using this under natural conditions. Right? ඒක නිකන් control කරලම තියෙන්න ඕනේ. නැත්තම් නිකන් තියන්න බෑ. Forced convections means, right? Forced. ඒක forcefully කරලා තියෙන්න ඕනේ. Which means it can be under the impact of a fan, external fan, right? Or any other source of wind using maybe pipe එකකින් එන wind එකක්, air flow එකක්, right? ඔය dry එකකින් එන air flows තියෙන අන්න ඒ වගේ නිකන් air flow එකක් වෙන්න පුළුවන්. ඔක්කොම අර නිකන් fans වගේක් නේ තියෙන්නේ, right? So if there is something forced, as the word says, that is a forced convection. Natural conditions විතරක් තියෙනවා, that's a natural convection, right? Okay, then, right, listen. Now this is valid for larger temperature differences under forced convections only. Under forced convections only, right? Under forced convections only, right? So therefore we are going to have a forced convection here, right? කොහොමද කරන්න කියලා බලමු. We are going to have a forced convection, otherwise නිකන් 20 විතරයි අපිට යන්න පුළුවන් limit එක තියෙන්නේ. ඊට වඩා කරන්න බෑනේ, right? ඊට වඩා spread එකක් ගන්න ඕනේ graph එකට. So therefore we will be using a forced convection. And this is how this works. Listen. This is how this works. Right. Materials වලට යන්න කලින් you better mention this. Right? මට මේක erase කරන්නත් වෙයි. Take down the theory first. Write down law of cooling. My law of cooling කියන්න ලියගන්න. After this line, මේ line එක විතරක් ලියන්න. Write the first line. Write the first line. Write the first line. Write the first line. And write law of cooling. දන්නේ නැද්ද? මම කියන්න. In red. law එක ලියගන්න red වලින්. Write the law of cooling in red. Rate of heat loss from a heated object. Rate of heat loss from a heated object. Rate of heat loss from a heated object is directly proportional to excess temperature between directly proportional to excess temperature between object and the environment. Excess temperature between object and the environment. Excess temperature between object and the environment. Right. Then write down the equation and introduce terms. Write down the equation and introduce terms. Reduced terms. Rate of heat loss, coefficient of emissivity, area open to atmosphere, excess temperature. Right? Then mention this below. Valid for larger temperature differences under forced convection. Underline or highlight forced convection. Right? Underline or highlight forced convection. Right. Listen now. Right? Listen. Now, rate of heat loss depends on QOT depends on EA theta minus theta R. No? Right? Now, if I need to control this, first tell me on which E depends on. On which E depends on? On which E depends on as a factor. Come again. Huh? On which coefficient of emissivity depends on? Huh? Nature of the surface. Nature of the surface. Right? Nature of the surface. If nature of the surface is same, E should be same. Right? Then for the experiment, therefore we are going to use the same calorimeter. Right? If the same calorimeter is used, right? මේ මුල ටික තමයි තේරෙන්න ඕනේ මේක ලොජික් එක. හොඳේ? මේක ලොජික් එක තේරුණාට පස්සේ මේ එක්ස්පෙරිමන්ට් එකේ ඇති දෙයක් නැහැ. Right? If you understood the logic, right, then there's nothing here. Right? To make E constant, nature of the surface should be kept constant. No? Then same calorimeter is going to use, because we are going to do something under two scenarios, right? For water and a liquid. Right? Then we'll be using the same calorimeter. If same calorimeter is used, we can make sure that same nature of the surface is there. Is same. Right? And area open to atmosphere can be controlled by filling the liquids up to the same height. Yeah, but the local done. On a subject, what about? Local is done never. Any windows open? Metering in. Right. Listen. Right. Listen. To keep the area open to atmosphere constant, the liquid is filled. Right. Liquids are filled. Liquids के लिए water and liquid are filled to same height. If it is filled to same height, area open to atmosphere is same. Area open to atmosphere के लिए that is not only the surface. Area open to atmosphere के लिए මේ ඔක්කොම right. දැන් මෙහෙම නම් මේක තියෙන්නේ right. When the liquid is like this, assume this has a liquid column, right? All this surface is open to atmosphere. මේවා නුත් convection වෙනවා, right? Everything is open. Area open to atmosphere කියලා කියන්නේ මේක විතරක් නෙවෙයි. Right? That is the total area of the liquid. Right? To keep it constant, it is filled up to the same height. And if we do all the calculations in the same temperature difference, right? Theta minus theta R is also going to be same, right? Then if whole right hand side of the equation are constants, E is a constant because same calorimeter is going to use, A is constant because liquid and water are going to fill to the same height, right? And theta minus theta R is constant because we will be doing all calculations in a same temperature range, same temperature difference, right? Then if all these are constant, then Q over T should be constant, right? So therefore, our argument is this. Our argument is this. Now, hence, Q over T should be constant, right? Then we'll be plotting two cooling curves for water and a liquid, right? For water and a liquid, right? When all these conditions remain constant, then Q over T of water should be equal to Q over T of liquid, right? And finally, we are going to equalize these two, right? Simply, right? First scenario, we are going to cool down, right? We are going to cool down water, right? Say we are starting from 70 degrees Celsius, right? We are starting from 70 to, and say the system is cooled down to 40, right? 35, 30 to 30, right? Then between 70 and 30, all calculations are done, right? Using same calorimeter filled up to same height. Then rate of heat losses of water, right? Rate of heat loss of water is equal to rate of heat loss of liquid, and we can equalize these two, right? Once these two are equalized, since S of water, specific heat capacity of water is known, specific heat capacity of the other liquid can be determined, right? My equation earlier penna logic, right? If you understood the logic, first part is done, right? If you understood the logic, first part is done, right? Now, therefore, right? Q over T of water plus calorimeter equals Q over T, rate of heat loss of liquid plus calorimeter, right? Okay, Q over T equal right? Now, have to start from here, right? Mention this again and mention these points with arrows. Mention the equation again and mention these points with arrows. Can I explain the logic again? We'll explain again under methodology, right? Right. First, for E write down, for E write down, same calorimeter is used. Same calorimeter is used. E වලට දාන්න arrow එකක් දාලා ලියන same calorimeter is used. Right? And for A write down, මේකට arrow එකක් දාලා ලියන both liquid and water are filled up to same height. 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 Right? For theta minus theta r, write down. All calculations are done. All calculations are done. All calculations are done. All calculations are done within same range. Within same range. Right. Now write this below as a point. Hence, right hand side of the equation remains unchanged. Hence, right hand side of the equation remains unchanged. Hence, right hand side of the equation remains unchanged. Hence, right hand side of the equation remains unchanged. Right? So that left hand side LHS should be unchanged. So that LHS should be unchanged. Right? Okay, now mention this. Therefore, Q over T of water plus calorimeter equals Q over T of liquid plus calorimeter. Right. Listen now. Listen now. Right. Now I'm going to explain about the method of the experiment. Listen. Right. My equation to write the equation, we need readings, right? To explain about readings, I have to explain the experiment, right? Listen now. Listen now. We are using this. This is a stand, right? On the stand, this calorimeter is suspended. On the stand, the calorimeter is suspended, and it is closed using an insulator lid, right? This is an insulator lid. Right? And styra thermometer, right? The liquid is filled up to here. We have to make a force convection here to create a force convection, right? We are using a uniform airflow from a fan, right? Uniform airflow from a fan. Right, a normal table fan napkin. Right? Table or stand or whatever it is, it should be a uniform airflow with the fan, right? Then throughout the experiment, you have to keep on the fan at a constant speed, right? Right, now what we do is this. Initially, listen now. Initially, before filling this with water or liquid, right? First of all, I need the mass of the system, initial mass, right? Readings make explain right? First one, I need the initial mass. Initial mass empty calorimeter with the styra, right? So first of all, I need the mass of, right? Mass of empty calorimeter plus styra, right? Same one. Now this is filled with water, right? Water means heated water. Usually we heat it up to 70 degrees Celsius, right? No rule. 70 usually heat 70 or 80, right? 70 usually. So water is heated up to 70, and water in 70 is put into the calorimeter, right? Once water is put in, right? Once water is put in, again you have to take the reading, mass of water plus calorimeter plus styra, let's say M2, right? Now mass of water is known here, then mass of water is M2 minus M1, right? Now system is at 70. System is at 70. 70 heat system is at 70. And then we let this cool under this force convection, right? The airflow something known fan face color right? Then under this force convection, we let this cool, right? And for each 30 seconds, for each 30 seconds, you are going to take the reading of this thermometer for each 30 seconds, right? Then in a table, we are going to record the temperatures of thermometer, right? This is time, right? Time from 0 30 seconds minutes 0.5 1 1.5 2 2.5 2.5 3 2.5 6 minimum 6 we need, over, right? ඊට පස්සේ මේ තියෙන්නේ water, right? මෙතන මම ලියන්න හදන්නේ liquid, right? Now temperatures are recorded against time. Time එකත් එක්ක temperatures එක තියෙනවා. And we are going to plot the cooling curve of water, right? ඒකත් මම අදින්න. We are going to plot the cooling curve for water. Cooling curve for water. Listen. Cooling curve is between, what are the axes? Cooling curve. Temperature and time. Theta with time, right? Theta is in degrees Celsius now. Degrees Celsius now. And time in seconds, right? Time in seconds. Right? මම මෙතන දාලා minutes වලින් අපි time එක seconds වලින් මේක මාක් කරනවා. Right? Then water වලට අදිනවා. Say you are starting from 70. Right? ඒතර cooling curve එක මේ වගේක් එයි. Until theta r, room temperature. Right? And then after plotting the cooling curve for water, water is removed from the calorimeter. Water is removed from the calorimeter. And this same calorimeter is used again to fill the liquid. Liquid is filled to the same height. Liquid is filled up to the same height and it is heated to same temperature. And once liquid is filled, have to take the mass again. Then mass of liquid plus calorimeter plus stirrer, let's say M3. Then mass of liquid is given by M3 minus, more than M3 minus M1, right? M3 minus M1. M3 minus M1. Alright? And repeating the same for the liquid. Right? Repeating the same for the liquid. So liquid එකටත් මෙහෙම curve එකක් එයි. Starting from 70. Again, it is also going to cool down to room temperature. Right? The water වලට එකක් අදිනවා. Liquid එකට එකක් අදිනවා. Right? And we are going to select, listen, we are going to select the same temperature range. We are going to select at same temperature range, right? අපි මේ වගේ temperature range එකක් ගමු. මේකට දැන් temperature එක say from here to, ඉතින් මේ initial points ගන්න somewhere from the middle, in between, right? මේවා special points නේ. මෙහෙම range එකක් ගන්නවා. Then during the same range, see මේ graph එක හොඳට බලන්න. During the same range, see water has taken to cool down from say theta 1 to theta 2, to cool down from theta 1 to theta 2, water has taken this much of a time, right? And during the same range, this liquid has taken a time from here to here. මෙතන cross වෙන්නේ. Say time of liquid, right? අන්න ඒක graph එකෙන් හොයාගන්නවා. හරිනේ වැඩේ. Now we are going back to our logic, right? Logic එක තමයි QOT of water, right? මේ ටික තේරෙනවා කියන්නේ experiment එක ඉවරයි වගේ. QOT of water plus calorimeter equals QOT of liquid plus calorimeter, right? මේක plug කරනවා. Then for water and calorimeter, mass of water M2 minus M1, right? M2 minus M1, right? Let's assume specific heat capacity of water as CW, right? Temperature difference is same for water and calorimeter. No? Going to take it out, right? Plus calorimeter part එක මෙතන දානවා. Mass of calorimeter is M1. Then temperature difference theta 1 minus theta 2, right? Over water TW, right? equals මේක same තමයි කරන්න තියෙන්නේ. මම පොඩියට ලියනවා. Then for liquid M3 minus M1, say C liquid Cl plus M1 again, and the temperature difference is same, theta 1 minus theta 2 over time TL, right? These two are going to cancel, and from the rest M1 is known, M2 is known, M1, M2, M3 are known. TW, TL are known, right? And we know the standard value of specific heat capacity of water. Then using the calculation, CL can be determined, right? Difference between the previous method and this one is, previous one was for a solid, right? This is for a liquid, right? For liquids, this is the only method we have, right? Liquids වල කලින් ගෙන් හොයන්නත් පුළුවන්. හැබැයි ඒක අපිට ගයිඩ් දෙන්නේ නැහැ. මේක තමයි අපිට liquids වල තියෙන්නේ, and this is the only experiment from Newton's law of cooling. Only experiment we have from Newton's law of cooling, right? Okay. right මේක theory එක explain කරන්න යද්දි ඉතින් ඔක්කොම ටික කියන්න වෙනවා නැත්තම් තේරෙන්නේ නැහැ. දැන් theory එක මේක ඇත්තරම මේක තමයි theory එක. ඉතින් මේක වට කිව්වට තේරෙන්නේ නැහැ. right නැත්තම් theory එක දෙන්න ඕනේ මෙච්චරයි. right now where did we stop? right then mention about the readings, right? Write down readings එක ලියන්න. අනිත් ටික ඔක්කොම method එකේ ලියන්නේ. write down the readings, right? mention the readings, write down. first one mass of empty calorimeter, mass of empty calorimeter with styrer within brackets M1. mass of empty calorimeter with styrer within brackets M1, right? Second one, mass of water comma calorimeter with styrer, mass of water comma calorimeter with styrer, right? M2 within brackets M2, right? Next one, mass of liquid comma calorimeter with styrer, mass of liquid comma calorimeter with styrer, M3. right? Next one, time taken by water to cool down, time taken by water to cool down, time taken by water to cool down from θ1 to θ2, time taken by water to cool down from θ1 to θ2, time taken by water to cool down from θ1 to θ2, right? Within brackets TW bike क्या कहोगे TW, right? Next one, time taken by liquid time taken by liquid to cool down from θ1 to θ2, time taken by liquid to cool down from θ1 to θ2, within brackets TL, right? Then specific heat capacity of, next one මෙතන මම කොහොමද mention කරමු, specific heat capacity of water, CW, specific heat capacity of water, CW, specific heat capacity of water, CW. Next one, specific heat capacity of liquid, CL, specific heat capacity of liquid, CL, right? Next, specific heat capacity of calorimeter, specific heat capacity of calorimeter, C L, sorry CL में CS, right? को में तो नहीं लिया है M1 CS, right? Okay, then write down below. Write down below. According to the theory, put a comma. According to the theory, put a comma, and mention this. QOT of water plus calorimeter equals QOT of liquid plus calorimeter, and mention the equation. Right, M2 minus M1 mass of water into CW, specific heat capacity of water, plus M1 CS mass of calorimeter times specific heat capacity of calorimeter, whole thing into temperature difference theta 1 minus theta 2, right, over time it takes TW. Same thing on the other side. For liquid, mass of liquid is M3 minus M1, right, into specific heat capacity of liquid CL plus calorimeter M1 into CS brackets theta 1 minus theta 2 over TL. Nah, දැන් graph එකයි මේ වගේ අඳින්න එපා. tables නුකුත් ලියන්නත් එපා. right, يعني graph එක ඇඳෙන්නේ නැත්නම් මේක explain කරගන්න විදියක් නැති ඉන්න. right, then write down below CL can be determined using the equation. 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 Right? CL can be CL can be determined using the equation. Equation can make it using this equation. CL can be determined using this equation. Right? Alright. Then the theory එක ඉවරයි. Right? Theory එක ඉවරයි කියන්නේ අතන experiment එකේ ඔක්කොම ටික වගේ ඉවරයි. Right? දැන් අර ඔඩ එකට අපි මේක කරගෙන යමු. Right. Next, write down materials and apparatus. Materials and apparatus. Materials and apparatus. Right. Write down. First one, a polished calorimeter. A polished calorimeter. Right. Now, when I say polished, now you know what the reason is. A polished calorimeter. Right. Next, a heat insulated lid. A heat insulated lid. A heat insulated lid. Thermometer, styrer. Thermometer, styrer. Stand. Right? Stand here. Stand. Right? Then an electric fan. Right? අනිත් ඒවාට ඉතින් අපිට විතර මෙෂර් කරගන්න ඕනේ වුණේ ඒවා. Right? We are measuring masses. Right? Then triple beam balance, four beam balance, or electronic balance. Right? Either one. Triple beam balance, four beam balance, or electronic balance. Triple beam balance, four beam balance, or electronic balance. Right? Then time is measure කරගන්න ඕනේ. To measure times, stopwatch. Right? Then finally, sufficient amounts of water and liquid. Sufficient amounts of water and liquid. Right, now take down the diagram. Take down the diagram. Take down the diagram. right? Right, take down the diagram. Diagram. Diagram එක මේක.
කලින් එක්ස්පෙරිමන්ට් එකේ ටේබල් එක.
නෑ ඒකේ ටේබල් එකක් නෑ. කලින් ඒ ටේබල් එකක් නෑ. right, දැන් ටේබල් එක ලියන්න එපා, only the diagram. හරිනේ? Okay, write down the method. Write down method. 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 First point. Measure the mass of. Measure the mass of. Measure the mass of. Measure the mass of empty calorimeter with stirrer. Measure the mass of empty calorimeter with stirrer. Right. Next point. Next point. Fill water up to. Fill water up to. A certain height. Fill water up to a certain height. Within brackets. Within brackets. Within brackets. 1 centimeter less. 1 centimeter. 1 centimeter less than total height. 1 centimeter less than total height. Less than total height. To fix the lid. To fix the lid. Right? Again, මෙහෙමයි 1 centimeter කියලා rule එකක් නෑ. If the lid is 1 centimeter, lid is around 1 centimeter usually. Right? Lid එකේ තියෙන space එක අයින් කරලා අපි තියනවා. නැත්නම් lid එක ගන්න බැරි වෙනවා. Right? When water is put in. Right? ඒතර එහෙම rule එකක් නෑ. 2 centimeters තිබ්බත් කමක් නෑ. lid එක තියෙන 1 centimeter උනාට. Doesn't matter. Doesn't matter. Unless we fill the liquid and the water to the same height. Doesn't matter. Right? Okay, issue එකක් එන්නේ. Issue arises if you fill it up to the surface and try to close the lid. Right? ඒතකොට lid එක වහන්න බෑ. right. Measure करने के लिए given है, right? And measure mass of system within brackets M2 and measure mass of system within brackets M2 and measure mass of system within brackets M2. Right. Next point. Next point. Next point. Start recording. Start recording. Start recording. Temperature of water. Start recording temperature of water. In each 30 seconds. In each 30 seconds. In each 30 seconds. When it cools down. When it cools down. When it cools down. Next point. Plot the cooling curve. Plot the cooling curve. Plot the cooling curve. Plot the cooling curve for water. Plot the cooling curve for water. Plot the cooling curve for water. Right. Next. Remove water from calorimeter. Remove water from calorimeter. Remove water from calorimeter. And fill it. And fill it. Remove water from calorimeter. And fill it with the liquid. And fill it with the liquid up to the same height. Up to the same height. And fill it with the liquid up to the same height. And measure the mass of liquid, calorimeter with stirrer. Liquid, calorimeter with stirrer within brackets M3. Within brackets M3. Right? Within brackets M3. Repeat the same. Next point. Repeat the same procedure. Repeat the same procedure. Repeat the same procedure. Repeat the same procedure. For liquid. And plot the cooling curve. Repeat the same procedure for liquid and plot the cooling curve. And plot the cooling curve. And plot the cooling curve for liquid on the same axis. And plot the cooling curve for liquid on the same axis. And plot the cooling curve for liquid on the same axis. Right? Right. Next point. Next point. All data are recorded. Next point. All data are recorded. All data are recorded. In the following table. All data are recorded in the following table. All data are recorded in the following table. All data are recorded in the following table. To plot cooling curves. To plot cooling curves. Right. Copy down the table. Right. This is time. Right. Time. And it is in minutes. Right. Minutes. Time in minutes. Temperature of water. Right. Second one. Temperature of water. Temperature of water. And this is temperature of liquid. Temperature of water and temperature of liquid. Temperature of water and temperature of liquid. Temperature of water and temperature of liquid. Temperature of liquid. Right, take down the table. Right, 0.51, 1.5 to 2.5. Right, it was a graph. Now below the table, take down the graph, pooling curves. Then take down the graphs. Sorry. This one is for water. This one is for water. This is the liquid. Theta R, theta 1, theta 2. And from theta 1 to theta 2, mention these times properly. Time takes by water is Tw, by liquid is Tl. Right. Correct? Done. Done. Double check the graph. Graph එක තමයි මෙතනින් important මේක. Double check the graph. Graph එකේ times ටිකයි temperatures ටිකයි double check කරන්න. Right? Axis, times and temperatures. Right. Now calculation. ඊළඟ දාගන්න calculation කියලා. Calculation. Right. See, for water, right? For water, listen, for water. Now, Q over T of water. Q over T of water again, water plus calorimeter. Right? Mass of water is M2 minus M1. Mass of water is M2 minus M1. Specific heat capacity of water is CW. Right? And mass of calorimeter was M1. Specific heat capacity was CS. Right? And they are cooling down from theta 1 to theta 2 during a period of TW. Right? Q over T of water plus calorimeter. Alright? Total heat should be here. Then heat liberated by water is here. Heat liberated by calorimeter is here over their time TW. Alright? Then same thing for liquid. Same thing for liquid. Q over T of, right, water plus liquid. Same thing. M3 minus M1 mass of liquid times C of liquid plus calorimeter M1 CS. Same temperature difference, theta 1 minus theta 2, right? Over a period of or time interval of TL, right? Mention these two. Further. Right? Write down. Label this as equation 1, label this as equation 2. Write down. According to theory, 1 equals 2. According to theory, 1 equals 2. Right? Equalize these two. According to theory, 1 equals 2. Then theta 1 minus theta 2, theta 1 minus theta 2 is going to cancel and the rest remains, right? M2 minus M1 plus CW plus M1 CS over TW equals M3 minus M1 CL plus M1 CS over TL. Right? Write down below again. Calculate CL using standard values for CW and CS. CW and CS, using standard values for CW and CS, right? Okay, so basically experiment is done from here, right? Remarks are there are special things, right? Any questions about the experiment so far before going on to remarks? Any questions? All good? Right? Pada remarks you have right. Go to remarks. Go to remarks. Go to remarks. First point. First point. First point. Both water and liquid. First point. Both water and liquid. Both water and liquid. Both water and liquid should be filled up to. Should be filled up to. Should be filled up to same height. 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 Within brackets, within brackets, within brackets, same point again, within brackets. To make areas open to atmosphere equal. To make areas open to atmosphere equal. Right. Next point. Next point. Same calorimeter should be used. Same calorimeter should be used. Same calorimeter should be used for both water and liquid. Same calorimeter should be used for both water and liquid. Same calorimeter should be used for both water and liquid. Within brackets. To equalize nature of surface. 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 Then all calculations, next point, all calculations should be done. All calculations should be done within the same temperature difference. All calculations should be done within the same temperature difference. All calculations should be done within the same temperature difference. All calculations should be done within the same temperature difference. Within brackets, equalize excess temperature. Equalize excess temperature. Right. Next point. Both water and liquid should be well stirred. Both water and liquid should be well stirred. Both water and liquid should be well stirred throughout the experiment. To ensure uniform distribution of temperature throughout. To ensure uniform distribution of temperature throughout. To ensure uniform distribution of temperature throughout. Right. Next point. To ensure uniform distribution of temperature throughout. Next point. Glass or plastic calorimeters. glass or plastic calorimeters, glass or plastic calorimeters are not used. Right? Reason is this. Listen, when it comes to glass and plastic, right? Copper use calorimeters copper, right? What we are using is copper, right? Glass and plastic use because glass and plastic are heat insulators, right? They are weak heat conductors. Heat insulators, they are weak heat conductors, right? Then it takes a long time. To cool down, right? So when it takes a long time to cool, temperature outside the calorimeter, listen, temperature outside the calorimeter is different from temperature inside the calorimeter. Then temperature outside the calorimeter and temperature of the liquid are two different values, right? Right? Issue because outside temperature is room temperature. It matters to make these conditions constant, unchanged, right? That's the thing. Alright, write down within brackets. Since they are weak heat conductors, temperature of calorimeter can be different from temperature of liquid. Temperature of calorimeter can be different from temperature of liquid. Right? Right. Equations because I have considered a same temperature difference for both liquid and the calorimeter. 0 minus 0 2. Now, if these two are two different temperatures, right? If these two are two different temperatures, even I can't write this equation. Right. That's it. Right. So quickly go through what is given. Compare the value of obtained experiment with the standard value of the capacity of liquid for the idea source. Right. Right. The other thing, the last thing, listen. Now, when we take the temperature difference from this point to here, right? When we take the temperature difference from theta 1 to theta 2, right? Theta 1 to theta 2, right? During the range, right? In the range, there can be amount of heat loss to environment, right? Right? To eliminate this and to get more accurate reading, right? We can do the calculation like this, right? If we consider only one point here and find the gradient, if you find the gradient of a single point, gradient point, right? If you are finding the gradient of a curve, we have to use a mirror strip. Mirror strip use method, right? Mirror strip use right? Mirror strip use right? If you need to find the gradient here, right? Say I need to find the gradient of this point, right? Point gradient, because gradient changes over the line, right? If you need to find the gradient of this one, right? What we do is I have to keep a mirror, right? Mirror strip on the line like this, right? I have to keep a mirror strip on the line like this, right? And we will see the image of this curve on the mirror, right? You will see the image of the curve on the mirror, right? Make a podi mirror strip, a small mirror strip, and you have to rotate the strip until the actual curve and the image that you see from the mirror are coincided. When they are coincided, right, which means this point is collinear. When may point collinear. Now, if you draw a line here, if you construct a line here, that is exactly a perpendicular line drawn to this point. Then remove the mirror and draw another perpendicular line to this, and this is the correct gradient. Right? Right? If you are going to this method, how to use a mirror strip? How to use a mirror strip to find the gradient. That is not as easy as finding the gradient of a straight line. Now, y minus x delta y minus delta x right? Point change. Then only method we have is using a mirror strip. Right? මේකත් mention කළා වැඩේ ඉවර කරමු. Right, මේ තියෙන mirror strip එක. Write down as a next point. To have more accurate value. To have more accurate value. For CL. To have more accurate value for CL. To have more accurate value for CL. Temperature difference can be written. Temperature difference can be written. Temperature difference can be written. What do you say? Can be written using gradient of graph. Using gradient of graph as follows. Using gradient of graph as follows. Using gradient of graph as follows. Right. This is a magnified view of this, right? And now let's say this angle is alpha. Gradient is tan alpha. Correct? Angle is alpha. Gradient is tan alpha. What is given by the gradient here from the graph? What is given by the gradient of the graph? This is a cooling curve. What is given by the gradient of the graph? Gradient. What is given by the gradient? Delta theta over delta t, right? Then what is it? As a variable or as a quantity? Rate of cooling, right? Not rate of heat loss. Q over T. Rate of cooling. Rate of cooling. Oh, that is also called rate of temperature fall. Right? Rate of cooling and rate of temperature fall. Right? They are very small values now. We are going to take the gradient at a point. For very small values, we are using differentiation. Right? Or differentiation use karna. Then you are using differentiation. Then this is delta theta or delta t. Right? Then instead we will be writing d theta or dd. I think differentiation part. Right? And this is the tan alpha now. This is tan alpha now. Right? With delta a very small difference. Because that's a value at a point. Tan alpha. Right? Maybe there are now when you are writing the temperature fall here, delta theta or t part, then this part can be replaced by this. Right? From the curve and this of method that I explain mirror strip use करनी थी. Okay, finish. Gradient is dt theta over dt tan alpha, right? So what we are going to measure is tan alpha. Tan alpha is equivalent to d theta over dt, right? Now this is what we do. Mirror strip එක use කරන විදිය කියන්නම් මේක මෙරික් කියලා කියන්න. Right, now if we do the same for both water and liquid, right, you will get two gradients, no? Right, then curves දෙකක් තියෙනවනේ මේක curve එකක් නේ මම ඇදලා වෙන්නේ. So likewise if you repeat the same for the next curve also, right, we'll get something like this. Right, now if you do the same for water and liquid, if you do the same for water and liquid, right, from here we can get d theta over dt of water, say that is tan alpha 1, and from here you can get d theta over dt of liquid, say that is tan alpha 2, right? Now since all other conditions are same, q over t should be same, right? Our logic ekama use karna. Since all other conditions are same, q over t should be same, right? Then q over t of water equals q over t of liquid, right? Ara වැඩේම කරනවා, right? For theta over t we will be writing this one instead, right? මේක ලියන්න නෑ දැන්. අර time durations ඕනෙත් නෑ. time duration එක ඕනෙත් නෑ. හරි? මේවා මොකුත් ඕනේ නෑ. කෙලින්ම දැන් මේක ලියන්න. Like this. Total heat is m2 minus m1 cw m1 cs. මෙන්න මෙතෙන් temperature fall එක එන්න ඕනේ. Right, මේ theta over t part එක replace කරන්න යන්නේ උනේ. වැඩ තේරෙනවද? That is into tan alpha 1. Tan alpha 1, right? ඊට මදිනේ මම මේ ලියනවා. මේක erase කරනවා. මම මේක තිබ්බේ නිකන් compare කරගන්න ඉඳලා. Right, කවන්න එකක් තියන්න. Right, see? Then q over t of water equals q over t of liquid. q over t of water කියලා කියන්නේ m2 minus m1 cw plus m1 cs. Right, මෙන්න මෙතෙන්ට එන theta over t එකක් තියෙනවනේ. That is theta over t delta theta over delta t or dt d theta over dt of water, right? tan alpha 1. හරිනේ? හරි නේද? මේ එන්නේ මේක d theta over dt of water, right? කාන මේක ලියලියනම් theta over t එක replace කරාම then here m3 minus m1 cw m1 cs, right? m1 cs d theta over dt of liquid, right? Then this is tan alpha 1, right? This is tan alpha 2, right? Tan alpha 1 and tan alpha 2 are known from gradients, right? Then again can do a simplification. This is a little bit more accurate because you are not doing a calculation for a range. Range එක කරන්නේ නැහැ, right? This calculation only at a point, right? Point එකේ විතරයි වැඩේ කරලා තියෙන්නේ. Range එක කරන්නේ නැහැ. එහෙම කරන්නත් පුළුවන්, right? Okay, now take it down. මේක ලියුවත් නෑ නේද? Now apply this for these two and show it and write this. right? Understood? Right? That's it. මේ mirror එක use කරන විදිහ කියන්න ඕනද? මතකයි? දැන් මතකයි පස්සේ අමතක වෙයිද දන්නේ නැහැ. කවන්න එකක් ලියාගන්නකො. නැත්තම් mirror එක අමතක වෙලා මාව මතක් වුණොත්. ඕකක් ඇවිල්ලා. Right. Write down. Use a mirror strip. Use a mirror strip to find. Use a mirror strip to find. Use a mirror strip. Use a mirror strip to find use a mirror strip to find gradient of a curve. Use a mirror strip to find gradient of curve. Right. Right now. Keep a mirror strip. Steps wise 1, 2, 3 डाल लिया है. First one. Keep a mirror strip. Keep a mirror strip. Keep a mirror strip. Keep a mirror strip. Keep a mirror strip on the curve. Keep a mirror strip on the curve. Keep a mirror strip on the curve and rotate it and rotate it and rotate it until and rotate it until reflected image of curve at the point, reflected image of curve at the point coincides with actual curve. Coincides with actual curve. Draw line. Second, step wise लिया ना. Draw line along the mirror at this instance. Draw line along the mirror at this instance. Within brackets, this is a normal drawn to curve at this point. This is a normal drawn to curve at this point. This is a normal drawn to curve at this point. This is a normal drawn to curve at this point. This is a normal drawn to curve at this point. Alright. Next step. Remove the mirror. Remove the mirror. Remove the mirror strip. Mirror strip. And construct a normal to the previous line and construct a normal to the previous line and construct a normal to the previous line. Right? Within brackets, this line is the tangent drawn. This line is the tangent drawn to the curve at the point. This line is the tangent drawn to the curve at the point. This line is the tangent drawn to the curve at the point. Right? ඇතිනේ. ඒතර gradient එක හොයාගන්න ඕන නම් ඉතින් complete the triangle and measure the angle. That's it. එකත් ඕන නම් ලියා ගන්න. Complete the triangle and measure the angle tan alpha. Right? Tangent එක ඇඳගත්තා කියන්නේ හරි. Because otherwise the thing is right මේක එන critical නේද? ඒ කියන්නේ මේක you know just by keeping a ruler like this, right? We can't see whether it is exactly tangential or not. By the unaided diving. මෙහෙම නිකන් බලන්න බෑ. පොඩ්ඩක් වෙනස් වුණා කියලා ඒක තේරෙන්නේ නැහැ. That's the thing. ඒකයි mirror strip එක use කරන්නේ. මේකෙන් එන එක හරියටම හරි. right? තේරෙනවද? ඒ කියන්නේ නිකන් rule එකක් තියලා මෙහෙම rotate කරලා අපිට බලන්න බෑ. You can't say whether this is tangential, this one is tangential එහෙම කියන්න බෑ. right? ඒක වෙනස් වෙනවා. ඒක පේන්නේ නැහැ නිකන්. තියලා බලන්න rule එකක්. මෙහෙම curve එකක් ඇදලා point එකක් ගාලා මෙතන rule එකක් තියලා බලන්න. එහෙම කරන්න බෑ. right? That's why we have this method as a more accurate method, right? Okay, that's it. That's everything. Any questions? Oh, same theory ගන්න ඕනෙත් නෑ දැන්. අයි මේ දෙක දන්න? That's a good question. Listen. Now, listen. When you take, listen, same theta ඕනේ. ඔයාගේ same theta ද කියලානේ. difference එකක් කරන්නේ නැහැ. Right? Same theta. Yes. Same theta කියන එක හරි. Because go back to our fundamentals. We have kept theta minus theta are constant because theta is constant. No? Then theta should be constant. හරිනේ? ඒකෙන් එතනින් difference එකක් නැහැ. Right? මෙතනනේ දැන් point එක තියෙන්නේ theta minus theta r should be constant. දැන් theta කියලා කියන්නේ temperature at this point. Temperature of the object at this point. Right? It should be constant. නැත්නම් මේක වෙනස් වෙනවා. Right? එතකොට මේ curve එක මෙතන ඇන්දොත් මෙහෙම නෙන්නේ. මෙහෙම curve එක එනවනේ. මෙතනින් ගන්න ඕනේ. theta නම් theta කියනවා මෙතනින්ම ගන්න ඕනේ. Right? That's a good question. Listen again. Our initial assumption කියලා කියන්නේ that is one of our initial conditions we kept constant. Otherwise, if right hand side is different, I can't argue this. Right? මේක argue කරන්න බෑ. Right? ඒ හින්දා මේ වැඩේ කරත් theta should be constant. මේ theta should be same. Difference කතාවක් නෑ. theta should be same. theta එක විතරක් same වෙන්න ඕනේ. හරිනේ? අරගෙන නම් difference එකම same වෙන්න ඕනේ. මේක theta විතරක් same වෙන්න ඕනේ. Right? What else? Right, මේක හරිනේ. හරි. What else? Any other questions? No? Inesi ke questions තියෙනවද? Anything? No? ඉතින් ඔව් සීදලා. යනු කාටද? Online? Can you explain the logic again? Logic එක දැන් හරින්නේ? Logic එක අහලා තිබ්බ කවුරු? Logic එක හරියන්නේ නැන්නේ? L plus C for liquid in equation. Yes, liquid plus calorimeter. All good for now. Can you slow down your telling speed when points are ready? Right. Okay. No any questions? No. හරිනේ? Right. Listen. Are you aware that the conditions of the earth is going to be worse in the coming 2 months? Right? ඕක first time මම class එකේදී කිව්වා මෙහෙම එකක් වෙයි කියලා මාර්ච් විතරනේ. මතකද? මේ මම නිකන් අදත් බැලුවා wind patterns. ඒක වෙනවා ඉතින් දැන් wind patterns ඔක්කොම මේ පැත්තට හැරලා ඉවරයි. මේ මම අද නිකන් දවල් ඉන්න ගමන් බලවල හිටියේ අර windy කියලා මම ඔය වෙබ්සයිට් එකේ windy එකේ බලවල හිටියේ wind patterns දැන් ඒ කියන විදිහට හැරලා ඉවරයි. Right? It was forecasted back in March, right? March වල forecast වුණා. And I also shared that in some of the classes. මම හිතන්නේ මම ඔයගොල්ලෝ class එකේ කියන්නේ නැද්ද? March වල මම කිව්වා. ඔව් කිව්වා ඔයගොල්ලෝ class එකේ කිව්වා. March වල මම කිව්වා. ඊට පස්සේ දැන් වෙලා තියෙන්නේ now WMO is confirming that it is for sure happening, right? WMO කියලා කියන්නේ World Meteorological Organization, right? Now they are saying that World Meteorological, right? Meteorological Organization. They are saying that it is going to start in June, right? Then June වල wind flows ඔක්කොම start වෙලා තියෙන්නේ and going to last up until August, right? ඒතකොට A levels තියෙන කාලෙත් ඔක set වෙනවානේ. මම කියන්න හැදුවේ ඕකේ ෆිසික්ස් ඇස්පෙක්ට් එකකුත් තියෙනවා ඉතින් ෆිසික්ස් ඇස්පෙක්ට් එකක් තියෙනවා කියලා කියන්නේ in terms of hygrometry humidity right it is happening right basically what is happening is this මං කිව්ව ටර්ම් එක මතකයිද ඒකට නමක් කිව්වා ඒක මතකයිද මතකයි එල්නිනෝ කියලා එකක් කිව්ව මතකයිද නේද මතකයි it is called El Nino, right? This word is coming from Greek or something, right? ඒකයි මේ නිකන් අමුතු වචනයක් තියෙන. That is called El Nino, right? El Nino කියන්නේ මෙහෙම සීන් එකක්. නිකන් දැනගෙන තියාගන්න මම මේක ෆිසික්ස් එක කියන්න හදන්නේ. ෆිසික්ස් එකට එන්න කලින් ඉතින් දැන් wind patterns ගැන කියන්න වෙනවනේ. Listen. මෙහෙම එකක් වෙන්නේ. Now, if you take the world from this side, right? මේ තියෙන්නේ ඔස්ට්‍රේලියා right? මං ඔස්ට්‍රේලියා වල මේ පැත්තේ කන්ට්‍රි එකක් ගත්තොත් මොනවද තියෙන්නේ? දැන් අර වර්ල්ඩ් එක වටේනේ තියෙන්නේ. ඔස්ට්‍රේලියා වල මේ පැත්තේ මොකුත් නැහැ වගේ සීන් එකක් තේරෙන්නේ. අය අර දිගටනේ දැකලා තියෙන්නේ ඕකයි ඔය කේස් එක. අන්න හරි. නෝර්ත් ඇමරිකානේ. හරිනේ? මෙන්න මෙහෙනේ තියෙන්නේ. right. කොහොමනේ තියෙන්නේ? සවුත් ඇමරිකා නෝත් නෙමෙයි. සවුත් ඇමරිකා. right. සවුත් ඇමරිකානේ තියෙන්නේ. හරි නේද? මේ කියන එක තේරෙනවනේ. ඔස්ට්‍රේලියාව වලට මේ පැත්තෙන් ගත්තොත් ඔයාලට පේන්නේ සවුත් ඇමරිකා. හරි? මේ අර මේක අරගෙන කරකවලා බලන්න. මැප් එක දාගෙන. කරකවලා බලන්න. ඒතකොට එහෙම නෙවෙන්නේ. දැන් ඕක අර හැමදාම පොඩි ගානේ දැන් අර දිගට දැකලා නිසා ඔස්ට්‍රේලියාව වලින් පස්සේ මොකුත් නැහැ වගේ තමයි නැත්තම් හිතෙන්නේ. මේ පැත්තේ සවුත් ඇමරිකාව වලින් පස්සේ මොකුත් නැහැ. අර පැත්තේ ඔස්ට්‍රේලියාව වලින් පස්සේ මොකුත් නැහැ වගේ දැන්. හොඳ නම එහෙම නින්නේ. ඔක ස්පීකර් එකට එද්දි, එර්ත් එකට එද්දි. right. මේකයි කේස් එක. listen. So usually right, earth has wind patterns or winds from South America to Australia side, right? දැන් ශ්‍රී ලංකාවේ ඉන්න කොහෙද ඒකත් කියන්න බෑ නැත්තම් කියන එක වැඩක් නැහැ. So එයා ශ්‍රී ලංකා. ඔස්ට්‍රේලියාවට වුණා වුණත් මොකද නේ ශ්‍රී ලංකාව එක දැනගන්න බෑ. එයා ශ්‍රී ලංකා. ඔස්ට්‍රේලියාව වලට බැලුවොත් කොයි පැත්තද ඉන්නේ? මෙහෙන් ඉන්න ඕනේ. හරි. උතර මෙන්න මේ හරිය. right මේ ඉන්දියා අපිත් ඔහොම ඉන්නවා. හරිද? උතර ඉන්දුනීසියාත් ඔහේ කොහෙද තියෙනවා ඔහොම. ඕනේ. මට නිකන් මේක විතරනේ ඕනේ. අපි මේ වගේ දැනගෙන ඉන්නවා. නිකන් roughly. හරිද? දැන් වෙන මේකයි usual wind patterns are occurring from South America to Australian side usually, right? And with this El Nino effect එකට reasons එකේ තියෙනවා geographical reasons, right? මට ඒක එච්චර වැඩක් නැහැ geographical reasons කියලා කියන්නේ global warming, right? Even cutting trees matters here. Even cutting a single tree matters to change these wind directions, right? When we do it in a larger scale it matters. Right? ඒ කියන්නේ මේ අද එකක් කපන එක විතරක් නෙමෙයි. Now these are the results of compound results, right? Compound results of all the things we have done for a long time, right? This is actually called a super El Nino this time, and for the last time a super El Nino has been in 1978 or something, right? පොඩ චෙක් කරලා බලන්න 1978 ගොඩක් කල් 1978 කියලා කියන්නේ it's almost how many years? 50 years, almost 50 years, right? 48 විතර ගිහිල්ලා ගොඩක් කලින් වෙච්ච සිද්ධියක් නේ. El Ninos are happening, but this time it is forecasted that it's going to be a super El Nino, right? Super means conditions are extreme, right? When මේකයි. Now this is the normal wind patterns, usual wind patterns Earth has, right? With the El Nino effect, these wind patterns are going to reverse. Wind patterns are going to reverse like this, right? With the El Nino, මේ El Nino එකත් එක්ක wind pattern එක reverse වෙනවා. When wind patterns are reversed, right? Listen, wind patterns are reversed. All heated මෙතන දැන් තියෙන්නේ ocean නේ. All heated water particles in the oceans are going to displace towards this direction, right? දැන් මේ පැත්තට heated particles යනවා. Right? And when heated particles are displaced to here, right, from the bottom of the sea, more cold particles are coming into the surface here, right? More cold particles are coming into the surface. මේ පැත්තට temperature එක දැන් අර usual තියෙන routine එකට වඩා අඩුයි. Here temperature is higher. Higher the temperature, what about vaporization? Now this is where I'm going to connect this to our hydro things and thermal. Higher the temperature, What about evaporation? Vaporization, evaporation. What about evaporation when temperature is higher? Increases. Evaporation increases, right? When evaporation increases, now from this side, from the skies, from the oceans here, right? It is going to evaporate more, right? More evaporation means more clouds. More evaporation means more clouds, more rain clouds at the end, right? Here, this is cold water. With respect to this, evaporation this side is minimum, right? Less, then less rain clouds. Almost now, since the conditions are extreme, right? Since the conditions are extreme this time, right? This region, South America, Argentina, Chile, ඔය මේ හරිය තියෙන countries තියෙනවනේ, right? ඔන්න countries එකට දැන් rainy clouds වැඩි වෙනවා. That is 3, 4, 5 times more than the normal level, right? Then therefore, these countries are going to get a heavy rainfalls, right? මේ පැත්තට heavy rainfalls එනවා during this time. මේ ඔක්කොම heavy rainfalls කියලා කියන්නේ මේ පැත්ත flood වෙලාම යනවා කියලා තමයි forecast එකේ තියෙන්නේ මේ WMO එකේ. Flood වෙනවා කියලා. Right? ඊට පස්සේ for these countries less rain clouds means less rain, right? Less rain කියලා කියන්නේ this is going to reach a drought situation, right? මේ පැත්ත අර extreme rainfall වලට යද්දි මේ පැත්ත extreme drought එකකට යනවා. Right? Then starting from Australia, right? Australia වලට impact එක වැඩි, and I have seen some news roaming around that Australia has already taken some actions for the El Nino coming up to preserve their animals, kangaroos, animals, right? People, මොනවාද sheets වගේක් එහෙමත් දීලා තිබ්බා roofing වලට දාගන්න. අපේ මොකුත් නැහැ ඉතින්. Australia දැන්ටම ඉතින් වැඩ බලන් අරන්. Because otherwise if there are like people, animal or whatever it is which belongs to country destroys after this, then when they are back in the normal situation, right? Then situation of the country is not as same as before, then they are going to control it. That is how developed countries take actions, right? We are still a developing country now, so we don't take any action. We haven't taken any action yet, right? නිකම්ම ඔය news වල මම යනවා දැක්ක යරන actions නම් මොකුත් නැහැ, right? The actions ගන්න ඕනේ, ඒක තමයි මේ කියන්න හදන්නේ. දැන් මොකද්ද කරන්නත් ඕනේ කියලා. Now from this side, including Australia, towards this side, right, the same thing happens, right? මේ ඔක්කොමඩ මේක වෙනවා. So Sri Lanka is also in the middle, right? So we are also going to get a drought, right? We are also going to get a drought, and these rainfall that we have these days are the final rainfalls we have before El Nino, right? අන්තිම ටික වගේ එකක් තමයි, right? The impact here is then මේකේ physics වැඩේ මේකනේ. These ones are going to vaporize more, then more clouds, may better rain, right? Here vaporization is less, right? Hygrometry part 10, vaporization is less, right? Then low humidity, right? Less rain, dry days means droughts, may better droughts වලට එනවා. ඕකනේ දැන් වෙන්නේ droughts වලට එනවා කියලා කියන්නේ. Now the thing is we have patterns in agriculture and all the things, no, right? Then ultimately our rice harvest is going to have an impact, right? Vegetables is going to have an impact, right? Other than that, finally drinking water is going to have an impact, right? Even WMO says that even a single drop of water is going to matter for these countries in the coming 2 months, right? එහෙම තමයි ඒගොල්ලෝ කියන්නේ. Then so from our side what we can do as a precaution is, right, we have to cultivate something. Cultivate means you can plant something, right? At least, because otherwise we will run out of food. දැන් එහෙම කියලා ස්ටෝර් කරගන්න කියලා නෙමෙයි කියන්නේ. ඒ කියන්නේ දැන් ඔගේ මේ කිව්ව ගාම වෙන්නේ මොකද්ද? ඊතන හරි ෂෝටේජ් එකක් එනවා. වඩුව තමයි කියලා ගිහිල්ලා අර සුපර් මාකට් පිටින් ගෙදර අරන් යනවා. එහෙම එකක් නෙමෙයි. ඒතකොට ඉතින් කාලවත් නැති වෙනවනේ. එහෙම නෙමෙයි. එහෙම කරොත් මේ not fair. එහෙම නෙමෙයි, right? But to knowing this, to face this, right, we better plant something in our gardens, right? ඒ කියන්නේ නිකන් ඔය හිතන්නකො rice නැති වෙනවා කියලා. rice අඩු වෙයි. නැති වෙනව නෙමෙයි, අඩු වෙයි. right? අඩු වෙද්දි ඔයා බතලාලයක් හරි ගෙදර හිටවලා තිබ්බනම් කන්න බලවන්නේ. something like that. ඉතින් මොනවා හරි නිකන් කරන්න බලන්න. ගස් කපන්නේ මේ ඉතින් ඉන්නවනම් පොඩ්ඩක් ඉන්න කපන්න නැතුව ගස් කියන්නේ ඔය නිකන් සමහර කට්ටිය රබර් එහෙම දැන් මේ ඔය රබර් එහෙම ලෑන්ඩ් ස්පීඩින් අයින් කරනවානේ. එහෙම හිතනවා නම් පොඩ්ඩක් if you can wait for 2 months that's better right. ඒ වගේ එකක් වෙනවා කියන්නේ අර ground water නිකන් මේ පැතිරෙන්නේ නැති වෙනවා right. ඒතකොට දැන් මේ වගේ සිටුේෂන් එක ground water නැති වුණාට පස්සේ ඒක තව worse වෙනවා. ඕක තමයි case එක. ඉතින් මේ අපිට කරන්න තියෙන අපේ පැත්තෙන් වර පුළුවන් තරම් තියෙන water sources පරිස්සම් කරගන්න right. water sources පරිස්සම් කරගන්න. ඉතින් ඔය ගස් කපන නම් ඒවා කරන්න එපා. plus especially අපි survive වෙන්න ඕනේ. to survive you can cultivate, you can plant something right. මොනවා හරි නිකන් අර ඔය අපේ තියෙන ඔය quick හදා ගන්න පුළුවන් දේවල් right. පඤ්ඤොක්කා ගියයි බතල ගියයි ඔය මොනවා හරි ඔය ඒ වගේ types තියෙනවනේ. මොනවා හරි එහෙම එකක් පුළුවන් නම් plant කරන්න try කරන්න right. කොස් ගස් එහෙම තියෙනවා පරිස්සම් කරලා තියාගන්න. අර ඒ වගේ එකක් වෙන්නේ ඊට පස්සේ දැන් ඕක ඉවරුනාට පස්සේ තව එකක් වෙනවා. දැන් අර දැන් අපිට ඉතින් ඔක්කොම හම්බ වෙනවා. ඕක ඉවරුනාට පස්සේ තව කේස් එකක් වෙනවා. ඕක ඉවරුනාට පස්සේ වෙන කේස් එක තමයි. Now once these wind patterns are restored again right, it is going to go back to normal right. ආයිද මේ back to normal. ආයි මේ direction එකට එනවා. back to normal මේ direction එකට එනවා. ඒතර මේ direction එකට එද්දි මේක ආයි දෙපැත්ත මාරු වෙනවා. right. ඇයි දැන් මේ තියෙන heated particles මේ පැත්තට එනවනේ. නේද? එහෙම වෙලා මේ පැත්ත මාරු වෙනවා. that is called La Nina. අර ඒවට ඉතින් තියෙනවා එක ඒවා. El Nino එකේ opposite එක තමයි La Nina. ඒ කියන්නේ අර opposite wind flow එක. La Nina, something like this. La Nina. Right? So after August you are going to get La Nina. දැන් දැනට තාම කියන්නේ El Nino ගැන විතරයි. තව ඉස්සරහට La Nina ගැනත් කියයි. right. එහෙම තමයි. එතකොට ඉතින් ඔයගොල්ලෝ exam දෙලි ඉවරයි. La Nina එද්දි. කොහොමත් El Nino ඉවර වෙද්දිත් ඔයගොල්ලෝ exam ලියනවා. La Nina සෙප්තැම්බර් වගේ ඒ කියන්නේ by the end of August තමයි La Nina එකක් එනවා කියලා කියන්නේ. මේ La Nina එක දැන් මේක අනිත් පැත්ත වෙනවා. ඊට පස්සේ වෙන්නේ now we are going to get a heavy rainfall. Then it is expected that it can go up to the rainfall levels that we had in Ditwa. right. එහෙම forecast කරනවා. ඒතර ආයෙමත් අර පොඩක් අමාරු සිටුේෂන් එකකට එනවා. හරි. එලිනෝත් ඇවිල්ලා La Ninaත් ඇවිල්ලා අන්තිමට ඔක්කොම අපේ පිටින් තමයි යන්නේ. මේ අතර මේගොල්ලෝ එක්ස්පෙක්ට් කරනවා මේ La Nina එක આવොත් මේ දැන් ශ්‍රී ලංකාව වගේ කන්ට්‍රි එකකට අපිට ඩිට්ටවලදී ආපු රේන්ෆෝල් ලෙවල්ස් වලට යන්න පුළුවන් කියලා. right. තව ලඟ වෙන ඕක more accurate වෙයි. දැන් තව 3 months විතර තියෙනවා La Nina එකට. මේ හැබැයි ඒ ලෙවල්ස් වලට යන්න පුළුවන්ලු. එහෙම ගියොත් දැන් රවුට් එකේ ඉඳලා කර කුට්ටම් වෙලා අන්තිමට වහිනවා හේදිලාම යන්න. අර එහෙම එකක් වෙන්නේ. ඊට පස්සේ අර ඩිට්ටා වගේම එකකට යන්න පුළුවන්. එහෙම වුණොත් මේ පාර damages තව හොඳට වැඩි වෙනවා. මොකද now still soil is recovering after ditwa right. ඔය තාම hill countries වල soil එක අර කලින් තිබ්බා වගේ stable නැහැ right. ඒ තාමත් ඒ ඔක්කොම තියෙනවා. still that is in the process of recovering no. ඕක recover වෙන්න යනවා more than like 10 years 15 years ලේසියෙන් ඕක recover වෙන්නේ නැහැ. එහෙම තමයි හැටි. තාම දැන් recover වෙන ගමන් ඉන්නේ. එතකොට ඕක උඩට ආයිත් rainfall එකක් set වුණොත් තව අරිට වඩා soil layers ගැලවිලා යනවා. ඒතර නිකන් දැනගෙන ඉන්න මෙහෙම එකක් දැන් වෙන්න යන්නේ. ඒතර මේ ඕගලන්ටත් exam ලියන්න වෙන කාලෙත් ඔය වැඩෙත් set වෙනවා හොඳේ. එහෙම එකකුත් තියෙනවා ඉතින්. නිකන් කිව්වේ මේවා දැනගෙන ඉන්න ඕනේ ඉතින් මේ general knowledge දැනගෙන ඉන්න. right. let's go to next one. experiment 4. and you are the batch who got the least number of days before the exam from all recent batches no right. now take the advantage right. මේ ඒකත් මම කියන්නේ take the advantage කියලා කියන්නේ. now it's true that you got the least number of days right. මම ඊයේත් කවුරු කෙනෙක් post එකක් කරලා තිබ්බා last 5 years වල days එහෙම අහලා postpone වෙයිද කියලා. now for now there's nothing no any clue about postponements right. මම කියන්නේ postpone වෙන්නේ නැත්තම් හොඳයි කියලා ඉතින්. because the thing is now if you enter university say 3 months before right, which means your everything in your life is going to be 3 months before right. entering the university, passing out, getting to a job right, maybe your marriage everything ඔක්කොම 3 months before වෙනවා. ඔක්කොම වෙනවා. ඉතින් හොඳයිනේ. පොඩි කට්ටක් තියෙනවා. you have to do some sacrifice and the other thing is, now because of those things and several reasons, there are a majority of students who are not performing in their normal, what we call the performances, right? So therefore, even if you put a little bit more effort these days, you can emerge quickly. That's the thing. මේ පාර majority එක පොඩ්ඩක් අර ඔය එක එක case එක පොඩ්ඩක් අවුල්. Right? I personally believe that Z scores will also fall by a bit this time. 25 එක compare කරලා 26 වල පොඩ්ඩක් අඩු වෙන්න ඕනේ. මොකද කට එක performance පොඩ්ඩක් අර මදි. ඒකට එක reasons තියෙනවා. Right? And සමහර classes වල මේ දවස්වල නිකන් syllabus cover කරගන්න බැරුව struggle කරන වගේ scene එකේ ඉන්න classes තියෙනවා. ඔය ඕන subject එකේ හොඳේ. ඕන subject එක අර يعني ඇත්තම දවස් අඩුයි තමයි. But still, if you can take that challenge and do it easily, you can pop up from that majority crowd. That's a good thing. Right? ඒ කියන්නේ ඔයා පොඩ්ඩක් හරි මහන්සි වුණොත් majority එක මේ පාර ටිකක් අර මදිනේ මේ කියන්නේ මදි කියන්නේ kind of lacking some things, right? So therefore, easily you can pop up from that sample, right? Majority එකෙන් උඩට එන්න lazy. ඒ නිසා I think පොඩ්ඩක් වැඩේ කාගෙන වැඩ කරන්න. Only 9 weeks, right? ඒකෙන් 9 weeks වලින් වැඩේ කරලා වැඩේ ඉවර කරන්න. That's it. Right? අර competition එක කියලා කියන්නේ මෙහෙමයි මේ ඔයා give up කරන්න නැතුව වැඩ කරගෙන ගියොත් නිකම්ම උඩට එන්න පුළුවන්. අනිත් ඒවාට වඩා පොඩ්ඩක් අනිත් ඒවාට වඩා කියලා කියන්නේ if I compare with the other times, right? You can easily pop up from that crowd, right? ඒ chance එක තියෙනවා. ඉතින් ඒ chance එක ගන්න. Right, okay, let's go. Experiment 4. Write down. Practical 4, experiment 4. Write down. Determination of specific latent heat of fusion of ice. Determination of specific latent heat of fusion of ice. Determination of specific latent heat of fusion of ice. Determination of specific latent heat of fusion of ice using method of mixtures. Using method of mixtures. Right, make it easy. Right. මෙහෙමයි වෙන්නේ. Listen. හරි අපි materials එක ලියමු. මේකේ theory එක explain කරන්න lazy. Write down materials and apparatus. Materials and apparatus. Right? Materials and apparatus. Write down a calorimeter. Don't draw, write down a calorimeter. A stirrer, thermometer, thermometer. Stirrer කියන්න බැරුණානේ. Listen. Stirrer තමයි, that is called a square net or net stirrer. Right? මේක specialty එකක් තියෙනවා ඒක කියන්න. Write it as net stirrer. Net stirrer. ඒක පොඩ්ඩක් special එකක්. ඒක මොකද්ද කියලා කියන්න. Net stirrer. That is also called square net stirrer. එහෙමත් කියනවා. නැත්නම් net stirrer. Right? net එකක් තියෙනවා. ඕක තමයි ඔයගේ idea එක. net එක මොකද්ද කියලා කියන්න. Right, then heat insulated lid. Heat insulated lid. Then sufficient amounts of water and ice. sufficient amounts of water and ice. Sufficient amounts of water and ice. Right? Then triple beam balance. Triple beam, 4 beam or electronic. Triple beam / 4 beam. Right? මේක නම් chemical use කරන්නත් පුළුවන්. Right? Chemical balance කියලා එකක් තියෙනවා දන්නවද? Chemical or electronic ඕන එකක් පුළුවන්. And since we need more accuracy, it's better to go with 4 beam, electronic or chemical. Right? And very importantly, this is a unique one, filter papers. Right? මොනවද කියලා කියනවා? Filter papers. Filter papers. Filter papers. Filter papers. Right? Listen. මේක label කරලා මෙමු. Now this is the insulated cover as before. Right? Insulated cover. අර කලින් වගේම තමයි ඉතින්. All the heat loss from conduction, convection and radiation should be minimized. Right? දැන් කලින් explain කරලා නිසා මම ඒවා ආයි අර in detail explain කරන්න නැහැ. These are insulated supporters. Right? අර කලින් ඒවා තමයි conduction, to minimize conduction. Insulated supports. Right? And insulated lid. Right? Insulated කියලා කියන්නේ heat insulated. And this is net styrer. Net styrer. Right? Net styrer, thermometer, thermometer. Right? මේක තමයි calorimeter එක. Calorimeter. Calorimeter. Right? ඊට පස්සේ මේක water වලින් fill කරලා තියෙන්නේ. මේ තියෙන water. Right? ඊට පස්සේ මෙතන දාලා යන්න. This is called ice chips. Ice chips. Ice chips. Right? Ice chips නැත්නම් small pieces කියලා කියනවා. Small pieces. Right? Now take down the diagram and label. Right? මේකේ theory එක lazy. Take down the diagram and label. Right? කරන්නේ කොහොමද කියලා කියන්නම්. Ice chips ආවේ කොහෙන්ද ඒ ටික කියන්නම්. Take down the diagram and label it. I think in one of the recent paper discussions also I discussed this one, right? Ribbon? Ribbon? Okay, finished? Finished? and check labels, net styrer, calorimeter, insulated cover, right? අර කලින් වගේ තමයි rigid form වගේ එකක් දාන්න නැත්නම් air itself is also fine, right? cotton දාන්න පුළුවන්, cotton වල වඩා rigid form හොඳයි, right? rigid form is the best one we have nowadays කියලා කියන්නේ best one we have now with the availability and everything. Insulated supports, ice chips, or that is called small pieces of ice chips, නැත්නම් small pieces, thermometer, insulated lid. හරි? right. මේමයි කරන්නේ. listen. So first of all, we have to have an ice cube, right? First of all, we have to have an ice cube, and you have to break it into small pieces. You have to break it into small pieces. Small pieces doesn't mean too small. Small pieces කියලා කියන්නේ that is not too small pieces. මේ chips කිව්වම තේරෙනව නේද? right? chips කියලා කියන්නේ පොඩි pieces කියන එකනේ. අර නිකන් powder එකක් වගේ වෙන්න බෑ. ඒ කියන්නේ නිකන් ගොඩාක් පොඩි වුණොත් experiment එක කරන්න බැරි වෙනවා. මම ඒක reasons වලදී කියන්නම් ඉස්සරහට. right? Because now always we are going to add ice chips, melting ice chips to the system here. Melting ice chips තමයි දාන්න ඕනේ. right? How to make sure ice chips are melting? Ice chips melt වෙනවා කියලා කොහොමද අපි බලාගන්නේ? right? When you keep it in atmosphere, right? You should see some formed water. Water form වෙලා තියෙන්න ඕනේ. ඒකනේ melt වෙනවා කියන්නේ. right? Then that is a verification that your ice cube is not at a negative temperature. නැත්නම් දන්නේ negative තියෙන්නේ කියලා. right? You have to make sure that it is at zero. Melting ice. right? Melting ice දැන් melt වෙද්දි around the ice cube දැකලා තියෙනවනේ. Around the ice cube or ice chip, right? We have a small layer of water, right? Ice cube එක melt වෙද්දි layer එකක් එනවනේ water, right? To remove that water layer, we have filter papers here, right? Ice chips ගන්නවා. පොඩි ice chips, small pieces, and have to remove the water layer around the ice chip by the filter papers, right? Filter papers කියලා කියන්නේ ඒක තියෙන අරක පිහ දාන්න. To remove water layer, right? ඒක හොඳට remove කරලා, right? You have to remove it, and then only one piece at a time, one piece is added to the calorimeter, right? There is an initial amount of water inside the calorimeter, right? Agan. Okay, sir. Right? There is an initial amount of water inside the calorimeter, and one ice chip is added at once, right? And when ice is added, what can you say about density of ice and water? What is higher in density? Water, right? So ice floats. When ice floats comes to the surface of water, no? right? If it comes to surface of water, 10% of ice cube is going to be above water. 90% is only immersed, right? If 10% is above water, that is not going to get heat from the water, no? right? So therefore, you have to make sure that ice chip remains inside water until it is fully melted, right? For that, net styrer is used. net styrer එකේ තියෙන්නේ මේ styrer එකේ තියෙන net එකක් එක්ක. net එකක් එක කියලා කියන්නේ have you seen මේක දැකලා තියෙනවද? අර මේ පරණත් නෑ දැනුත් තියෙනවා. පරණ නෑ නෑ පරණ නෑ. හරිද? මේ ඉස්සර නෙමෙයි. සමහර ගෙවල් වල ඉස්සර කියන්න බෑ. සමහර ගෙවල් වල තේ හදද්දි දැකලා තියෙනවද මේ if you are not using tea bags, අර I hope you are not using tea bags. අර මෙහෙම එකක් use කරනවා මේ ඒකට නිකන් තේ ගොට්ට කියලා කියන්නේ ආච්චිලා හැම. ඒක හැබැයි ආච්චිලා වගේ තමයි ටිකක්. ඈ? ගොට්ට. ඈ? What's the term for that? ඒක term එකක් තියෙනවද? term එකක් තියෙනවද? දන්නේ නැහැ මං අහලා. term එකක් තියෙනවද? ඉංග්‍රීසි term එකක් තියෙනවද? ඉංග්‍රීසි term එකක් තියෙනවද? තේ ගොට්ට අහලා තියෙනවද? තේ ගොට්ට දන්නේ නැද්ද? තේ ගොට්ට දන්නවා ඉංග්‍රීසි term එකක් තියෙනවද? මං හිතන්නේ ඒකට ඉංග්‍රීසි term එකක් නැද්ද කොහෙද? right? Anyone? I haven't heard English term. I haven't come across any English term for this. You have seen this, right? මේක දන්නවනේ. මේකට මේ දන්නවද තේ හදලා තියෙන? මේකට මොනවද දැන්? මේකට අර මේක දාලා right? මේ කුඩින් වතුර දාලා මෙහෙම කප් එකක් තියලා මෙහෙම තේ එකක් හදාගන්න දන්නවනේ. මෙන්න මේක තියෙන්නේ. right? Let's say it's තේ කොට්ට for now. ඒක තේ කොට්ට තමයි ඉතින් වෙනවද දන්නේ නැහැ. මොකද කියලා මේකම තමයි මේ තියෙන්නේ. මේ වගේම එකක් තමයි මේ තියෙන්නේ. අර ඒ කොට්ට shape එක තියෙන්නේ. right? මෙහෙම එකක් තමයි දැන් තියෙන්නේ. right? with the handle මෙහෙම මේකට handle එකක් තියෙනවා. කොහොමද තියෙන්නේ? right? මේක net එකක්. this is net අරගම තමයි යෝද. මේක net එකක් තියෙන්නේ. බලන්න. this is net. Then when the ice chip is inside, listen, when the ice chip is inside, that is going to cover by this net, no? Right? ඔන්න ඕක තමයි මෙයාගේ purpose එක. net styler. Right? Then if you ask whether a normal styler can be used, no. එහෙම use කරන්න බෑ. එහෙම වුණොත් ice cube එක උඩට එනවා. Right? ඒකයි net styler එකක් use කරන්නේ. Now what happens is, right? What happens is this ice cube is going to absorb heat from water, no? And it is going to melt. Ice melts. Ice එක melt වෙනවා. Ice එක melt වෙනවා. Right? So likewise, we will be adding ice pieces one by one, right? One by one, only one at a time. One by one, after removing water from filter papers, you have to add it one by one, and finally, these readings are taken, right? The readings මම මුලින්ම මොකුත් කිව්වේ නැහැ. readings කියලා කියන්නේ මේ ටික. මුලින්ම අර කලින් වගේම තමයි. We need empty calorimeter with styrer. Let's say M1. Then after water is filled, then water plus calorimeter styrer, say M2, right? Then initial temperature of water, theta 1, right? Then final mass of system, right? M3, right? Now mass of water is here, no? Mass of water is M2 minus M1. Alright? What is mass of ice added? කොහොමද ඒක ගන්න? M3 minus M2. right? මේ තියෙන්නේ ice add කරන්න කලින්නේ. Then mass of ice මෙතනින් එනවා. mass of ice M3 minus M2. right? Now all heat losses are controlled here. right? Then precautions ටික දන්නවා. conduction, convection, radiation are controlled. right? Then we can assume that there's no heat loss to the environment, right? Other than that, we are going to follow method, heat compensation method in this one as well, right? Our temperature difference එකක් ආව ගමන් අපිට compensate කරගන්න වෙන විදියක් නැහැ. Then only option we got is heat compensation. ඒ විදිහට මේකත් කරනවා. right? Then if there's no heat loss to environment, right? Tell me, what is the equation? What is the relationship between ice and water now? Ice is absorbing heat, no? Ice absorbs heat, and first of all, it should be melted, right? Then melted ice is at which temperature? Ice melt වෙච්ච ගමන් තියෙන මොන temperature එකද? 0, right? Then it is increasing. It should increase its temperature to the final temperature, right? Ice melts වෙලා මේ system එක 0 වල තියෙන්නේ නැහැනේ. The system is going to reach the equilibrium in some kind of a temperature somewhere in between. right? දැන් හිතන්න 25 කියලා. ඒතකොට 0 ඉඳන් 25 වෙනකන් අර මෙල්ට් වෙලා ආපු ice ටිකත් heat වෙන්නත් ඕනනේ. right? ඕක තමයි වෙන්නේ. Now this side is ice. See? Heat absorbed by ice equals heat liberates by water plus calorimeter. Right? Ice absorbs heat for two things. First one is state change, melting. Ice එක melt වෙන්න ඕනේ. හරි? Melt වෙන්න ගිය heat එක ml. Mass of ice is M3 minus M2. Into L of ice. Right? Right. මෙන්න දැන් ice එක melt වුණා. M3 minus M2. Mass of ice is melted, and now it is at 0. If the final temperature of the system is final temperature එකක් තෝරන්න. Now finally final mass and final temperature. Say theta 2. Right? If the final temperature of the system is theta 2, water forms by ice is initially at 0. It should increase its temperature up to theta 2, right? එහෙනම් මේ පැත්තට තව පාට් එකක් එන්න ඕනේ. It is also absorbing heat. It absorbs. initially 0 නේ තියෙන්නේ 25 වලට යනකම් යන්න ඕනේ 25 ඕ final temperature it absorbs heat එහෙනම් absorption පැත්තෙන් එන්න ඕනේ then same ice amount m3 minus m2 same ice amount absorbs heat cw theta 2 minus 0 until it is reaching the final temperature right එහෙනම් මේක තමයි ගොඩක් අයට මිස් වෙන්නේ මේක මේ එක්ස්පෙරිමන්ට් එක කරද්දී ice melt වෙන එක ලියනවා හැබැයි heat increase එක ලියන්නේ නැහැ when ice is melted it is at 0 වල තියෙනක final temperature එකට යන්නත් ඕනේ right clear then from the other side it liberates by water and calorimeter water කියලා කියන්නේ m2 minus m1 right then this water is coming from initial temperature to final temperature theta 1 minus theta 2 right because the system is cooling down right system cools down ice ne add kare system cools down then it is coming from theta 1 to theta 2 එහෙනම් මෙතන temperature difference එක කියලා කියන්නේ theta 1 minus theta 2 and the calorimeter with stirrer right this ES is also coming from theta 1 to theta 2 right මෙන්න heat equilibrium එක thermal equilibrium එක right using this equation m3 m1 m2 m3 cw cs are known right which means L can be determined right අපි හොයන්න ගියේකනේ L can be determined right ඕක තමයි experiment එක right any questions right තව explain කරන්න කලින් කියන්නේ තව ලියන්න කලින් any questions අතන explain කරලා ඉවරයි I have explained everything about the experiment now right special things මොකුත් කිව්වේ නැහැ but everything about the experiment is explained any questions before we take this down all good අනේ right then diagram එක යන්නනේ right method කියලා method first point measure the mass of it is called strainer strainer තමයි නේ හරියයි that's correct good strainer yes double strain කියලා එහෙම අර මේක හරි strainer තමයි term is correct strain double strain කියලා term සාල් නැද්ද ඉමේෂාල තියෙනවා වගේ ආලනේ හරි strain තමයි හරි thanks right අර මට ඒක strain කියන එක ආවේ නැහැ මොකද double strain කියන word එක මම double strain අහලා තියෙනවා single strain double strain දන්නවා මේ හැබැයි ඒක ටී ඉන්ඩස්ට්‍රි එකේ නෙමෙයිනේ අහලා තියෙන්නේ ඒකයි ඒක ඔයගොල්ලෝ අහලා ඇති මේ බා ඉන්ඩස්ට්‍රි එකේ තියෙන බා වල ඒ කියන්නේ පබ් වල එහෙම ඔය මේ මොනවාද මොක්ටේල්ස් මේ මොක්ටේල්ස් නෙමෙයි කොක්ටේල්ස් ඔය එක එක දන්නවනේ මේ කොක්ටේල්ස් සමහර ඒවා ඩබල් ස්ට්‍රේන් කරලා එහෙම දෙන ඒවා තියෙන අන්න ඒක right ඒක ඩබල් ස්ට්‍රේන් නැත්නම් සිංගල් ස්ට්‍රේන් නැත්නම් ඩබල් ස්ට්‍රේන් හරි කරලා දෙන්න right it's correct good okay thank you measure the mass of empty calorimeter plus with stirrer measure the mass of empty calorimeter with stirrer measure the mass of empty calorimeter plus stirrer with stirrer within brackets m1 right next point add water up to 2/3 of height අර කලින් වගේම තමයි up to 2/3 of height up to 2/3 of height of calorimeter up to 2/3 of height of calorimeter and measure the mass of water, comma, calorimeter with stirrer. Mass of water, calorimeter with stirrer, within brackets M2 and M2 and initial temperature of system and initial temperature of system. Right? Next point. At dry ice chips, dry means it should be, water layer should be removed. Dry ice. Right? Dry ice කියලා කියන්නේ water layer නැති එක හොඳ. ඒකට තමයි filter papers use කරන්නේ. Right? අර අනිත් ඔයගොල්ලෝ දන්න dry ice නෙමෙයි. Right? තව එකක් තියෙනවා dry ice කියලා ඔය මේ carbon වලින් එන එක. ඒක නෙමෙයි. Right? මේ dry ice කියලා කියන්නේ when the ice cube is dry. Right? නැත්නම් අර carbon structure එක නෙමෙයි. Right? මොනවද කිව්වේ? At dry ice chips, one by one, at dry ice chips one by one, while well stirring water, Next point. Stop adding ice chips. Stop adding ice chips when temperature of system has fallen significantly. When temperature of system has fallen significantly, within brackets about 5 degrees Celsius, about 5 degrees Celsius, right? Then next point, take the final temperature within brackets minimum temperature. Take the final temperature within brackets minimum temperature of water and record it. Next point, measure the final mass of system. Final temperature within brackets theta 2. Final temperature within brackets theta 2. Right? Within brackets theta 2. Then next one, measure the final mass of system within brackets M3. Final mass of system M3. Right? Okay, then put a subheading as calculation. Write down according to the theory. Right? Put a comma and start from here. Right? Take it down. We didn't mention the readings yet, right? Readings down and readings no. Readings it's fine. In the description we have the readings, but I didn't list down. Right? My readings or method right. So below this, list down the readings as well. List down the readings as well. Readings right? List down these readings. And have to add 3 more here, right? Specific heat capacity is right? Then for readings, list down this mass of empty calorimeter with stirrer M1, right? Second one, mass of water, comma, calorimeter with stirrer M2. Right? Third one, initial temperature of water, initial temperature of water, right? Next one, right? Final temperature of, next one, final temperature of water, theta 2, final temperature of water, theta 2, right? And then final mass of system, M3, final mass of system, M3, right? Next, specific heat capacity of water, CW, specific heat capacity of water, CW, right? Specific heat capacity of water, CW. Next one, specific heat capacity of calorimeter, CS. Then specific latent heat of fusion of ice, 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 L, capital L. Right. Write down below. L can be determined, capital 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 L can be determined using above equation, can be determined using above equation. Right? Okay, remarks. This is done, right? Go to remarks. Right, listen. Now, in this experiment, we are in a decrease in temperature. No? If temperature decreases beyond dew point, right? Again, dew forms, right? When dew forms, to form dew, some amount of heat is absorbed by dew, right? So therefore, we are going to have an error. Then first thing is you have to make sure that your final temperature is a value greater than dew point, right? And dew point measure dew point measure plan right? Nikang itana dana bhai think dew point exceed make a dew right? From the outer surface dew right? First point, write down first point. Final temperature of system, final temperature of system should be greater than dew point, should be greater than dew point. Right? Within brackets. Otherwise dew forms and calorimeter absorbs some heat from dew. Which is not included in calculation. Right? For the same point, brackets same point check dew point before starting the experiment. Right, next point. Heat loss to environment. Heat loss to environment by conduction, convection and radiation. By conduction, convection and radiation should be minimized as discussed before. කියලා කියන්නේ reference එකක් code නම් දාගන්න. මම ඔක discuss කරේ in experiment 2. අද කරපු 2 එකේ. හරිනේ? එතකොට radiation එක නැති කරන්න මොකද්ද කරන්න කියලා කිව්වා. නැති කරන්න නෙවෙයි. To minimize radiation, what's the precaution? To minimize convection, conduction කිව්වනේ. අන්න ඒ ටිකම තමයි. Right? Next point. Heat compensation method. Heat compensation method is used for more accurate value for L by minimizing for more accurate value for L by minimizing the error caused due to heat transfer with environment. Error caused due to heat transfer with environment. Right? Next point. Only small ice chips are used to ensure melting ice is added. To ensure melting ice is added to calorimeter. Right? Within brackets, write down ice cubes are not added. Since it's difficult to control final temperature. And ice powder කියලා කියන්නේ very small chips are not added because it melts because it suddenly melts, clear? Because it suddenly melts. Because it suddenly melts even before adding. It suddenly melts even before adding. Right? Next point. Next point. Ice chips should be wiped with filter papers, wiped with filter papers to remove all water, from ice, and only dry ice chip, dry ice chips are added to the calorimeter. Right. Next point. A net stirrer is used. A net stirrer is used. A net stirrer is used. A net stirrer is used to prevent ice chips. Floating at the surface of water. To prevent ice chips floating at the surface of water. Right? Okay. That's it. Let's see what's here. It is advisable to determine the dew point AQ1 approximately before mixing ice. Then, by preventing the final temperature of mixture going below the dew point, the error caused by dew depositing on the calorimeter surface can be minimized. Right? When the temperature of the calorimeter begins to fall below room temperature with the mixing of ice, it begins to gain heat from surroundings. This can be minimized by lagging the calorimeter with heat absorbing materials. Lagging covering. Lagging means covering. Right? Ab heat conduction lagging systems. Right? Then OS compensation method used in the method of mixtures can be used. Right? Heat of the calorimeter. Right? Okay. Right. Any questions? Any questions? Any questions from these two? Right? Point when it comes to thermal experiments, method is kind of simple, but the background is not that simple. It is kind of comprehensive. Background එක තමයි ගොඩක් ඒතකොට දැනගෙන ඉන්න ඕනේ. Right? ඒ හින්දා එකෙන් හොඳටම ප්‍රශ්න අහනවා. Right? Background is comprehensive. Background එකේ ඔය එක එක reasons ඔක්කොම ටික දැනගෙන ඉන්න. All good? Right? Online? So, are the ice chips added? Are they added one by one or as above? I already told you. One by one. Any other questions? Any other questions? All good? Yeah. More than? Calorimeter දැන් මෙහෙම නෙවෙයි. Dew form වෙනවා කියලා කියන්නේ gas particles liquid වෙන්න ඕනේ. මොකද්ද? Absorption එකද liberation එකද? Absorption එකනේ. Right? Absorption නෙමෙයි. Liberation එකනේ. Then absorbed by calorimeter. Right? Liberate කරන්නේ dew particles. ඒක absorb වෙනවා ඒතර calorimeter එක. Right, what else? හරි නේද? ඒක confuse වුණා නම් right when dew forms right ඒ point එක confuse වුණා නම් when dew forms dew form වෙනවා කියලා කියන්නේ right dew form වෙනවා කියලා කියන්නේ water is coming from gaseous state to liquid state right gaseous to liquid නෙන්නේ gaseous to liquid වෙනවා කියලා කියන්නේ heat is released right හරි නේද මේක gaseous to liquid නේ then this is emitting heat releasing heat liberating මේ පැත්ත liberation එක when there is a liberation calorimeter is going to absorb that heat right ඒක තමයි මම දුන්න point එක හරිනේ ඒතර calorimeter එක absorb කරනවා dew වලින් liberate වෙච්ච heat එක කියන්නේ dew වලින් අපිට ඕන නැති heat එකක් liberate වෙනවා ඒ අපිට ඕන නැති heat එකක් කියලා කියන්නේ that heat is not included in our calculation that's the thing dew වලින් ආපු heat එක calculation එකට දාගන්න දෙයක් නැහැ right all good set මිද ඉන්නවා right හරිද හරිද මේක කන්ෆියුස් වුණා නම් ලියා ගන්න that's a good question right dew form වෙනවා හරිනේ මේක තේරෙන්නේ නැතිනේ dew form වෙනවා forming dew means water vapor liberates heat right that heat is absorbed by calorimeter හරිනේ ඔයගොල්ලෝ හරිනේ okay then practical 5 ඔය බ්‍රේක් එකක් කොහොමද හා සද්දද බ්‍රේක් එකක් ගන්න what's the time 1:35 15 minutes right මේ ඕගොල්ලෝ ආයි කනවද නෑනේ අර main meals නෑනේ නැත්තම් එහෙම 1:35 1:50 PM නෙමෙයිනේ මොනවාද AM right so we'll regroup by 1:50 Right. Right, we'll start. Okay, let's start.
So after one ice chip melts, we have to remove the lid and add another ice chip.
Not really. In the lid, there's a small what we call in some lids. In some lids, there's a small what we call a hole that you can add ice chips. Close කරන්න පුළුවන් එකක් තියෙනවා. එහෙම නැති එකක් වුණොත් නම් ඉතින් remove කරලා add කරන්න ඕනේ. Right. Go to experiment 5. Experiment 5. Experiment 5. Right. The last experiment for the day from method of mixtures. Right? From method of mixtures, last one for the day. Right? Right, write down determination of specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water by method of mixtures. By method of mixtures. Right. So here also I can explain after materials and apparatus, right? But the thing is, again, the background is there, but the method is again simple. Right. Mention materials and apparatus. Right. Materials and apparatus. Materials and apparatus. Mention. A calorimeter. A calorimeter. A calorimeter. A calorimeter. Right. Then we have a special one here that is called a steam generator. Right. මේක තමයි A මොකද කියලා කියන්නම්. Next one, steam generator. Steam generator. Steam generator. Steam generator. Right. Then stirrer. Next, thermometer. Next, thermometer. Next, steam trap. Steam trap. Steam trap. Right. Next, heat insulated sheet. Heat insulated sheet. Heat insulated sheet. Right. Bunsen burner. Bunsen burner. Right. Then balance can අපි ආම මොකද ලියන්නේ? Mesh එක ලියුවෙත් නෑනේ. Then a wire mesh නැත්තම් wire net, right? Wire mesh. A wire mesh. Right? 4 beam balance. Right? මේක නම් triple beam use කරන්නේ නැහැ because we are going to measure steam, right? It's a very small amount, very small mass, right? Triple beam එකෙන් අමාරුයි, right? It should be either 4 beam or chemical, right? Steam එකට measure කරන්න යන්න කොහොමද කරන්න කියලා කියන්න. Right? 4 beam balance slash chemical balance. 4 beam balance slash chemical balance. Right? Listen. Okay, this is the apparatus. This is called, listen, I'm going to explain while labeling this. This is called the steam generator, right? The steam generator, right? The literal meaning is this. Steam generator means when we burn this from the Bunsen burner, right? Inside this, we have water, right? And until this is reached, this is heated to the boiling point, steam generates, right? To take that steam as an output, this wire is put. This wire this tube is put. Wire can tube this tube is put. Steam now the generated heat can come along this tube to this one. This is called the steam trap. This is called the steam trap. Steam trap. Right? What happens here is when steam is coming from here to here. Now, what is the temperature of steam at here? 100, right? That is at 100. Steam හැදෙන ගමන් තියෙන්නේ. This is forming steam. Steam එක ආයි heat වෙන විදියක් නෑනේ. Boiling water නේ තියෙන්නේ. Forming steam. That is at 100. But when it is reaching to this side through this tube, right? If the temperature decreases below 100, what happens? If the temperature of steam decreases below 100, because it is coming from here to here through this air medium, steam is at 100. What if temperature decreases below 100? What if temperature decreases below 100? Can there be steam at 99? No. Then what is there at 99? Water. Water හැදෙනවා. Water හැදෙනවා. Steam එක cool වුණොත් water හැදෙනවා. Right? Then purpose of using steam trap is this. Right? මේ නමයමත් තියෙනවා steam trap. And trap එකක් මේ. Steam එකට trap එකක් බලන්න. මෙතන ඉඳන් steam එක එනවා. Right? And some amount of steam can be converted to water again if that is cooled down. Right? Make a water or not, that water is falling down. Steam flowing on, steam is flowing and water is falling down. Right? For this water to go out, this outlet is there. Water hadunot water එක එළියට යන තමයි මේ තියෙන්නේ. Right? And since steam is a gas, steam කියන්නේ gas එකක්. It floats, right? It flows. This tube is put with the bend. මෙතන මේ bend එකක් තියෙනවා පේනවනේ. right? මම මේක මෙහෙම අන්දොත් මේ bend එකක් තියෙනවා. right? It is fixed with the bend. Then water is not going to go through this one because water falls down. Water එක මේකෙන් වැටෙනවා. මේක ඇතුලෙන් ආයෙ යන්න විදියක් නැහැ. Only the steam is going to go in and reach here. right? ඒක තමයි steam trap කියන්නේ. If there are water forms, if there are water molecules forms, they are going to go out from this right? Because our purpose is, if water has already formed, it should not be mixed with water here. Steam එක විතරක් මට mix කරගන්නයි ඕනේ. Only the steam should be mixed, right? Only the steam should be mixed. අර මෙතනින් මේ outlet එකෙන් water එක යනවා. Steam එක මෙතන bend එකක් තියෙන එකයි bend එකක් නැතුව straight එකක් තිබ්බනම් water මෙතනින් එන්න පුළුවන් නේ. ඒකයි bend එකක් දාලා තියෙන්නේ. Bend එකේ purpose එකක් සමහරලාට අහනවාද? Purpose of bend is to prevent water coming in through this tube, right? Only the steam comes through the bend, since that's a gas, right? And steam එක විතරක් මේක ඇතුළට එනවා, right? And this steam which is coming into the system is going to combine with water here, or going to mix with water here, right? Mix with water here, and it is going to do a state change. Water කියලා කියන්නේ දැන් 100 වල තියෙන එකක් නෙමෙයිනේ. Then it is going to do a state change. Then that steam should be converted to water at here inside the calorimeter, right? මෙතන convert වෙන එක මට වැඩක් නැහැ. ඉතින් අපිට වැඩක් නැහැ. Because that is out of the calculation, right? ඒකට තමයි මේ trap එක use කරන්නේ. නැත්තම් මේක මෙහෙම direct ගහලා දාන්න විදියක් නැහැ. Trap එක ඕනේ නැහැ direct ගහලා කරන්න පුළුවන් නම්. එහෙම කරන්න බෑ. Because then some amount of steam will be converted into water when it is coming from here to here, right? ඒ part එක අර අපිට segregate කරන්න විදියක් නැහැ. We can't separate or segregate that part, right? That's why steam trap is used, right? Steam generator, purpose of steam generator is generating heat, right? Purpose of steam trap is segregating water and steam at this point, right? Then only steam is mixed here. හරිනේ? steam එක විතරක් mix වෙනවා. steam එක විතරක් mix වුණාට පස්සේ මෙන්න මේකයි. steam does this state change, right? For the state change, is it an absorption or liberation by steam? Steam මොකද කරන්නේ? Liberation or absorption? Steam to water නේ දැන් වෙන්නේ. Steam to water. Liberation. හරිනේ? Heat loss, liberation. Then liberated heat by steam. මෙන්න බලන්න logic එක. Liberated heat by steam. Right? Readings ටික ලියන්න ඉඩ දෙලා මම මෙහෙම ලියන්නම්. Then liberated heat by steam is equal to, who is absorbing it? Water and calorimeter, right? Method එක simple, logic එක simple. Steam එකෙන් heat එක එනවා, right? Heat එක යා liberate කරනවා. Steam liberates heat, right? That liberated heat is absorbed by water and calorimeter here, right? That is absorbed by water and calorimeter here. Then absorbed heat by water plus calorimeter, right? Now what are the readings we need? අර කලින් ඔය තමයි දැන් නිකන් logically හිතලා වුණා readings කියන්න පුළුවන්. I need the initial mass of calorimeter before water is added, right? අර කලින් order එක මේ බලන්න මේ method of mixtures තුනම එකපාර පාඩම් කරන්න. ඒක මම අන්තිමට කියන්නම්. Method of mixtures තුනම එක වගේ. They are very comparative, right? When you study all three together, right? එතන තුනක් තියෙනවනේ. තුනම එක වගේ. Right, first one, there are differences ටික වෙනම බලන්න, but there are more similarities, right? First one, we need mass of empty calorimeter with stirrer, same one, right? Then mass of water calorimeter with stirrer, say M2, right? What is the initial temperature of steam? 100, right? 100, right? මෙතනත් steam තියෙනවා. මේ steam එක 100 වල තියෙන්න ඕනේ because it was at 100 here. මෙතනින් ඔක්කොම ටික outlet එකෙන් යන්න, right? And to minimize that, from our side what we do is we are making this tube as short as possible here, right? මම මේකේ part එකක් ඇඳලා නැහැ, මේක අඳින්න. Insulated sheet, right? අර කලින් කතාවම තමයි. Because if this gets a direct heat from this, again there is an error, right? Mass of water calorimeter and stirrer මෙතනින් එනවා mass of water initial system එකේ mass of water කියන්නේ එතකොට m2 minus m1, right? Then we need initial temperature of system කියන්නේ water, initial temperature of system, right? Now during the process, does it increase heat or increase temperature or decrease temperature during the process here? Increasing or decreasing? Water. Does it increase or decrease heat? Decrease temperature? Increase. Because heat is added. Heat නෙමෙයි. steam is added. Right? Steam at 100 is added. Right? And temperature. Then when it reaches the maximum temperature, maximum reach final temperature of the system is a maximum temperature. Right? We need maximum temperature. Then maximum or final temperature of system say 2. Right? Then finally the final mass. Final mass say M3. Then what is the mass of added steam? Mass of added steam. What is the mass of added steam? Mass of steam. M3 minus M2. Right? M3 minus M2. Right. Equation then dimension liberated heat by steam. Liberated heat by steam. Right. Steam now steam at 100 comes in. Then first of all it should undergo the state change. Right? State change ml. Then mass of heat is steam is M3 minus M2. M3 minus M2 say L. Right? Plus now steam is converted into water. Now converted water by steam is at what's the temperature? 100. Is at 100. Then it should cool down from 100 to final temperature of water. Right? Ice එක වගේම තමයි. ඒ විදියමයි. හරිනේ? steam එක ආවා. steam එක water වලට convert වුණා. හැබැයි steam water වලට convert වෙච්ච ගමන් ඒක තියෙන්නේ 100 වල. Right? That amount of water is at 100. It should cool down to the final temperature. Right? එහෙනම් මෙයාට තව MSC එකක් මම ලියන්න ඕනේ. This same mass should be cooled down. Right? මෙතනින් පස්සේ දැන් water නේ. Cool down from 100 to theta 2. හරිනේ? 100 minus theta 2. 100 to theta 2, 100 minus theta 2 equals absorbed heat by water and calorimeter. Mass of water is M2 minus M1. M2 minus M1 CW. Right? Plus make a calorimeter M1 CS. Right? What is the temperature difference for this system? Temperature increase theta 2 minus theta 1. Theta 2 minus theta 1. Theta 2 minus theta 1. Right. Since everything else is known, L can be determined. Right? Method of mixtures and especially latent heat of fusion of ice and latent heat of vaporization are also very comparative. Right? Setup is different. Setup special things. But as a principle, as a concept, they are very much same. Right? Logics same. Okay. Apparatus right. Then take down the apparatus. Take down the apparatus. Right, make a label thermometer. Thermometer. This is a glass tube. Make a this is a glass tube. This is a glass tube. Right? Bunsen burner. Tripod. Right? Then steam trap. Thermometer again. Thermometer. Right? This is called the bent tube. Bent tube. Right? Calorimeter. Right. This is outlet of water. Right. Take it down. Only the diagram. only the diagram. ටියුටරේ තියෙන එක check කරත් කමක් නැහැ. මේ මම label කරලා තියෙන ටික හරියට බලලා දාගන්න. sheet එක label කරලා නැහැ නේ. sheet එකත් label කරන්න ඕනේ. heat insulated sheet, right? මම මේක කලින් කිව්ව මොනවද හදන්න කියලා. heat insulated sheet made of is either මොනවද කිව්වේ? Regiform or asbestos. කොහොමද? මේකද? ඔව්. හරි. එතනින් steam ගියාට ආයෙත් හොඳ question එකක්. Listen. That's a good question. Listen. Now, if steam goes out from this, right? That is very rare. ඒක rare වෙන්න reason එක මේක, right? Density of steam is less than density of air. Steam කියන එක උඩට යන්නේ. Density of steam is less than density of air, right? ඒ හින්දා මේ steam එක මේක through පහළට යන්න අමාරුයි. Right? It is rare. But even if it goes out, doesn't matter, because what I need is the collected mass of steam into this only. එළියට ගියත් අවුලක් නැහැ. එහෙම යන්නේ නැහැ. ගියත් අවුලක් නැහැ. මට මේකට ඇතුළට ආපු ටික විතරනේ මට මෙතන කැල්කියුලේෂන් එකට ඕනේ. හරි? Doesn't matter. Doesn't matter. I haven't tried on the styre. මේ styre එකක් ගන්න ඕනේ. Sorry. හරි නේද? Finish. Right. Then mention these readings first. After this, mention these readings. Mention these readings. Mass of empty calorimeter with styrer. Mass of empty calorimeter with styrer. මේක label කරලා නැහැ. This one. Wire mesh or the square net. Square net. මෙතන තියෙනවා square net එක. Purpose එක මම කිව්වා. What's the purpose of using the square net? Right, and then label කරලා තිබ්බේ. What's the purpose of uniform distribution of heat throughout the bottom of steam generator now? Right, බාන මොනවා හරි මිස්සලා තියෙනද කියලා labels නෑ නේද? මිස්සලා තියෙනවා නම් කියන්න. නේද? Right, mention readings. First one. මේ හැම reading එකක්ම මම මේ හැම experiment එකකම දුන්නේ that is in the correct order. ඒක තමයි sequence එක. ඒතර sequence එකත් එක්ක questions වල අහනවා. ඒතර sequence එකව දැනගෙන ඉන්න ඕනේ. Right? Then first one, mass of empty calorimeter with styrer M1. Second one, mass of water, comma calorimeter with styrer. Mass of water, comma calorimeter with styrer. M2. Right, next one. Initial temperature of water. Initial temperature of water. Initial temperature of water, theta 1. Theta 1. Right, next one. Maximum slash final temperature of water. Maximum slash final temperature of water. Right, theta 2. Theta 2. Then final mass of system. Final mass of system. Final mass of system, M3. M3. Right, heat capacity specific heat capacity of water, CW. Specific heat capacity of water, CW. Specific heat capacity of water, CW. Then specific heat capacity of calorimeter. Specific heat capacity of calorimeter, CS. Right. Next, specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Right? L, capital L. Capital L. Capital L. Right? Okay. Right. अभी मेथड ले लो मैं केलिमा कैलकुलेशन के मेंशन करो. Right. Write down method. 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 First point. Measure the mass of empty calorimeter with stirrer. Measure the mass of empty calorimeter with stirrer. Right. Next one. Next point. Fill water up to 2/3. अरे कालिंग आगे में दमाए होंगे. Fill water up to 2/3. Fill water up to 2/3 of height of calorimeter. 2/3 of height of calorimeter. And measure the mass within brackets M2 and measure the mass within brackets M2 and initial temperature of water measure the mass M2 and initial temperature of water within brackets theta 1. Right, next point. Insert steam to calorimeter through steam trap. Insert steam to calorimeter through steam trap. And well stir the system. Well stir the system. Until temperature is increased significantly. And stop flow of steam. Right. Next point. Now in this one thing special. Now, even though you stop stream right now, right now, the temperature is not going to be stay unchanged right at this point, because there are stream that has already come into the calorimeter, even though we have stopped from here. Right? ඒ ටිකත් mix වෙන්න දෙන්න ඕනේ. ඒතොර මෙතින්ට පස්සෙත් තව පොඩ්ඩක් temperature එක, even though this is disconnected, temperature of the calorimeter rises. Right? මේකට ආපු stream ටිකක් තියෙනවනේ තාම. අපි මෙහෙන්න මේක දැන් ගලවන්නේ. right? මෙහෙන් ගලවන්න කියලා කියන්නේ දැන් මේක අයින් කරනවා. මේ trap එකෙන් මෙහෙම අයින් කරනවා. මෙහෙම trap එකෙන් අයින් කරාට මෙතන තියෙන stream එකක් තියෙනවා. ඒ stream එක තාම add වෙලා නැති, mix වෙලා නැති stream එකක් තියෙනවා. Then it is going to increase the temperature by a bit. Right? එතකොට ගලවපු ගමන් temperature එක අරගෙන හරියන්නේ නැහැ. You have to wait until it rises to the maximum point and have to take the reading at that particular point. Right? Next point. Wait until right? Wait until temperature of water rises to the maximum value, and take the final temperature within brackets theta 2, and take the final temperature within brackets theta 2. Right, next point. Measure the final mass of system. Measure the final mass of system. M3 within brackets M3. Right, next point. Since there's no heat loss to environment, put a comma and mention this. Liberated heat by steam equals absorbed heat by water plus calorimeter. Right? It was the equation. Plug those values and get the equation. Liberated heat by steam. Right? Absorbed heat by water plus calorimeter. Liberated heat by steam, absorbed heat by water plus calorimeter. Right? Equation yaad liya. Finish. Right, write down below. Calculate L, calculate capital L, using the equation. Calculate capital L using the equation. Right? So basically that's it about the experiment. Right? Remarks in about about the experiment. That's it. Right? May experiments are mulim method de walla innode vankiwe. That's the easiest way when you study thermal experiments. Mega set and thermal vitarai. Right? Thermal වල එහෙම තමයි හැටි. Right? දැන් මේක optics වල කරන්න යන්නේ බා optics වල theory එක කොහොමද ඕනේ. Right? ray diagrams තියෙනවා, ray diagrams ඕනේ. Convex lenses වල එහෙම ඔය තියෙන special cases තියෙන, and especially virtual images in concave lenses අර එහෙම ඕනේ parts තියෙනවා නම් ඒවා ඕනේ. මේ thermal වල when you study thermal experiments, the easiest thing is first go through the theory, right? Understand the theory first, right? Theory එක බලන්න, readings එක බලන්න, then understand the remarks, right? අර ඒ flow එකේ ගියාම වැඩේ lazy. theory එක තේරෙනවා කියලා කියන්නේ calculation එක කොහොමද කරන්න පුළුවන්, but always in the experiment there will be questions about the other things, why this is done, how this is done, right? ඔය වගේ questions ආනවනේ එනකොට අන්න ඒ ටිකට answer කරන්න overall idea එක තියෙන්න ඕනේ. overall idea එක ගන්න මුලින්ම concept එක තේරෙනවා නම් අර idea එකෙන් 50% නිකන් ඉවරයි. 50% නෙමෙයි ඊටත් වැඩි. like 60% 65% of the thing is over if you know the logic and the concept here. ඊට පස්සේ ඒකට feed කරගන්න තමයි තියෙන්නේ මේකේ වේ. right? okay, then let's go to remarks. right, listen. in steam generator steam generator කියලා කියන්නේ this is only unique, this is unique only for this experiment. එහෙම ඒවා ඉතින් වෙන මොකද යනවද? steam generator එකක් තියෙන අපේ out of all 38 experiments only steam generator we have is the one here, right? එහෙම unique ඒවා තියෙනවා ඉතින්. right, listen. now when this is heated to 100 degrees Celsius, then මේ water ඔක්කොම ටික 100 වලට boil කරන්න ඕනේ. when it is heated to 100 degrees Celsius, right? what can you say about pressure inside this steam generator? does it increase or decrease? pressure inside generator, steam generator, right? මේ gas එකත් temperature එක වැඩි කරනවා, මෙයත් temperature එක වැඩි කරනවා. what about pressure? it's approximately a constant volume. then when temperature increases, pressure increases, right? when pressure increases, there's a risk of exploding this, right? steam generator එක explode වෙන්න පුළුවන්, right? ගොඩක් අපි heat කරනවා. this is starting from room temperature and heated to 100 degrees Celsius, right? then there's a risk of exploding this if pressure is excessively increased, right? ඒකට තමයි මෙයා ඉන්නේ. now what this is done is, right? see, this is open, glass tube is open, and then from this end this is open to atmosphere, no? this is open to atmosphere, no? then without increasing the pressure inside this, pressure is controlled through this. මෙතන තියෙන්නේ atmospheric pressure නම් දැන් මේකේ මේ හැරෙට එනකම් atmospheric pressure එක ඇවිල්ලානේ තියෙන්නේ. හරිද? then pressure is controlled using this. then there's no risk of exploding this even if you heat this beyond 100 even. 100 වලින් උඩට රත්කත් අවුලක් නැහැ. pressure එක වැඩි වෙන්නේ නැහැ. pressure එක වැඩි. ඒ කියන්නේ මේක seal වෙලා තිබිලා pressure එක වැඩි වුණොත් තමයි explode වෙන්නේ. right? to control it we have this tube, right? that's a very popular question නා. ගොඩක් ඒවා අහලා දෙනවා. ඇයි ඒ tube එක දාන්නේ කියලා මතක තියාගන්න ඉතින්. ඒක මේකට විතරක් unique එකක්. reason is that, right? නැත්තම් pressure එක increase වෙන එක අපිට control කරන්න බෑ. එහෙම වුණාට පස්සේ වැඩේ control. temperature එක විතරක් increase වුණා නම් අපිට ඇදිනේ. pressure එක ඕනේ නැහැනේ. the actual thing is that even though I need to increase temperature here, if this was sealed, pressure automatically increases. But I don't need to increase pressure, right? A control කරන්න මෙයා use කරනවා. හරිනේ? right, first point the glass tube is used to control pressure inside steam generator, to eliminate the risk of exploding it when heated. right? next point heat losses to environment by conduction, convection and radiation. should be minimized as mentioned before. Right? අර කලින් කියපු ටිකම තමයි ඔතේ. Should be minimized as mentioned before. Right? Next one. Heat compensation method is used. Heat compensation method is used to minimize the error caused due to transfer of heat with environment. Right. Next point. A heat insulated sheet is used. A heat insulated sheet is used to prevent direct heat from Bunsen burner reaching calorimeter. Right. Listen. This is a good point. Listen. What is the boiling point of water? 100. Right? 100 is at which pressure? Atmospheric pressure. Right? When pressure changes, both boiling points, melting points changes. Right? කොහොමද ඒක change වෙන්නේ? When pressure decreases, boiling points decreases. It comes down. Right? Thermal කරලා දීවා. When pressure decreases, boiling points decreases. When pressure increases, boiling points both boiling points, melting points both increases. Right? Now we have to make sure, this steam is doing the state change at 100, no? Right? 100 කියන එක use කරන්න නේ. කළා තියෙන්නේ. Right? If the pressure of steam which is coming into this is greater than atmospheric pressure, right? Then boiling point won't be exactly 100, it will be deviating from 100. Right? For that, what we do from the setup is, right, this tube, when we steam in a tube, bent tube, it should not be immersed in water, because if there is immersed in water, pressure is going to change. Right? Water immersed unot pressure change, right? Water වලින් එන pressure එකක් එනවනේ. දැන් අවුලක් නැහැ. Right? මේ තියෙන atmospheric pressure, this is also atmospheric pressure. Right? So therefore this cannot be immersed in this one. Right? එහෙම immerse කරොත් pressure එක change වෙනවා. pressure එක change වෙනවා කියලා කියන්නේ මේක capillary එකක්. මේක පොඩි tube එකක් නේ. ඒතකොට ඉතින් ඔක දැන් හැමදාම connect වෙනවා surface tension. If that is immersed, what happens? Through this capillary tube, මොකද ඒකට කියන්නේ? Capillary rise. පොඩි capillary rise එකක් එනවා. capillary rise එක ආවම pressure එක change වෙනවා. HRG එකක් එනවා. Right? ඒ නිසා immerse කරන්න බෑ. Then if pressure changes, the steam is not going to do the state change at 100. Right? Okay, next point. Bent tube should be fixed close to water surface without immersing in water within brackets if immersed pressure changes so that boiling point changes. So that boiling point changes. Right. Next point. Next point. A shorter connecting tube. Connecting tube කියලා කියන්නේ මේක මම label කරේ නැහැ. මේක තමයි connecting tube කියලා කියන්නේ. A shorter connecting tube. මේක label කරන්න තරම් එකක් නෙමෙයි, but දැන් මම explain කරන්න හැබැයි මෙයා ගැන. A shorter connecting tube. ඔන්නම් දියාගන්න. A shorter connecting tube should be used to minimize. A shorter connecting tube should be used to minimize condensing of to minimize condensing of steam before adding to calorimeter. Right. Next point. මේක purpose එක මම කිව්වා මේක කියන්න හදන්නේ about stream tap. Right. ඒක purpose එක කිව්වා. Now even though we use a shorter tube, right, there are particles which are already converted into water. Then to segregate water and steam, this stream trap is used. Right. Next point. A stream trap is used to segregate condensed water and steam. Right. Within brackets, water goes out from outlet. Water කියලා කියන්නේ condensed water. මොකද මේ water යන්න ඉඩක් නැහැනේ. Condensed water ඕන නැහැ කියලා. Condensed water goes out from outlet and condensed water goes out from outlet and only steam flows through bent tube. Right. Okay. Right. Quickly, let's check what is here. Right. One way to minimize the error due to heat loss is use a polished calorimeter. ඒවා කලින් කිව්වා ඔක්කොම. Right. Cover it with heat insulating ඒ ටික හරියි. Right. ඒ method same හොඳයි. ඉතින් ඕක අර හැම එකටම පාඩම් කරන්න දෙයක් නැහැ. they are same. Right. කොහෙද යවුවත් එකම answer එක ලියන්න තියෙනවා ඔයාලට. In the compensation method ඒකත් same. Since the amount of steam that collects in the experiment is small, මේක ටිකක් හොඳ point එකක්. Listen, since the amount of steam that collects in the experiment is small, care has to be taken regarding the accuracy of measuring mass. Right? That's why I told you triple beam balance is not used here. Right? පොඩි amount එකක් නෙන්නේ. triple beam balance එකේ least count එක එන්නේ 0.1 grams. 0.1 grams. ඒක මදි. Right? 4 beam එකේ 0.01 grams. That's enough. That's adequate. Right? The compensation method is often referred as method of hurry. Okay, so that's it for 5. Any questions? Any questions?
All good.
Right? Right? All good. Right. Experiment 6. Experiment 6. Experiment 6. Right. Write down determination of relative humidity of air. Determination of relative humidity of air. Determination of relative humidity of air using a polished calorimeter. Using a polished calorimeter. Determination of relative humidity of air using a polished calorimeter. Experiment 6. Right? Yeah. Right. හරි මේකත් materials කියලා explain කරන්න. Write down materials and apparatus. Materials and apparatus. This is the simplest one out of all, right? Materials and apparatus. Write down two polished calorimeters. First one, two polished calorimeters. Right? Then ice chips. Ice chips. Ice chips. A net stirrer. A net stirrer. Right? Then two thermometers. Two thermometers. Two thermometers. A glass sheet. A glass sheet. A glass sheet. A glass sheet. Slash heat insulated sheet. A glass sheet slash heat insulated sheet. Right? And finally, two stands. Two stands. Two stands. Right. Two stands. Two stands. Right. Listen. Right. Now we have two identical calorimeters. Listen. We have two identical calorimeters. Look at the board. One is here, and the other identical calorimeter is here. Right? Then one calorimeter is only one calorimeter is filled with water, right? And let's say this thermometer is T1, and nothing is inside this one. Say that is T2 thermometer. Thermometer is T2, right? Listen. Now, what we do is adding small chips of ice into this one by one. Adding small chips of ice into this one by one, right? And let it melt inside the calorimeter, right? And now initially they are polished surfaces, right? Polished surfaces, so they are shining surfaces, right? Now when I add ice and let it melt, then temperature of system decreases. At some point, when temperature of system decreases below dew point, dew forms, no? When dew forms at the surface. When dew forms at the surface, right? Dew form, you know. When dew forms at the surface. When dew forms at the surface, what can you say about the shine of the surface? Shine reduces, no? Right? You can cool drink, right? When dew forms, shine reduces, right? That is called tarnishing. Technical term is tarnishing. Tarnishing කියන එක අහලා තියෙනවද? ටානියා දන්නවා. tarnishing දන්නේ. tarnishing කියලා කියන්නේ. right? Reducing that shine. Tarnishing. Right? When it is start to reduce the shine. Right? Which means dew forms starting no. Dew forms starting කියලා කියන්නේ at which point the system is. When dew forming starts. මේක දිහා බලාගෙන ඉන්න ඕනද? You are going to observe this while melting ice. And you will notice a point where the shine of the surface is, right? Shine of the surface is decreasing, right? දැන් අපිට මේක දිහා විතරක් බලන් ඉඳලා shine එක ගැන idea එකක් ගන්න බැරි හින්දා තමයි identical එකක් තියන් ඉන්නේ. නැත්තම් දැන් thermometer එකක් නිකන් මේක අස්සර දාන්න වැඩක් නැහැ නේ. right? thermometer එක එළිය තියාගත්තත් temperature එකෙන් room temperature එක ඕන මෙසේ කරගන්න පුළුවන් නේ. right? Identical එකක් තියාගෙන ඉන්නේ. Then we can easily compare this one with the tarnishing one. right? එතකොට මේකේ තියෙන original surface එක තිබ්බ විදිය. එතකොට මෙයත් එක්ක difference එකක් ආපු ගමන් ටක් ගාලා අපිට මේක notice වෙනවා. right? That is the point where dew forms starting to form dew means that is a dew point. right? මෙයාගේ reading එක ගන්නවා. that is a dew point. that is a dew point. dew point එක ආවනේ. taking the reading from T1. right? reading of T1 when reading of T1 thermometer T1 when dew forming starts, right? Let's say theta1, right? Then after some time, right? ඊට පස්සේ ඒක කලින් now when dew forms we will stop adding ice. When dew forms we will stop adding ice. Then after some time the system again absorb heat from environment and going to reach the room temperature. right? දැන් මේක cool වෙලා තියෙන්නේ. cool වෙලා තිබ්බට ඉතින් මෙයා room temperature එනවනේ. when it is coming back to room temperature, what can you say about dew? then dew already මේක තියෙනවා. now when it is coming back to room temperature, what happens to this dew? forms dew. it vanished. right? it vanished. right? දැකලා තියෙනවනේ. dew එක අනිත් පැත්තට vanish වෙනවා. cool drink එකක් ආයි බුද්ධි හොඳට බලන්න ඉතින් ඔය මම thermal එකක් දීලා ඒකට කිව්වා. cool drink එක ඔයා තියාගෙන ඉන්නකොට cool drink එක තියපුවාම dew forms, right? and if you keep it in the environment for a longer time, then again dew is vanished. right? then again we are observing this for the point where dew vanishing starts. right? dew vanishing starts වෙනවා කියලා කියන්නේ again you are going to see the shine of the calorimeter here. right? ඒ temperature එකක් ගන්නවා. then reading of T1 when dew vanishing starts. right? say that is theta2. right? starting to vanish dew means what kind of a temperature is that with respect to dew point? That is also almost dew point, a little bit above dew point. right? even if 0.0001 degrees above dew point, it starts to, right? that is almost a dew point again. the readings දෙකක් තියෙනවානේ. then as a more accurate dew point, we are getting the average. මේ දෙක average එක ගත්තා නම් හරියනේ. when the average, then dew point of this day is, right? dew point of this day is, then dew point of the day is theta1 plus theta2 over 2. dew point එක දන්නවා. right? dew point එක දන්නවා. if dew point is known, right? if dew point is known, we have a standard table, right? of saturated vapor pressures with temperature. right? saturated vapor pressure table එක කියලා එකක් තියෙනවානේ. standard table එක. then if dew point is known, we can find saturated vapor pressure at dew point. if room temperature is known from T2, that's the purpose of using T2 to measure room temperature. if room temperature is known, we can measure room temperature using T2, and using the standard table we can find saturated vapor pressure at room temperature. then relative humidity is given by, what's the equation using pressures? relative humidity is given by saturated vapor pressure at dew point. right? saturated vapor pressure at dew point over saturated vapor pressure at room temperature into 100%. මේ equation එකට දානවා. දාලා මේක හොයාගන්න. right? That's it. Right. Make it right. Take it down. ඊට පස්සේ මේ glass sheet එක use කරන්න මොකද කියලා කියන්න බැරනවනේ. Listen. When dew forms, right? මේක ඔයගොල්ලෝ දැකලත් ඇති. When dew forms, even if you blow to dew, have you seen that dew can be vanished? It vanished if you blow into your drink or cold drink or whatever it is. ඒක notice කරලා නැද්ද? නැත්තම් ඒක බලන්න මේ dew එක හැදුනට පස්සේ ටිම්බල dew වුණා යවන්න පුළුවන්. Why? Excel අපේ Excel එකේ යන්නේ heat එකක් තියෙනවනේ. In Excel layer it has some small amount of heat. ඒ heat එකත් එක්ක dew එක අනිත් පැත්තට vanish වෙනවා. ඒතර ඒ Excel heat එක මේකට mix වුණොත් ඒ කියන්නේ මේ dew එක vanish වෙන if Excel heat of the person who is doing the experiment, right, is going to impact here, then these readings are going to be erroneous, right? Then to prevent that Excel heat or the Excel air from the mouth of the student or whatever the person who is doing this, a glass tube is placed, glass sheet is placed in between the mouth and the calorimeter. Right? Glass එකක් ගන්න transparent වෙන්න හින්දා. මොකද ඒකේ purpose එක මේ Excel එක prevent කරගන්න විතරනේ. Right? නැත්නම් අර regiform asbestos use කරන්නත් පුළුවන්. ඒ මවුලක් නැහැ. Right? ඒතකොට ඉතින් අපිට මෙහෙම පේනවා. එහෙම ලොකු ප්‍රශ්නයක් නැහැ. අර glass එකක් use කරන්න ඒක transparent කරන්න හින්දා. Right? මොකද Excel heat එක ගියත් even if that small heat is going to mix here, it matters. Dew නේ තියෙන්නේ. Dew කියන එක නා මාර sensitive. ඒතකොට ටක් ගාලා dew එක අනිත් පැත්තට vanish වෙනවා. Vanish වෙද්දී ඔය temperature එක measure කරොත් that is not just due to environmental conditions. ඒතකොට අපි අර external condition එකක් දීලා. Right? ඒතකොට දැන් ඔක කරන්න ගන්න. breathe in breathe out කරන්න නැතුව ඉන්න බෑනේ. ඒ හින්දා glass sheet එකක් use කරනවා. Right? Okay. Make it take it down. ඔය guide එකේ නේද? guide එකේ දීලා තියෙන මේ style එක වැරදි. That should be a net style, right? Ice chips නේ දී කරන්නේ. Right? ඔය පොඩි mistakes තියෙනවා ඉතින් ඒක බලා ගන්න. Right? මේක label කරන්න. net style. Right? මේ තියෙන ice chips. Ice chips. Right, maybe polished calorimeters. Polished. Right, T1, T2 කියන්නේ thermometers. Mercury in glass thermometers. Right. Finished. Right. Mention method.
Do we need to write all the materials or some when asked?
I hope I understood the question. Right? If all are asked without mentioning as items and instruments, right? You have to write everything. Items, instruments කියලා මෙයා කරොත් instruments එක වෙනම ලියන්න ඕන, items වෙනම ලියන්න ඕන. Right? Instruments කියලා කියන්නේ ඔය triple beam balance, right? ඊට පස්සේ thermometer instrument එකක්. අර measure කරගන්න use කරන ඒවා තමයි instruments. Items කියලා කියන්නේ styrer, right? ඒවා items. ඊට පස්සේ මේක නම් වෙන items නෑ. ඊට පස්සේ අර කලින් ඒවා තිබ්බේ filler papers, right? එහෙම items and instruments තිබ්බොත් ඒ දෙක වෙන් කරලා ලියන්න නැත්නම් ඔක්කොම ලියන්න ඕන. Right? සමහරලාවට මේ diagram will be partially completed or the items will be labels will be partially completed. You have to complete the rest. Right? ඒ වගේ cases වෙනවා.
For apparatus with higher number of materials.
Yes. If all are asked, we have to write all, right? But usually, how the questions are coming is as partially completed diagrams with labels. එතකොට අපිට ඉතුරු ටික තමයි complete කරන්න තියෙන්නේ. දැන් අර කලින් කරපු එකේම steam generator side එකේම අඳින්නෙම නැතුව diagram එක දෙනවා. දැන් calorimeter විතරක් දීලා. Then you have to draw the steam generator and label it. ඒ වගේ. හරි. අර total එක ඒ කියන්නේ මුළු entire diagram එකම දෙන්න නැතුව ඔක්කොම labels උත් අහන questions නම් ඇත්තටම එහෙම තිබිලා නැහැ. right partially තමයි එන්නේ. right හැබැයි ඔක්කොම දන්නේ නැතුව ඔයාලට අර නැති කැලලට ලියන්න බෑ. එහෙම තමයි වෙන්නේ. right okay method take two identical calorimeters take two identical calorimeters and fill water into one calorimeter and keep the other one empty insert thermometer T1 into water and T2 to empty calorimeter. Right, next one. Add chips of ice or ice chips. One at a time. right අර හැම වෙලේම 1 by 1 දාන්න එක කලිනුත් එහෙම තමයි. one at a time. නැත්නම් අර අපිට temperature control කරගන්න බෑ. දැන් එකපාර ice cube එකක් දැම්මොත් එම dew point එකත් ගිහිල්ලා dew point එකටත් below ගිහිල්ලා හොයාගන්න බැරි වෙනවා. right one at a time while well stirring right next point observe the surface of calorimeter and identify the point where tarnishing of calorimeter surface calorimeter ඕනේ නැහැ tarnishing of surface ඒ word එක ඒකට තමයි term එක ඒක මතක තියාගන්න that's a term tarnishing at the point where tarnishing of surface starts right within brackets forming dew starts right take the reading of T1 within brackets theta 1 right next point stop adding ice stop adding ice and let calorimeter with water returns to room temperature and identify and identify the point where shining of the surface is regained within brackets vanishing dew starts right, vanishing dew starts. Take the reading of T1 within brackets theta 2. Take the reading of T1 within brackets theta 2. Take the reading of T1 within brackets theta 2. Next point. Take the reading of T2. Take the reading of T2 and reading of T2 within brackets mention it as theta 3. Right. Then mention this as calculation. Theta 3. Reading of T2. And then T2 T2 is going to measure which temperature? Room temperature. Right? Room temperature one mada method table lekada ega measure karaga. Right? Okay, balan table lekin. Right. Go to calculation. Right? Write down. Mega. Therefore, dew point equals theta 1 plus theta 2 over 2. Dew point is theta 1 plus theta 2 over 2. Dew point equals theta 1 plus theta 2 over 2. Right? It was a room temperature kat methane liya na. Right? It has a room temperature. Room temperature equals theta 3. Right? Room temperature equals theta 3. Right? Next point. Check the respective saturated vapor pressures. Check the respective saturated vapor pressures. Check the respective saturated vapor pressures from the standard table. Right. Now for dew point, the relevant saturated vapor pressure is, let's say, P0, right? P0 dash Q. And for room temperature, let's say saturated vapor pressure is P0 double dash, right? मैंने आप mention करा, right? If relative humidity of atmosphere is Y, put a comma and mention the equation. Y equals saturated vapor pressure at dew point. Here, saturated vapor pressure at dew point. Saturated vapor pressure at dew point. And here, saturated vapor pressure at room temperature. Right? Times 100%. Right? Kilima equation then Y is given by saturated vapor pressure at dew point P0 dash at room temperature P0 double dash into 100%. Calculation. Right. So that's basically it. Right. Let's see the remarks. Remarks. Mention remarks. 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 Right. First one. Two identical calorimeters are used. Two identical calorimeters are used. Two identical calorimeters are used. Two identical calorimeters are used to compare between surfaces, to compare between surfaces when tarnishing, to compare between surfaces when tarnishing. Right, next point. Both calorimeters should be cleaned to remove dust, should be cleaned to remove dust, should be cleaned to remove dust before starting the experiment, to remove dust before starting the experiment. Next point. A glass sheet is used. A glass sheet is used. A glass sheet is used. A glass sheet is used in between the mouth and calorimeter. In between the mouth and calorimeter. To prevent exhale heat, to prevent exhale air, to prevent exhale air, to prevent exhale air reaching calorimeter. Right. Next thing, listen. When it comes to forming dew, humidity, right? What are the other external environmental factors matters? Wind speed, right? Wind speed matters, right? Since wind speed matters, when you do the experiment, right? Even a fan cannot be on in the room that you are doing, right? Lab එකේ නම් කරන්නේ lab එකේ fan එකක්වත් දාන්න බෑ, right? If your lab is air conditioned, ඒතර අවුලක් නැහැ. ඒත් අවුල. ඒතර හොඳටම අවුල. ඒතර හොඳටම අවුල. What is done by the air conditioner? It absorbs water vapor, right? ඒ වුණොත් dew එක අරයටත් absorb වෙනවා. ඒතර හොඳටම අවුල, right? ඒතර air conditioners, fans, ඊට පස්සේ cutting උලන් මොකුත් බෑ හොඳේ. දැන් ඒකනේ glass sheet තියලා තියෙන්නේ, right? ඒ කියන්නේ පිබ මේක කරන්න බෑ. කරනවා නම් හරියට ඒ කියන්නේ මොකුත් නැතුව it should be a closed room. The other thing, right? ඒ කියන්නේ windows අරගෙන දාඩියයි කියලා එහෙම බෑ හොඳේ. එහෙම වුණොත් ඉතින් වරදිනවා. ගන්න පුළුවන්. වරදිනවා. යාර එළිය තියාගෙන එහෙම බෑ. මේක closed room එකක. ඒ කියන්නේ seal room එකක කරන්නත් ඕනේ. Next point. Experiment should be carried out. Experiment should be carried out. Experiment should be carried out. Experiment should be carried out in a closed room. In a closed room. In a closed room. In a closed room where all fans, air conditioners should turn off. Right. මේක තියෙන විදිය ගැන idea එකක් නැත්නම් ඕනනම් මේකත් optional ඕනනම් අරගන්න. මේ sheet එක තියෙන විදිය. Right? Glass sheet is kept here, right? And you are here. Right? තමයි. Right? මේ තියෙන මේක. ඕනනම් විතරයි. Right. ඕනනම් අරගන්න. Next one. Now just by the first round, if you fail to identify or if you are not sure about the starting point of forming dew, right? ඒක එකපාර සමහරලාට දැන් හොයාගන්න බැරි වෙනවා, right? So in that case, have to repeat this and take the average of all the readings. Right? Right? Next point. Next point. Next point. This procedure can be repeated. This procedure can be repeated. This procedure can be repeated for several rounds. For several rounds. For several rounds. For several rounds. To get the average. To get the average. For better identification. For better identification. Of tarnishing. For better identification of tarnishing. Tarnishing temperature, better identification of tarnishing temperature. Right. And the other thing, only ice chips can be used, right? Large ice cubes, right? If ice cubes are put, right, at the very point that you are putting it in, instantly, the tarnishing starts, right? Ice cube and then dapuan tanggal cool, right? Dapuan cool, or the specs dana, the specs dala, AC kindala, elite, tanggal glass, okay, instantly it happens. Instantly it happens. Right? So the cool drink at the very moment that you take it out from the freezer, right? It happens. Right? So time dew point chips next point. Next point. Large ice cubes are not added. 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 Because it starts tarnishing instantly. Because it starts tarnishing instantly. Because it starts tarnishing instantly. It starts tarnishing instantly. Right. That's it. Quickly see what's given. Right. In selecting the glass sheet to prevent exhale skirting the calorimeter, take care to decide on its dimension so that it would not obstruct stirring but would have the common sense would have the size sufficient for the purpose it used for. Right? Again, ස්ටර් කරන්න බැරි වෙන තමයි ඉතින් ලොකු ග්ලාස් ෂීට් එකක් ගහගත්තොත් ඉතින් කරන්න බෑනේ. ඒක තේරෙනවද? දැන් මෙහෙම එකක් තියාගෙන මෙහෙම කරන්න පුළුවන් වෙන්න ඕනේ. right ලොකු ග්ලාස් ෂීට් එකක් නම් තියෙන්නේ ඉතින් තව එකෙකු වෙන්නේ නැහැ ස්ටර් කරන්න. right ඒක normal නේ. හරි. That's it. Okay, any questions? Any questions or any doubts from all 6 experiments we discussed? Right, this is everything about thermal. Right, කොහොමත් මේ 6 එකක් එනවා හොඳේ දැන් benefit එක. Right, you are going to get one experiment out of these 6 as question 2. Right, දැන් අද මේක තේරුණා නම් අමතක වෙන්න කලින් ආයි බලන්න. Plus now always when you are writing papers, right, you are writing this thermal structure now, right? Then don't let it fade away from your mind. Right, just 9 weeks. Right, දැන් අද තේරුණා නම් ඔය විදියටම exam එකට යනකම් ඔක maintain කරන්න. Keep that momentum. Right, any questions? No? Right? Online. We should get dew point. Listen, we should get dew point value and room temperature from the readings we got in experiment. Yeah, these two. T1, T2. Dew point is just color. Dew point is θ1 plus θ2 over 2. And room temperature is θ3. Reading of T2. What else? Anything else? Anything else? All good. Right. Okay then. All good. Right. Then if no questions, we'll wind up. Right. Okay. If no questions, we'll wind up. And I'll be conducting another seminar. I'll be conducting another seminar on electricity experiments also, and going to finish off all 38 experiments. Right. Then electricity na tu anit ඔක්කොම ටික කරලා නේද the last one will be electricity, right? And once electricity is also done, all 38 experiments are discussed as live seminars, right? And I'll keep this video on YouTube, right? chapter කරලා තියන්නම්. ආයි ඕනොත් ඇවිල්ලා බලන්න. නැත්තම් දැන් 8 hours විතර තියෙනවනේ. ඔක බලන්න බෑනේ. මේ අනිත් ඒවා chapter කරලා ඇත්තේ. chapter කරලා තියන්නම්. ඕන experiment එකක් තිබ්බොත් ඇවිල්ලා බලන්න පුළුවන් වෙන්නේ. right? Okay then. If no questions, we'll wind up, right? So stay safe. මං කිව්වනේ එල්ලිනොත් වෙනවා. Stay safe. වැඩ ටිකක් කරගන්න ඕනේ. පරිස්සමෙන්. Right? Stay safe and work hard. Right? Okay. Then see you today. See you today. Right. Okay then. Good night, good morning, and goodbye.